Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love.
Welcome everybody. We are starting, but before the start, just wanted to highlight that there are 3 stages here. This one outside and one upstairs. But okay, let's start. I'm Gleb from 1inch. At 1inch, we are pretty serious about security. Like security is our top priority. So I am pleased to introduce a series of talks that will highlight approaches, tools, insights of how to build DeFi secure and be confident that you will never be hacked. So our first speaker is Yuri Tkachenko from LiDAR. He will introduce insights on the revolutionary LiDAR v3 protocol. Welcome, Yuri.
Tonight we will fight for the right to
Hey.
stay alive, 'cause you
Thank you all for coming so early here. Let's see if it works. Do we have a problem here with slides or? Different one. Okay, so let's start. I'm here today to present you a LiDAR v3 upgrade for I think one of the biggest upgrades in the protocols we have lately. And so let's start. My name is Yuri Tkachenko. I'm a head of DeFi engineering at LiDAR, and also I'm a LiDAR DAO contributor, and also I'm one of the developers behind the LiDAR v3. So kind of multitasking guy. And thank you for listening to me. So let's start with what LiDAR is. LiDAR is a liquid staking protocol, the biggest one in Ethereum. We currently have TVL of 8.6 million ETH. And at the same time, LiDAR is a middleware that connects people with funds to node operators that actually do the staking. And one more thing that is very important, that LiDAR is a DAO. So all the code and policies are controlled by LiDAR DAO, and all the upgrades are done via LiDAR DAO votes. And so, what is LiDAR v3 in compared to LiDAR v2? It is a major upgrade, and a major upgrade in the philosophy of LiDAR, because LiDAR becomes from middleware grows into staking infrastructure, allowing anyone to have its own like small LiDAR pool setup that actually will benefit of using STEE's liquidity that is widely adopted among the DeFi. We plan to have like 2.5 million STEEs in those vaults after the launch, and yeah, I think it's pretty impressive. Yeah. So, what is V3 from the technical perspective? It's not a separate deploy of protocol like in some DeFi protocols. They just copy and do a new setup. We had to evolve our setup because we are staking providers. So we keep LiDAR v2, and right now it's called LiDAR Core Pool. And it basically stays the same, providing this one-to-one battle-tested staking. Like one-to-one, I mean STEEs to ETH staking. And we extend the protocol with a new layer called ST vaults. Those vaults address things that actually stop people from using like a core pool, because sometimes they need like ability to choose another operator, ability to choose like DVT, or the ability to have a compliance, to have some specific setup on top of operators. And maybe they want to adjust some features like restaking, or like some sidecars like MEV or something else custom that we don't support in LiDAR pool. So with those ST vaults, we have like an ability to have custom strategies for custom configuration of the staking like infrastructure on demand. So we have an option to do different DeFi strategies like looping or farming incentives, like something like this. And this brings us closer to institutional vaults because of better compliance and because of providing a top-level liquidity we have in the DeFi. So just to understand how it all works, this is the core mechanics behind the LiDAR v3. So staker comes to LiDAR right now and use only like LiDAR v2 module, and will be able to stake with like ST Vaults marketplace, where any like node operator can come and create its own vault. Like node operator, inst providers, and anyone like can create its own vault. They are permissionless. And the same at the same moment, node operators can share to be in a core pool or to be presented in the marketplace. So they can have optionality to like participate in the different setups, whatever is better for them. And now let's talk what's important about this update for LiDAR. So as I told you, it's a evolution from middleware layer into staking infrastructure. And Steve token right now it's one-to-one, but it will be over collateralized because of the vaults, because of the vaults reserve ratio we have. It is very important to know that vaults are isolated, so they have all risk assessment framework for each like individual vault, and they don't affect Steve's holders from the pool. The design of the vaults like never affect. One of the invariants we have like never affect the Steve holders on the core pool. ST vaults are permissionless to create, so anyone can come do its own setup, like agree with node operator, bring your own validators and so on, and work with vaults permissionlessly. Up to the moment when they want to have a liquidity, there is a like security issue. I'll talk later about this, but overall, like it's permissionless, and the vaults are designed that way that not like owners of the vault can at any time disconnect and decify the vaults to take the collateral back without if they will like feel that DAO can affect them somehow. So they will like see malicious action or malicious proposal for DAO. They can just immediately escape with all their funds, so DAO won't block them. This is one of the crucial designs because it's very important for our partners. So, this is a pretty big update. You can see by the timeline, it took like 17 months to develop. We had like started in June 24th, and like we plan to launch on December 25, but it's not like finalized yet. So during the development, like it's pretty much waterfall stuff. Like usually, like we have specs, smart contract development, tooling development, and test nets running, plus audits and plus upgrade preparation. The part it's required by DAO because we cannot like just deploy. We need to like wire everything to the DAO. One interesting thing here, you can see that we have like 8 DevNets. The DevNets is the custom protocol setup we have. It can be on like Ethereum testnet, like Hudi or Haleshki, or it can be local also. I'll come to it later a bit. So just for the curious people here, it's the stats we have, like 17 months, 15K lines of code in smart contracts. I think it's an enormous amount it's just doesn't fit in my head. 3.5K tests, 140 hours of internal like synchronous review. So it's not like when reviewing by one person. When we collect together as a team and review the code. So again, as I said, 8 private DevNets, 3 public test nets, 4 auditors, and we actually recently got this unicorn from 1inch. If you are like wondering where the unicorn from 1inch disappeared, it came to our pull request because GitHub doesn't even open it. So you cannot see this request. It's like 55,000 lines of code added, like 40,000 K deleted. So yeah, it's huge. So it was like a marketing stuff. So now let's dive into the process. And let's start exactly with the process, because if you don't have like a process of shipping the upgrades, you will screw it up pretty much eventually. But with a solid process that actually battle tested, I'll tell you a bit more about this. We can like guarantee that our approach to the upgrades is pretty secure. We control all the like stages of development, deployment, and verification of the upgrade. So we have a special framework, I would say, in DAO that helps, like it can be like adopted by any protocol to be used to do a secure upgrades. So more of this on this will be, Kate will have a talk tomorrow about this layered defense and how it saved Lido from, like, if you know, on dual governance stuff. So I'll move forward to the specs and research. So I think all of you, because you are researchers, like security guys here, you know that your spec should be resilient against attacks. You should focus on main actors who could be malicious. Don't bring like a market inside pool. But what I want to emphasize here most is that you need to focus on those scenarios and flaws that actually should never happen, and you should put a lot of effort to protect your code against something that would probably never happen, but it should be there to make it never happen. Like I don't know if you got this, but like designed for failure, not for the happy path. Also, the key ideas we had during the spec design were like we need to identify the places where the things can go wrong, like really wrong. If we like have extremely high amount of vaults, it can block our Oracle, for example. So we need to come up with some solution that will unlock it. So we came up with lazy Oracle. If we have like mass slashing events on all the vaults and all the validators in the vaults, we need to internalize the bad debt. If the vaults would deplete the core protocol, we need to have something like some lever to work with it. It is called redemptions. And another approach to this is trust no one. So you basically take all the actors in the system, like whatever, like node operators, vault owners, our own oracles, our own DAO, and you don't trust them. And you try to find the ways how they can be, how they can bring some malicious actions into the setup. So with this approach, like you have, like happy paths here is on liquidity and validators. It's very easy. But then if you dive deeper into the iceberg, you will get more and more stuff that actually comes up that you need to handle. During the research phase, it's crucial to keep an eye on what's going on with Ethereum itself. So, because some of the EIPs will drastically reduce your work, like EIP 7002 is actually execution layer triggerable withdrawals allow us, being vault owners, to extract value from the beacon chain, even if the node operator misbehaves or like we don't like it like acts malicious. So also like 7251 allowed us to shorten the validators because right now we have like a cap for 32 ETH per validator. Now it will be like 2048. And also some things simplified our work with oracles, like pending deposit EIP 6110 allowed us not to have like any workaround for TVL drop validation when the validators are deposited. In the meantime, Ethereum not always ship very like what we want. The main part of the not the main part, but the big part in the vaults infrastructure, like vaults contracts, is called PDG, pre-deposit guarantee, and DSM. It's a core logic. They only are developed to mitigate one thing: the front running for validators. And there is an EAP for this, for fix exact this thing. It's called 7684, but it's stagnant, I think, for 2 years. And the Ethereum Foundation just don't do anything about it. So if you have like connections anywhere, like push them to do something. So, other EAPs we would like to have, and I think they will be beneficial for like everyone, is 7688, when the upgrades, hard fork upgrades won't affect the G indexes. And this one is very heavy one. 7907, the limitation of contract size with 24 kilobytes. So this is just insane. We have like 2 contracts that constantly went over it, and we have to come up with some non-trivial stuff to just optimize the size. Yeah. Also, there are some weird issues with consensus layer stuff that should be fixed, but they are not. So I'll probably skip the development part here because I'm out of time, but just basically use like best practices, all the resources you can get to write a more secure code. The thing that we had problem with is that we use very old Solidity because Lido is a very old protocol by of course crypto standards, and we use Solidity 0.4.24 for because we are connected to Aragon, and we had to keep our tooling in a way it will also work with this old version. But heads up, Hard 3 is coming to fix all the issues for you, and also Certora is working on the bytecode equivalence checker to allow secure contract upgrades from like old version. That's actually like from like just secure contract upgrades, or just, but we will use it probably to upgrade to latest Solidity. So you have like a doc, you have a spec, you have code. Now about testing. So we suggest you do this. First, do a lot of internal synchronous reviews because they are very beneficial. Like you can like work in a team. You just if someone has some idea, they can like share and like or wrap it and find some findings. Another thing that we do as a code review, we have oh, it's called actually I have a tuple here. It's ProSeco, Protocol Security Committee. So they do it's a separate team of people that do a review. They never have like this tunnel vision that we have as a developers. They have an external to the developer team. So, but they are they have a good knowledge about the protocol itself. So they know how to identify issues, and they actually identify a lot of stuff that sometimes missed by our auditors even. So just add a bunch of tests, whatever you can do, like unit tests, integration, acceptance, formal verification if you can. If you can't, just ask someone who can do this. I wouldn't tell you, you all know who can do this. Add fuzzing and solvency tests. One very interesting thing that actually I like suggest you to do is to have a integration test setup that will actually run not only like on fork, for example, but also if you have like if you would like deploy absolutely pure copy of protocol, try to run this test also there to see what will blow, like what will be broken. Again, DevNets, why we had so many. DevNets is like a milestone. You can just fix the code at some level, reflect, see where the problems are, how to solve them, maybe find better approaches to to change architecture sometime. And if official testnets will be like broken, like we had with Haleshki and Sipolia, that's why we have Hoodie right now. Local DevNets are here to save you because we needed to test the Pectra stuff before Pectra came, actually, and we used our own thing that helped us to develop oracles. Oops. Same with testnets. It's just the difference is it's just public, and we can have a feedback from our integrators, like of partners, and the same and collect feedback. So you did the spec, you did the code, tests. Now it's time to bring like a second pair of eye to see that everything is okay. In our case, we worked with Certora, and they did a formal verification for us. We worked with Mixbytes because of their very extended knowledge of the protocol, of LiDAR protocol itself. Consensus made a fuzzing test for us and also a general audit, and Composable Security made an off-chain audit. We also tried to work with AI agents like Nethermind and Savant Chat. So the takeaway there, not ready yet, don't go there. Like, okay, you can try, but don't rely much on them. Okay, here's only one thing is important, like actually this picture. You see, this is from our internal chat. How much like findings do we have? We wanted to bring all the auditors into one place, into GitHub. And I think for us it was a very good experiment, but they probably don't like it, like not all of them. We have, on top of the auditing process, we have the Communify bounty program. I need 1 minute more. Okay? No? Okay. Just from these slides, okay, then you need to understand that you should verify the deployment as the verification of deployment is very important. It was as much important as audit itself. So then, like, you need to add monitoring, and the one thing that actually very important here, if you unsure, just don't deploy anything, because here the price of the error is too high. Sorry for being too long.
Thank you, Yuri. Thank you. Yeah, great. Security first. Okay, our next speaker Our next guest is from Gearbox Protocol. Please welcome co-founder and CTO of Gearbox Protocol, Mikhail Lazarev.
Hello, hello. 111. Hello, hello, DSS. Can you hear me? Oh, yeah, perfect. It works. So cool, so good. Can you switch the slides and I can start? So happy today to present on one of the best security events. Thanks for Sartoras, thanks for Muli for invitation. And today I want to talk about very cool topic because previously we have a value spend and trust crypto your money you are ready to lose. And with institutional upgrades, we are really now focusing on the way how to make things safe, how we can really achieve this institutional grade safety, and at the same time do not lose our decentralization. So let's go. Can you show slides, please? Oh, perfect. So today we will talk about this permissionless governance, how we build and how we start from a DAO managed markets, which were really very, very hard to manage, to fully permissionless system and keep the same level of security. Before we go, wait for. Yeah, so just a brief remind what Gearbox is. We are building a lending protocol which built on totally different ways than other lending protocols. In usual pools-based lending like Aave or Morpho, the first part of the system, you lock your asset, then it's locked on a smart contract, and then you can borrow asset against it. Gearbox works differently. So you as a user could open a credit account, and this is a smart contract wallet which could really execute transaction on behalf of you. When the credit account is open, you deposit your money, you borrow some funds from the pool, and then you can really send different transactions which could be executed on behalf of this smart contract wallet. How we achieve security? Quite straightforward, because when you execute a transaction, we provide some safe approvals, then you really interact with third-party protocol, and after that we have a post-execution hook which checks that you have enough collateral. So literally, if you try to steal money, if you try to do something against the policy, such transaction is reverted. So we really keep all time your credit account is consistent. And of course, it's a pretty brief explanation, but why we are decided to go to permissionless model? Because we have pools, we have multiple collaterals, we have multiple assets in our system, and still it's a pretty hard for DAO, like in Aave, to manage risk parameters, and it was really high limitation for scale. Another part, I totally support the idea of Vitalik that we can grow when we can really involve more players. So institutional players would not trust DAO managed pools. They will decide to switch and manage themselves. So we found it's a kind of straight motivation to do something new and switch the system from existing pools working on with around 400 million CVL into permissionless one without really forcible migration. And there are a few challenges. So what we really want to achieve. The first part, when you allow someone in permissionless way to manage your markets, you have to solve a few issues. The first one, you want to really limit somehow ways how market curators could rug users. It's not only related to the way you want to set time lock, etc. The biggest problem is how to find the way how curators could do this in a flexible way and at the same time have enough power to really interact in emergency situation. There are a few examples why permissionless and what the issues were faced by permissionless adopters. There are a few issues with Morpho and Euler when misconfiguration in price Oracle ended up with huge losses because there are a lot of exploiters who could found that your collateral is overpriced and then you want to try the market as exit liquidity. So what we do and how we achieve this institutional grade safety in a fully permissionless mode. We started from pointing out all possible edge cases. We really have a few months of discussing how curators could, and especially malicious curators, could do some steps to build a honeypot for LPs, for borrowers, and then decide to steal money. We really also design a full emergency tool set which really works well during this XUSD collapse and help invariant group to avoid 30 million loss. And you can see an example. You have a multiple way of this emergency tool set. So in Gearbox, you can forbid token, you can redistribute interest rates and ramping liquidation threshold as a part how you can avoid toxic assets. The second step, which is really crucial, we make a clear separation about roles and scope. So in Gearbox right now, DAO is very limited. And even if a DAO voting system will be fully hacked, there is no direct way to end users and curators. We also add additional layer, additional kind of committee, which is called instance managers or instance owners, who manage price feed whitelist to really eliminate all possible risk with price feeds configuration. And all stuff related to users and their terms, etc., are now under the control of risk curators. No one can really change anything, and they could change markets which could affect some users only via time log. So we also decided to build a full on-chain system which could connect all EVM chains. And to achieve this, we introduced a new concept which is called cross-chain multi-sig. So literally, when DAO make votes, these votes packed into a batches, and then they could really replicate it on each connected chain. This cross-chain multi-sig works as entry point, have the same address on all networks. So literally, all DAO decisions could be really distributed across multiple chains and executed there. So we limit decisions, but we create a robust mechanic how they could be delivered and executed on any chain. And what is also cool that all these batches for which DAO voted is packed into batches, and we use a similar idea like in normal blockchain. So it's connected by previous hash, so there is no way how someone could change the order of batches and really hack the system. And you can see this is a working interface. So right now it's a kind of historical way. The technical multi-sig, now we have a 6-person voted to connect a few networks. It's Monad, Nibiru, and Somnier. And this is signed batches which then were really redistributed across multiple chains. And we do that just to be ensured that these chains are configured properly. We just set a address of wrap token, native token, we set up address of gear token, and the treasury which collect fees. So it's a very good way how we can achieve really flexibility and still take a control of things which could break the system. The second part, and I really enjoy to present it, it's a quite unique and novel concept, which is called bytecode repository. And the easiest way to explain it, it's on-chain GitHub for smart contracts. So what does it mean and how it works? So we decided to eliminate fully all possible risk when developer machine could be hacked during deployment. And if you heard correctly the Lido presentation, the deployment process is the same level of significance that you really do in your normal audit stage. So what we did, we built and put all our bytecode on chain. Literally, we introduced a system that each contract has a different way how we can keep the type of the contract and version control to understand what this bytecode means and which part of the system it reproduces. So literally, you can see a small extract from our linear interest rate model. It has two constants. The first one is version and then the contract type. And it has a very good typing system implemented on the smart contract level. So we have a domain. And domain represents a programmatic interface. So literally, we assume that each domain, and if the contract really inherits this domain, should support this interface. The second part is type, and it also really helps us to understand what this contract does. So in interest rate model, you can have a linear model, fixed rate model, or any others, wherever you want. You have a version control. We have a major version which really related to breaking backward compatibility in many cases. We have a minor updates which also take about feature extents, etc., which could also require some different ways to produce. And for small security patches, we have a patch version, and these things is recognized on Gearbox permission smart contracts automatically. For example, if you really upload the smart contract in bytecode, which has a patch version, this version will be suggested as the latest update to risk curators automatically when they build these markets. But if you update others, it would be all-time opt-in decision by them. And then we build a life cycle to achieve a really sustainability. So it starts from development and uploading your bytecode into bytecode repository. When your contract is uploaded, you as a developer should sign it cryptographically. The same logic like implemented in Apple App Store. So you can't just upload an app, you should really sign it. And then we attract a third-party auditor. So even a core team and we as developers could not upload any smart contracts and go to production. Auditors and external auditors should check the code, add a cryptographical signature, and after that, only after that, it could go to production. So it could really help us to achieve amazing stuff. So right now, Gearbox is maybe the first lending protocols which achieved full autonomy. There is nothing should be done from developer side. Even if we stop operation tomorrow, curators could use it the same way. They could also really replicate the Gearbox protocol on any new EVM-compatible chain. The best stuff here is that we make a step further and we open this Gearbox bytecode repository for any contributor. If you want to build a plugin, if you want to add a price feed adapter to interact with other contracts, you are not limited with our team and special keys. You can also make a suggestion. You can really connect with domain, what I already told, add your own implementation for some feature. For example, you build a price feed to price correctly Pendle tokens or Balancer LP or wherever you want. You upload it, we have a whitelist of auditors, so you pass the audit, and it becomes available for curators. So right now, the protocol itself and whole code base lives on chain. And I know how many developers in the here? Okay, can you raise hands up? Yeah, do you remember this painful stuff when you need to verify contracts and then go to the website and check that the real code you deploy to the system is the same you have in a GitHub? It's a very, very painful way. So we did it a lot. And if you have smart contract like a 27 files, it becomes a nightmare. You can't make a mistake, but you should do this. With bytecode repository, everything is computed and checked automatically because one developer uploaded it to the bytecode repository and then external auditors did the same. They also compile on their machine, then compare bytecode once, and then it stores on chain, so no one can change it. And you can see how it looks. So literally, it's a list of our contracts, version sizes, and who audited them. So you can find all information about each contract in the system. You can change the source code, which is also stored there. You can find all deployed contracts. So if some kind of questions you have related to functionality, you can open it on any network and immediately find what's going on. And the second and the third part of this permissionless stack, what I'm also proud of, it's a price Oracle manager. If you really work somehow with price feeds, you know it's all-time nightmare because price feeds could be manipulated. A lot of security audits told about that. Hey guys, take your attention. This price feed could be manipulated. But it's not only related to the incorrect contract or misconfiguration. The biggest problem that all time these prices are aggregated value. And as you know, there are a few hacks when price got pumped and then it ends up with collateral collateral recomputation with higher price, and the attacker was able to steal the money. In Gearbox, we use a safe prices, so we use a pretty straightforward formula. It's just we pick the minimum between two alternative price feeds when we compute collateral. But to trigger liquidation, we use only main feed, and altogether, it breaks a great shield for LPs. At the same time, it also creates a good way which really protects from manipulation. We built, like in our team, all possible case how things could go wrong. And especially for tokens with low liquidity, it's a very useful case because all time people try to manipulate the value, and the best way and use case of such a system, you can combine a really fundamental oracles and market oracles, because fundamental oracles itself could really deliver some values pretty slow, because the smart contracts could be get hacked and market reacts faster. So if you know right now with XUSD collapse, luckily Gearbox were able to avoid it, the price feed still delivers the price of asset is $1.2 when, for example, a real market price is 16 cents. When you pick the minimum, you really protect your LPs and borrowers of such price manipulation or lack of updates. And you can also find a real example which happened on Euler when it was a $500,000 loss, when Chainlink Oracle get a spike and exploiter immediately used it. So even Chainlink, a very strong brand, a very good, maybe one of the best oracles in industry, could be manipulated somehow. When you pick two alternative opinions and pick the minimum value, it really solves the problem. And you can see so how it looks like. So as a price feed store, it's a really cool idea. We connect each asset listed in Gearbox on a particular network with possible price feed. So literally all time you can see the value, different value. And this price feed connected to each asset has a different methods how they could get value. For example, fundamental market oracles, maybe it could be some external oracle or computed value inside the system. And then this catalog is available for market curators. So we have instance owners who really filter all malicious activity, who really do not allow and check it securely. We also work with auditors teams like Mixbytes and Security to make an additional check, and then our market curators could check from a really pre-checked possible oracles. But if, for example, such oracle would be removed, also markets would not be affected because it's like one-time decision when you use it, and then of course until curator make any change, it would be still the same. And the market management, the last topic I want to talk, I think it's also a very good effort, and it's very, very crucial to make things understandable for humans. When you see a lot of cold data, when you see bytecode, etc., it's a very complicated to understand what's going on. And to do that, we really make a good interface, and each change is showing by really like values what was changed and what's the new value to make a clear picture for curators what they do, because it's like kind of multiple, maybe more than 100 settings per one market. The second part, we built a simulation and test net. So before going to production, we have multiple checks. We really launch a node, and this node really replicate all things in this batch. And then we run tests, not only tests related to unit test or integrational test. The most significant, we want to understand is there is enough liquidity maybe to pass all liquidations in this pool. Are there a way to open credit account for users? And a lot of them. So literally you can see there is a lot of detailed reports what was done and what was wrong. So our goal is to make a clear vision for curator that everything will go smooth and there is no one user account would be affected. if curator is malicious and such kind of data and reports go publicly because we are good friends for transparency, we vote for transparency, of course people has enough time to really close their position or check what they do. And the last but not least, it's a very good way how we really do not trust anything. This interface I showed you, it's a system which has a front end and back end. And in my assumption, each back end could be really compromised. We should not trust any solution like in the Web 2, because as you know, Bybit hack, the biggest hack ever for 1.5 billion, was not related to smart contract. It's how the potential attacker were able to really implement some changes in Web 2. So we built a way that this system is just generated batches and then we store them on IPFS. IPFS really gets your immutability, and then we use another system which is called permissionless safe, and it's a just static front end. There is zero dependency with backend. It's all time have a version on IPFS also to achieve this way. And during the sign-in process, all transactions, all the parts into human readable format. So if someone would be able to really hack our backend, and then people who sign them could find there's some incorrect way. So only after that, these transactions goes to time log. And even so, when the transaction goes time log, each risk curator and we as well has a robot which monitors what's going there and could also alert that some malicious things come on chain. So this is what we built, and I hope we can see more solution, because what I can see right now is that people really tell, hey, this is a problem of users, they should do due diligence, or it was a problem with price oracle and lending, stay in the way. I think if you want to really achieve institutional level of security, we should not really remove our decentralization vibe. We can really do it together. So thanks very much. Thanks for your attention. Really great to talk on DSS.
Thank you, Mikhail, for perfect timing. Our next guest is John Ennis from R&D team at SAFE. John will explain us the newly emerged multi-sig extractable value attack and how to prevent them. Welcome, John. Good luck.
How are we doing, everyone? Come on, we're in Buenos Aires. Come on, a bit more energy. How are we all doing here? Yeah, so I'm John. I work with the SAFE R&D team. We're primarily working on solutions related to security, censorship resistance, and privacy. And can I get a show of hands? Who here owns a multi-sig right now? So we have about maybe 50% of people. That's good. Who here knows what a multi-sig is? Okay, so I'm going to take the assumption everyone knows what one is. So yeah, a little bit about our team. We're a team of 5 people, primarily focused on building solutions for these 3 pillars. We're mostly inspired by Eric Hughes, who wrote the Cyberpunk Manifesto back in the 90s. Vitalik has since taken quite some inspiration from that, as well as Prescarvio, some security experts within the space. And we are aligned with these values, and we want to be building solutions that address these pillars as well. I want to just outline the problem of this whole talk and kind of our building philosophy behind the solution that we created. Right now, in most multi-sig architectures, your transactions can be watched, they can be creeped on before you execute. And that opens up some attack vectors associated with either minor extractable value or even critical vulnerabilities in your own protocol or critical vulnerabilities in your own operations. And I'll talk to you about 2 examples why this is actually a big problem as well. So why is this a problem? I think the first one, it's primarily this happens quite often, but it's kind of goes under the radar. But say Alice wants to buy 200 Alice tokens at $100 at the price. Because it's multi-sig, everything involves, like every action involves creating the transaction, waiting for multiple signers to sign the actual transaction before it's executed on chain and broadcasted to the meme pool. So this delay period while you're in the queue for your signers to coordinate, that's an exploit window for Bob to front run the transaction, back run the transaction, or do both and sandwich the transaction. So if Alice DAO plans to buy 200 tokens, 200 Alice DAO tokens at $100, Bob sees the transaction in their queue. Bob says, okay, I'll buy the token before, I'll increase the slippage, essentially. I'll increase the price that Alice has to execute on, and also then I'll back run and I'll sell, like knowing that Alice DAO is buying this, I'll then sell at the actual inflated price as well. I'm not going to go into too much MEV, but the top 10 DAOs have been affected by this before. There are people that are sitting and watching what the top 10 DAOs are doing and trying to make some multi-sig extractable value from it as well. I want to get scarier now because that's a problem, but it's not the biggest problem. I think the biggest problem here is actually like emergency protocol operations. And say Alice DAO needs to now execute an emergency patch for a critical vulnerability in their contracts. Let's say there is a risk parameter in their DeFi protocol that needs to be fixed, otherwise, it can be exploited, or let's say there's something in their governance process that can be targeted. And this is a problem because I've seen in the past, from speaking with people, that there has been transactions to literally fix DeFi, or transactions to fix a patch that have been left sitting in a queue for hours or even days. And this is a patch to fix a vulnerability that could involve millions, potentially even billions worth as well. Because these pending fixes are publicly visible, you can deduce what that transaction is trying to fix as well. And that's why we have malicious actors actively watching protocol operation multi-sigs, seeing what they're doing, seeing whether they're trying to fix a vulnerability in the contracts as well. So this delay period, that is the window for you to get wrecked if you're trying to fix something or cover up your tracks in terms of your contract vulnerabilities, or even your both off-chain and on-chain vulnerabilities that have an interaction with the on-chain world and with the contracts. To give you, I'm not going to name names, but a critical DeFi protocol was very prone to this, having a transaction in the queue for hours that could essentially cause a catastrophic, knock-on effect of the entire industry. And it's a top 5 protocol as well. So how do we actually address hiding this information? We want to hide the transaction details. We want it only viewable amongst the signers, so nobody that is a malicious actor can be viewing that information and waiting to make an attack based on that information. The answer is AI agents. I'm only messing. It's not AI agents. The answer is actually encryption. We have keys, we have private keys, let's use them. Let's use encryption. We're in the space, we're in the cryptography space, we're in the cryptocurrency space. Let's use encryption. And this is where we've created Secret Harbor, which is just what we call the solution. And it is a way to encrypt multi-sig transactions for safe, but also for other multi-sigs as well. This is not specific to safe. This can be applied to other multi-sig architectures. And what I mean, what is Harbor? It's just an alternative interface to Safe Wallet right now for making multi-sig transactions. And we've built it in a way that has minimal dependencies, so as censorship resistant as possible. The transaction queue is 100% on-chain, so there's no back-end that hosts the queue or coordinates the queue. It's all on-chain. And the signers communicate with signing and signatures via Waku, which is a peer-to-peer trustless protocol. So we're not relying on a centralized entity to coordinate the signatures as well. And you can do multi-sig transactions on it today. Harbor.safe.dev, if you want to try it out. It's experimental beta release right now. We haven't fully audited it, but I've been doing this. I've been dogfooding it. We have others dogfooding their transactions as well. It's a way to use it with minimal dependencies, and also, I will talk later, encrypt your transaction details. So Harbor's queue is all on-chain and public to anyone. So we want to make it secret Harbor, i.e. we want to hide this queue with encryption. And what Secret Harbor is a key exchange server. It's all on-chain. It's all hosted on-chain for encrypted communication. So that means signers can create secret transactions, and other signers can then receive the transaction, decrypt the secret transaction, understand the transaction details, sign it, and eventually execute it on-chain as well. And again, this is all on-chain. We're not using some centralized crappy backend hosted by AWS. I want to talk to you about the key exchange server. So the signers need to exchange encryption keys to enable this. And unfortunately, Ethereum uses public addresses and not public keys. So you can't necessarily do encryption with your public Ethereum address. There are workarounds, but a common security practice is to decouple the key you sign with the key you encrypt with. And I'm not a hardcore cryptographer, but it is a common practice to decouple those two to increase the security of the overall solution as well. What we use to create a separate encryption key is just a simple X25519 enabled Diffie-Hellman curve. It's a public key. It's widely supported. There's fewer security assumptions, and it's 32 bytes. And essentially creates your public key, your public encryption key here as well. To create entropy, i.e. to create enough randomness, we derive the key with signing with Ethereum signatures, and that gives us a encryption key to sign with and also decrypt and encrypt transactions. So the flow, I'm not going to dive into too much details here, but Alice simply registers her encryption key at the top with Secret Harbor. On the right-hand side, Bob registers, Charlie registers, so they all have their own public encryption keys. Alice, when creating a transaction, will retrieve the encryption keys from Secret Harbor, create the transaction based off Bob and Charlie's own encryption key public address, enqueues the transaction. Bob and Charlie are listening to Alice and see when Alice has queued a transaction. They retrieve the encryption key, they get the context, they decrypt the transaction, and once they decrypt the transaction, they can begin signing the transaction, and eventually everyone signs and executes the transaction at the end of the flow. So here is Harbor creating the public key. Here is where you can create an encrypted transaction. So they say you just want to send simple ETH transfer or do a more complex contract interaction. This is you signing and enqueuing the raw transaction with your public encryption key and using your signature of your own address. And then this is simply Bob and Charlie then signing the transaction because they have their own encryption key that matches what Alice has wrapped. They can decrypt it, understand the transaction details, and eventually execute. And what that means is only Alice, Bob, and Charlie can actually view this information. No one else can view this information. And that's it. That is essentially Secret Harbor. And I want to make a this is a really, really important point, is we call this Secret Harbor, but don't think this is everything you're doing is secret, right? We're just using basic encryption to encrypt the queued transaction data. Once it's executed on chain, it's public. People know what you did, essentially. And we're leaking metadata. So it's not a full privacy solution. People will still understand who is signing, how many signatures remain, and what multisig is transacting. So this is your transaction details are secret, but the metadata associated with your multisig is still public and known. So that's why this is a very specific solution when you want to stop doing, when you want to stop preventing multisig MEV with high values of high value transactions, or you have some critical protocol updates that you want to do, and you don't want anybody in the crowd or anybody in the world seeing what you're trying to patch up or what you're trying to execute between the queue and eventually executing on chain. We are bullish on solutions like Railgun and Bermuda for achieving full multisig privacy. So privatizing the signers, so no one knows who the signers are. Privatizing the multi-sig address, so you don't know the multi-sig address, and also the multi-sig configuration. Is it a 2 out of 3? Is it a 5 out of 7? Because what that does is kind of obfuscates as well. It's security by obfuscation. It's harder for malicious actors to identify, this is the security critical protocol multi-sig that I need to watch and I need to monitor and think of potential attack vectors for. So you're actually obfuscating that details, and that is helpful for security as another tool in the actual toolkit, not a foolproof solution either. And yes, that is essentially what we've built. Please try it out for yourself on harbor.safe.dev. Again, this is minimal dependencies and a way to privatize your queue. And also, if you want to know more about the solution, reach out to me on X, Sean McEngish, it's my name in Irish. Reach out to me on X as well if you'd like to speak about Secret Harbor. And I'm happy to take questions if anybody has any as well, because we have a bit of time. So if you have any questions about Safe, any questions about security or privacy, I'm down to discuss.
Hi, good morning. My question is, can you integrate this into an existing Safe for the governance of a protocol?
Yeah, so if you have a Safe right now, you can simply import your Safe to harbor.safe.dev. So any Safe that has been created, like version 1, version 1.1, 1.3, 1.4, this all can be used. So treat it as like a companion, essentially, for your current multi-sig as well. If you want to do some we don't expect everyone to be using this, but on certain use cases we do expect people to try it out. No more questions? Thanks everyone for listening, and catch me after as well. Thank you.
Hey guys, next session brings us two excellent security experts at the same time. So meet Daria from Aave, smart contract engineer, and Tomer from Certora, security research tech lead. They will show us how Aave v4 is engineered to be secure by design. Welcome, guys.
How's everyone doing? Good? Do we have the slides? No. Who here has heard of Aave or used Aave before? Oh, interesting. So you're in for a ride. Usually we never have to give a brief about what Aave is, but just a quick disclaimer. Deepest liquidity, largest lending protocol, never been hacked, one of the OGs. Those are nice pictures, right? This is so bad, man. Do you want to do some crowd work? Should we go there? All right, finally. Let's start. You want to give an intro?
So I'm Tomer Ganor from Certora, a tech lead. And
I'm Dara Sethi. I'm from Aave Labs. We are a service provider under the Aave DAO. About a year and a half ago, we put out a proposal, and we were selected by the DAO to build the next iteration of Aave, Aave v4. Our talk is about the security blueprint and how we engineered Aave v4, some new features, and some takeaways for your development practices as engineering teams. So let's start. What Aave v4 introduces. So I've already taken a scan that everybody knows what Aave is. So I think we're familiar with the architecture. One of the major things that we changed with Aave v4, so as we know that whenever you deploy an Aave v3 market, it's a standalone market which has the liquidity provisioning and borrowing strategy compiled together. One of the major architectural changes with Aave v4 is that it makes this architecture more modular by splitting the liquidity provisioning and borrow strategy in two components called the hub and the spoke. But why do we need this new architecture? While seeing the evolution of Aave v3 and seeing where it has reached today, we realized that Aave v3, for example, right now only supports tokenized assets, and it's very hard to bring more asset classes into the mix. By separating the liquidity provisioning part, you can have more exotic asset classes in a much simpler manner because the architecture is very plug and play. You can plug any hub to any spoke, essentially. So, for example, you can collateralize your LP position on Uniswap while it's earning LP fees. Or you can connect to another liquidity provisioning infrastructure, which is built by somebody else. It just needs to follow the interface. That's all. Another key aspect of this new architecture is that when new markets come about, for example, as we see, let's say that the standard spoke is what Aave v4 has built, which is an Aave v3 borrow market. Whenever new asset classes come into play, when they've legitimized and they've gained some traction, like in RWAs, real-world assets, and users want access to that. Right now, we have to spin up the market from scratch and bootstrap the liquidity from zero. But with Aave v4, they can just get a normal credit line. The users from another spoke get exposure to this new asset class and can enjoy good properties. The first component, the hub, is the central liquidity source. It's an extremely simple contract. It's supposed to be as extensible and modular as possible. The idea is that it only tracks the total supplied, the total borrowed, and the total owed assets. And it does not try to do anything else. When we have a spoke, the idea is this is where users shop for different borrowing terms. And it doesn't necessarily need to be a lending market. It can be any kind of exotic things that can access and use deep liquidity, some of which we'll see in a while. What's to come in the talk? We're going to talk about risk premiums and how we implemented something which most lending protocols don't, which is variable interest rates for each borrow position. We're going to see why this is important. What are the design challenges that we faced while building this and how we fixed it. Then we're going to introduce a new paradigm that we learned during the development of Aave v4, which is called prover-driven development. We're going to talk about how this accelerated the development of v4 and some tips apart from this as well. One thing in most lending protocols in Aave v3 and Aave v3 is, let's say, for example, you and I, we're both opening a position of the same value by borrowing Go. I back my position by using a collateral, like we talked about that now we can bring different asset classes into the system. Let's say that I'm borrowing against an LP token, tokenized, and you're borrowing against ETH, the same value. In Aave v3 and in most lending protocols, you and I pay the same borrow rate on our loan. But that doesn't seem fair because your token, ETH, has no risk attached to it, has less risk than my collateral because my collateral has an additional smart contract risk, has an additional pricing risk, for example. But you and I are both paying the same rate. So I think something's wrong. I think someone's getting screwed here because you're basically paying for my risk, which is not fair. So in Aave v3, what we introduce is risk premiums. It's a new feature where borrowers who back their loans with riskier collateral pay a higher rate, pay a higher premium. What this enables us to do is that from before a higher base rate, the base rate goes down, and if you have some exotic collateral which has more risk or more implied volatility, risk managers can define a particular risk for it, and you pay an additional premium. This essentially incentivizes borrowers to back their loans with less risky collateral because they pay less. And as you can see, the base rate for ETH went down. Earlier, it was paying for the risk for from somebody else because the Go suppliers, they were still getting a risk average return, so they were fine, but not the person borrowing from ETH. And this is good for suppliers because risky positions pay more, so they earn a higher yield. So risk premiums help us precisely price risk.
Thank you. So, so how can you do this? How can we precisely tailor a borrow position rate specific for each user so they have different rates as riskier the collateral goes? So one way to do it is to use, let's say the base rate is 5%, let's say an example, 5% base rate and 1,000 Go debt. And let's say the risk, collateral risk is 40%, which is just a number that the risk managers determine that this is the risk that collateral brings. We can have the effective rate of the borrower will be 7%, which is basically 5% times 1.4, extra 40%. And now the effective rate is 7%, which means that after a year, we will pay 70 Go in interest, which is 50 interest, and then extra 20 in fees. So let's see how it works for a couple of users, because we need, at the end, we need the hub to be able to extrapolate what is the total amount that user owes to the hub, so we can determine how much he owes to the LPs. So let's say Alice has 1,000 Go debt with 10% risk, and Bob has 2,000 Go debt with 30% risk. We need to calculate the weighted average of those two users, because they are the total users in this example. We need to know what is the weighted average of them to allow the hub to extrapolate what is the amount that a user owes to it and what he owes to the rest. So we just take Alice balance times Alice risk plus Bob's balance times Bob's risk divided by the total of debt that exists, and we get 23.33%, which is the weighted average. This is not precise. There is rounding here because of this division. We could round up or down. If we round up, we'll over-promise to the LPs, and if we round down, we under-promise. So it's better to round down and round against the user in a way, and then we don't over-promise and we're still solvent. So let's see what happens if we remove Alice from the system by repaying. So if Alice repays, we just need to remove her from the weighted average, which basically means that we take the total debt times the old total debt times the old weighted average. Then we subtract Alice debt times Alice risk divided by the new total, which basically turns out it's 29.99. And it's not 30. Why should it be 30? It's because Bob is now the only user of the system, which means that the weighted average of the system should be Bob. But Bob risk collateral risk is 30%. This is 29.99%. It looks negligible, but every time we do an operation, this will compound. Every time it will be less and less precise. So this is wrong. So what went wrong? The division. As I said, once we divide, as everyone knows, when divide, we have rounding, either round up or round down, or round up or down. So if we just didn't have this division, everything would be precise. So, of course, we just remove the division, and then everything should work. But it's hard, because the weighted average is a very intuitive way to do this. Because we have the weighted average of all of the users together, just multiply, and then we have the numbers we want. How can we do it in a different way? We just need to rephrase the problem. Instead of adding the percentage of risk to the interest, we just add the percentage of risk to the amount. Basically, instead, everyone has the same base interest. From before, it was like 5% base, and different amounts. So the effective rate is higher, but the real rate is the same. Just the amount is different. Let's see the same example as before with one user. So same base rate, 5%, same base debt, which is 1,000 Go, and 40% risk collateral. Now, instead of 7% effective rate, which is, again, 5% times 1.4, extra 40%, it's 7. We just have the same base, 1,000 Go, with 5% interest, and we have extra 400 premium ghost debt, which is the same 5%, which is basically a debt that we only pay interest for. We don't pay the principal, which means that after a year, again, we'll have 50 from the interest, and extra 20 from the 400 premium debt. 20 is like 5% out of 400. So it's the same 5% for everyone, same rate, but different effective rate. And let's see what happens with the 2 users from before. So we have, again, Alice and Bob. 1,000 go for Alice, 10%, and 2,000 go for Bob with 30%. Instead of doing the weighted average with the division and everything, we just sum everything up. We take 100 premium debt for Alice and 600 premium debt for Bob, which is basically just the debt times the risk, and we sum everything up, and we have this exact total. We didn't have divisions here. That's why it's precise. Now, when Alice repays our debt, like before, we just subtract Alice's position from the totals. We don't need to divide, we don't need to multiply. That's why everything is precise. You can see that 700 minus 100 is 600, which is the premium, Go premium debt, which is basically exactly what Bob has. So now the hub state is like Bob's state, exactly. So now it's precise.
I think that made sense. Let's continue with the security practices that we learned during the development of Aave v4. So before we start, there's something that as developers I really want to stress. You should get involved with auditors as early as possible in your, whenever you start designing a new protocol. We got involved with Certora at the design stage. And one of the major things that we did was we started defining properties very early on, essentially before we got too attached to our code. As developers, because we spend so much time on things, we start to get a tunnel vision of sorts when it comes to defining what we want. For example, let's say that you start out with the goal of making a circle. And while you're developing, you realize, okay, there are certain things that are inhibited by the development, by implementation details or something else. Maybe the goal changed, maybe requirements changed from somebody else. Midway, you realize, oh, well, actually, I need a triangle. Now you have two options at this time. Either you can power through, you continue, or you change. If you power through and you continue, you start molding it into something it may not be, or even if it comes out to that. You start applying patches. It may work, but at that point, you're just fixing things. You're not building things. And what this means is that as you start making patches, there could be gaping holes in your system that were missed by the auditors or by yourself because you spent so much time on just thinking about this. Another approach that you could take is instead of fixing, you start changing things. You start from the bottom up, and you start with the learnings from the previous time invested, you start building from scratch.
Yeah, thank you. So basically, to rephrase what Ahaya said, is that we first need to know what we want to do, which is, and in this example, is a lending protocol with risk premiums. And then we can think about the properties we want to have to make it safe. So we need to, at the start, we need to do the design properties, let's call it, when you know what we want to do, which is, for example, here in lending protocol, that the protocol is solvent. And then when you want to know how we want to do it, when you try to implement, when you try to design or try to plan your implementation, you see how you want to do it. And then you can think about properties of implementation-specific properties, like some variables should not be zero, should not be like any kind of different properties regarding the specific implementation. Once you have these two critical times, in the start when you know what you want to do, and in the middle when you know how you want to do it, then you want to you want it in English, and then you want to formalize your properties in CVL, Software Verification Language, which basically helps our prover to translate your English into mathematical formulas, and now we can know if your code is correct or not. And this process, as Daria said, is very iterative, because maybe during development we discover that what we want to develop is too hard, impossible, or just not what marketing wants, not what business wants. We talk with them and then they decide they want something else. We can change things when we can rediscover what we want and how we want to do it. But when we do it, we need to explicitly do it. We can't just think in our head we're one thing and then do something else. So that's why every time you change your mind, you need to rephrase the properties, rephrase the behavior you want to have, and that's okay. That's completely, that's great even, because you're developing, you're making new ground and new ideas. And the prover can help us find both the design issues and implementation issues as long as you formalize your properties correctly. So now let's go to the most important property that we prove for the hub, which share rate doesn't go down. For this property basically means that the protocol is solvent. So of course everyone wants, all of the protocols will be solvent. Everyone wants to be solvent, and this definition is very hard because protocol solvency, it has a couple of different meanings depending on the protocol. For example, if we have a protocol like Aave v3, it has index-based approach, which basically means that the amount of liabilities the protocol has is the amount of shares that exist times the index, the supply index in Aave v3, for example, and that is the total liabilities the protocol owe to the LPs. And the amount of assets that the protocol has is the total debt plus liquidity, and we just need the assets cover the liabilities. That's very easy. It's very easy to formalize the property. It's very easy to check it. And if, for example, I add this malicious function, just steal money from the protocol, for example, I can just call the function, take all of the money away. You could immediately notice that the property will fail because the assets will go down, the liabilities won't go down, and that means that we just lost money and the property will be violated. But in Aave v4, for example, we don't use index, we use share rate. And share rate is just take the total assets, divide by total shares, and that is the supply share rate for the user. And because of this definition, the previous property as I described it is true, is just true always. Because if we have this magic function, just steal all of the money from the protocol, now we have 0 assets. Basically, to recalculate the share rate, it will be 0. Total assets divided by total assets, which is 0 because we stole everything, divided by amount of shares, it's 0 because 0 divided by something is 0. And then the obligations, the liability of the protocol is 0. So total asset is 0, the liability of the protocol is 0, and that's true, but money got stolen. So that's bad. It means that we didn't check what we really wanted to check. What we want to check here is that share rate cannot go down, because if share rate goes down, it means that someone took more assets from the protocol than what he redeemed in shares, or just got free assets because he just stole money from the protocol. And share rate going down means that someone stole your funds. If share rate go up, it means you profit. If share rate go down, it means someone stole and you got socialized and got part of the loss, all of the loss, if you have a lot of shares. And that's what we proved. We proved that share rate cannot go down, which means that the hub is always solvent. No matter what kind of spoke we will build and what logic it will do, the share rate cannot go down always. The hub does all of the check to promise that the hub is always solvent.
During the development of Aave v4, as we've talked about, you need to start writing your properties early on. One of the benefits of that is once you've developed such a modular and extensible architecture and a protocol, these properties come very handy. As we know, the hub can connect to any kinds of spokes, any exotic borrowing strategies. It does, actually, not even borrowing strategies, anything that can do something with liquidity, essentially. Now that we have the hub properties written in, tinkering and experimenting with new kinds of spoke designs is extremely easy and straightforward, because you type out your hub property, your spoke, you can test it against the implementation very soon and find out if it's compatible and if it does not break any core invariants of the protocol, because you just need to adhere to the hub interface and run the Fedora approver once. This way you can test and tinker with your ideas and accelerate your development quite fast. One thing we also learned during the development was we had multiple iterations where we tried a lot of different ideas to make different kinds of features work. Most of them are not covered here, but you can check out other talks or our blog posts for that. You should start writing your protocols as prototypes so that you can iterate on them and work on them faster. Another tip that I have is also consider using, so as we know that the Fedora approver is a symbolic engine, consider using lighter SMTs like Z3 such that you can script and type out smaller parts of your code faster. Like maybe you're doing some extrapolation on the hub or on some level, and you want to figure out if these roundings work after thinking about whether they're in the favor of the protocol or not. Really quickly to conclude, Aave v4, because of the secure development, opens up a lot of design space, and some examples could be that, like we've talked about, you can collateralize LP positions. One more is that because of the way that risk premiums work, they're very modular and extensible. They can be built not just on your collateral, because the current market works just like a V3 market. They can work on your entire position. like an options market where your risk premium is sort of exactly equivalent to a margin, for example. That's all from our side. Our V4 code is live. Check out the properties. Thank you so much.
Thank you.
Thank you, guys. Our last speaker for today, Bianca from Chronicle Labs, Head of Developer Relations. She will show us how Oracle security can be reformed in 2025. Welcome, Bianca.
Thank you so much. All right. How is everyone doing? Hope you're enjoying DeFi Security Summit so far. This presentation will be about Oracle security in 2025. I want to start with a bit of a disclaimer. When I first applied to this talk, I had in mind a bit of a different angle. I was planning to go to the different sort of exploits that you can have when it comes to oracles and how you can prevent those. But in the meantime, I realized that there is something way more urgent that we need to tackle when it comes to Oracle security in 2025. So I will be focusing on that. Okay, the presentation is up. Amazing. A few words about myself. My name is Bianca Buza. I'm head of DevRel at Chronicle. Chronicle has been around since 2017. In 2023, it spun out of MakerDAO, now known as Sky. And today, it continues to power assets across the DeFi as well as the tokenization space. Now, I want to take you a bit on a journey, all the way back to DeFi summer. Back then, people weren't really talking about oracles unless something was going wrong. And every time you would read kind of the same headline, protocol hacked by millions because of XYZ Oracle exploit. And the main culprits are the following: flash loan attacks, market manipulations, stale prices, and so on. However, I would argue that since then, we have improved a lot as an ecosystem. It's true, we haven't eliminated completely this sort of exploits, but they are way more contained, and we learn a lot of important lessons, if you want. Here are some of those lessons. First and foremost, use decentralized oracles. Don't build your own oracle. And next, I'm going to go through some of the other considerations, if you want, when it comes to choosing an oracle. One of those is operational history. Has this oracle consistently secured funds over time? Here, of course, we're looking for longevity because it signals reliability, especially when the oracle didn't have any sort of exploits in the past. Another consideration is TVS, or total value secured. And here we're looking at how much value, what's the value secured by the oracle. We're also looking at the level of decentralization. We want to have multiple nodes run by independent validators, and those to use diverse data sources. Also important to look at who are those validators, who is running the network. Are those validators trusted independent validators? And here, high-profile validators have a reputation to maintain. So those bring higher levels of data integrity and network security. Data sources are equally important. We want the oracle to use tier 1 reputable data sources with established credibility, high liquidity, and of course, a track record. And also super important, operational costs. Oracles are expensive, and especially during times of network congestion, it's very important to make sure that they remain accessible to users and protocols. And definitely here, you want to make sure that this accessibility is the result of taking the right actions. And what do I mean by that? For example, if you're lowering the update frequencies, sure, it's going to be more cost efficient, but you end up with stale data. So that's not really the path you want to take. Instead, you want to create mechanisms that reduce costs without compromising data freshness. For example, in our case, we're using Schnorr signatures to bundle multiple signatures into one, reducing the gas. Now, these are some of the lessons we learn over time and some of the considerations for protocols to keep in mind for what I like to call the version 1 of oracles. And in a very, very simplistic way, this version 1 of oracles is technically a data pipe. So you go to the oracle, hey oracle, I need this piece of data, and then you have the oracle that has its network of validators. Those validators go to the different data sources. They gather the data, then they agree on the final data. That final data gets pushed on chain, and then it's readily available for smart contract and protocols to integrate. So this is V1. And it's very important to keep in mind that for this V1, we are talking about crypto-native assets. Assets that are available on-chain, and assets that have a lot of metadata to describe it. For example, if you want to know the liquidity of a Uniswap pool, you can just go to your favorite block explorer and get details such what is the TVL, what's the trade volume, what's the supply, what are the fees. Everything is on-chain, it's observable, verifiable, and programmable. And this is very important because you can actually, based on that information, you can build trust. But I would argue the game has changed. We are in 2025, and it's the year of RWA expansions. And here is what I mean by that. All the institutions are going on-chain. We have seen Robinhood having tokenized, Robin offering tokenized stocks on-chain, Stripe offering payments via stable coins, South Korea working on a legal bill to enable institutions to issue stable coins in one denominated stable coins, Shopify offering to its customers USDC payments, and so on. And the list continues. If you look at this screenshot, you can see that some of the largest institutions in the world are embracing on-chain, the on-chain economy. You can see the Bank of America, BlackRock, Citi, and so on. And they're offering several services related to the on-chain economy, such as crypto trading, crypto funds, crypto ETFs, crypto-enabled payments, and different forms of tokenization. This is the value of the RWA market last year in December, 13.9 billion. Anyone has a guess about this number today? Okay. 15? Anyone more? Okay, let's see the actual number. Today, this number is 35.54 billion. And if you do the math, that's a 155.8 increase in less than a year, really. And this is only the tip of the iceberg. If we're looking at the total market for gold, currencies, real estate, commodities, we're talking of over 40 trillion. So what does it mean? It means that there is a great potential of expansion for tokenized assets. But it also means that we have a lot of responsibility. We have this responsibility to tackle asset tokenization the right way and to make sure that we integrate these assets securely into DeFi. So here I want to talk a bit about what I like to call Oracle's V2. And I call them Oracle's V2 because they move past being simple data feeds to actually being real-world interoperability layers. So this version of Oracles, they enable protocols to take way more complex decisions that the version 1 we've seen before. They enables users to know if they can trust a protocol they're interacting with. They enable to determine if it's appropriate to have a financial contract to execute. They also enable to know if a tokenized asset, for example, a stable coin, it's actually backed, and so on. So as you can see, those are way more complex answers, complex questions to answer. And that's because tokenized assets are not really crypto native. Really, they are a representation of an asset that is off-chain. So the problem we're seeing is that those assets are not inherently transparent, and also they lack liquidity verifiability. And that's why, that's because these assets, they reside in traditional financial systems, and as we know, those are siloed, opaque, and off-chain. This also means that protocols can verify that these assets are actually backed. So if you're a DeFi protocol and you want to integrate, for example, a tokenized treasury fund, how do you know that the assets are, the underlying assets are actually there? Also, very important here, you need a lot more metadata in order to integrate those assets. And here are some of the examples of this metadata. So you might want to know about the custody of the assets, its composition, liquidity, the level of collateralization, its yield. All this information you need in order to build meaningful solutions when it comes to DeFi, and also to make sure that you can take proper security mechanisms when it comes to these assets. So what's really needed? We need an approach to, we need to approach asset tokenization the right way. Otherwise we risk reintroducing the same systemic risk that we have seen in traditional finance. And this is where oracles come into play. They help verify off-chain creditworthiness of assets. They provide key data, such as purchase dates, yields, maturity dates, and so on. And most importantly, they allow to sync the asset life cycle with the on-chain world. So you can see how an asset moves through the different stages, such as issuance, transfer, settlement, and so on. So this is why at Chronicle we build a proof of asset oracle. This is our oracle for real-world assets. And really what it allows to do, it allows DeFi protocols to handle tokenization the right way. So first of all, it connects directly to the custodian. So you have data source directly from the custodian, no middleman. And it allows to have an independent tamper-proof attestation of the data. And based on that, protocols have the flexibility to take different mechanisms. For example, let's say that you want to verify that the underlying collateral of a stable coin is actually there. And if the level drops, you can take some risk-appropriate measure. For example, you might want to do a circuit breaker, or you might want to do a liquidation, or some other mechanism that you can have execute automatically. That's it on my end. I hope I sparkled some interest to approach asset tokenization the right way, securely and responsibly. And if you would like to learn more about what we're building or oracles in general, please feel free to connect. I drop my handle on X. I'm always very happy to talk about oracles. Thank you.
Thank you, Bianca. I would like to thank all of our speakers that you have seen from the very morning. Yuri Tkachenko from Lido, Mikhail Lazarev from Gearbox Protocol, John Ennis from SAFE, Daria and Tomer from Avi and Sartora, and of course Bianca. Actually, in a couple of minutes, there will be a panel discussion. So everybody has already arrived, and we are just preparing the stage. So don't leave. We will start shortly. Thank you.
Hello, Buenos Aires!
Hello. Hello, everyone. How are we doing? Good? Exciting times in DeFi. I think this panel is more relevant than any time in the history of DeFi. We've got really great panelists, and would love for them to introduce themselves before we kind of delve into financial risk in DeFi.
Yeah, sure. Sébastien, co-founder of Stakehouse Financial. We are providing earned product for stablecoins and the whole DeFi. We are creating on Morpho, Camino, and also managing the growth sub-DAO of Sky.
Yeah, I'm Monet Supply, head of strategy at Spark. We're one of the largest on-chain capital allocators in DeFi within the Sky ecosystem.
Hey everyone, I'm Matt, working with Ale Labs. We're a risk and data firm working with protocols, primarily lending protocols across SVM, EVM, and all sorts of exciting chains.
Yeah, hey, Yaron from B Protocol, also RiskDAO. Over the last few years, we are consulting lending markets and now also curating vaults on Morpho and a bit also on Euler.
Hello, I'm Remy. So I have two hats. I'm the co-founder of Lagoon Finance, which is a permissionless vault infrastructure for curators or asset managers, and also a co-founder of 9 Summits, which is an asset manager and curator on Morpho, Euler, and Silo.
Fantastic. So we've got like asset managers and lending protocols and like almost the risk assessment tools, and we've got it all, I think. So I'm sure you know that the October 10th crash of crypto has brought a lot of like contagion that spread across DeFi, and that brought down some projects. And now the debate is about basically risk in like in DeFi. Well, who's managing risk? So I think probably the question to everyone in the panel is this shift in DeFi risk, the risk landscape. How do you see it in 2025?
Yeah, I can take this one. I think people learn that when you go on something called high yield, and there is a higher yield, there is risk. So sadly, it's sad that we have to learn it this way. But yeah, I think people now realize that chasing the highest yield is not always the best option. And I hope that people will start to thinking more about the risk side on the risk-return profile.
Yeah, I think That's a great point, and it's also it's getting more challenging for people to assess risk because previously there was maybe a few lending markets, like you work with Maker, you work with Aave, you work with Compound. Now there's even dozens of risk curators. They all have different approaches, different methods of risk management. So the job of a user is getting a bit more demanding, and I think we haven't really caught up with giving them the information they need in a digestible format.
Yeah, one of the really nice things about DeFi in 2025 is that unlike in previous years where, as Monet just mentioned, there's just a few opportunities for users to kind of dive into DeFi. Now there's a lot of different opportunities, whether they're different vaults with different kind of risk and reward opportunities there. And the challenge really is making sure that nobody's taking on much more risk than they intend to for the given yield. So kind of making sure that the risk and the reward stays balanced. It's something I think the ecosystem as a whole has a lot of room to improve in kind of helping users figure out where to place themselves on that spectrum.
Yeah, so definitely more for, then also Euler and others introduced, like a new concept of risk curators and kind of delegating risk management to others, maybe also to the users to some extent. Specifically in the last year or so, ever since Cicina, we saw that most of the yield actually moved off-chain. So a lot of off-chain components were introduced, arguably with higher risk, but with the way on-chain things are going, it's also kind of debatable. Where eventually most of the risk is. Other than that, I think, like the trend maybe of 26 will be not only risk curator, but actual, like fund managers in the kind of flavor of Midas and others, which, never really existed until now.
I think what we've noticed in the last 2 years is the externalization of risk, especially in lending protocols. So there is now like two model where the DAO or protocol would handle the risk, and the model introduced by Morpho 3 years ago were the externalization of the risk to curators or risk manager, asset manager, whatever name you want to call them. So I think it's interesting to see how, maybe for user now, there is they have to make a choice for the protocol and also for their curator. So it's becoming more complex to assess a situation and to look at the risk. And when you allocate to anything on chain, it's you have to know your curator very well, I would think.
And I think probably in 2025, we've seen the rise of these yield-bearing stable coins and basically underlying, tokenized strategies, and all of a sudden, I think 2025 people have stopped asking like, well, how do these assets work? Like, are they permissioned? Are they permissionless? Back in the day, I remember like 2 or 3 years ago, everyone said like, well, the Maker's DAI was just permissionless, you could redeem it, and all of a sudden today in 2025, just recently people discovered, well, I'm trying to redeem this stable coin for the USDC, but there isn't any. Where did it go? So I think a lot of these questions probably we'll try to answer in this panel. But honestly, like for just the average DeFi user or really the asset manager, the question is always like, what is the risk surface in DeFi? Probably like Sebastian, you allocate a lot of capital in DeFi. What are we looking at exactly? What's the risk surface? If you can break it down to us. Yeah, so Stackhouse is involved in orienting up to $3 billion of capital, so that's a lot. And the risk is very different depending on what you do. We are allocating, for instance, in T-bills. I know in DeFi a lot of people are saying, well, T-bills, those are risky, those are not liquid. T-bills are, or government money market fund are the risk-free yield of TradFi at least. And now it's coming on DeFi. So that's quite easy. It's not instant liquidity, but you really have it the next day, so that's fine. Then you have the lending protocol. So here you need to understand what is the collateral. And obviously, depending on the collateral, you can have crypto collaterals, you can have hedge funds, you can have a yield-bearing stablecoin, and you need to understand where the yield is coming from. And for those hedge fund strategies like stream finance, Well, you need to understand how they are generating the return. Because if you don't understand how they are generating the return, you cannot understand what are the risks. And it's very simple. If you don't understand, don't touch it. I think that's still a rule that works.
But then users might withdraw from the vault because you don't have competitive yield, and all of a sudden everyone in DeFi is generating 80% and you're generating 12%. So maybe I ask Remy, you also allocate a lot of capital. And what do you do for example, when your vaults like underperform in comparison because now you're taking less risk, for example? How do you manage this?
So you need courage to give user a lower yield, knowing that you handle the risk correctly and allocate to the right collaterals and the right asset. So I think a lot of yield-bearing stablecoin are in fact just vaults with asset managers allocating a stablecoin on-chain or off-chain sometimes. So what should be the industry standard is when it's allocated on-chain that you disclose all the addresses where so user can track what you're doing and the transparency that go with it. So it's very, and when I go to different protocol, for me sometimes it's hard to just find the final address where the money is allocated, to find the Octave or the debunk bundle link with all the addresses. And sometimes the money is even allocated off-chain, so then you cannot track anything transparently, or you have to rely on attestation. So sometimes it's fine. For example, like Itina has off-chain allocation, and so if you trust the team, if you trust operational risks that they carry, it's maybe fine to allocate, but you have to bear in mind that there is no instant transparency on what they're doing, so there is still a risk, but when there is yield, there is always risk, so it's just a matter of finding the right balance as an on-chain allocator.
Yaron, would you like to add anything to?
Yeah, nothing much to add. No, I mean, like the reason was like obvious competition, like over yield. I think eventually not everyone went full degen. But by the way, even those who didn't went full degen might got hit, regardless. Like the competition was very obvious, but also you could see some emergence of like branding and So like there was this feeling that maybe users don't know anything, but eventually most of the TVL did go to like more recognized brands, even to something like Aave, which by far has the most TVL. So like saying that users don't understand anything is not correctly true, but yeah, there are like many users who might not really fully understand.
Mone, I have a question. So Spark, one of the leading lending protocols, I think you've also always questioned or like consider whitelisting assets, and and now with this new wave of DeFi, and how do you assess risk in general before like deciding to either considering an asset, or if maybe the community asking you like, hey, why can this asset be the borrow in the pool? How do you look at risk?
Yeah, we get an incredible amount of inbounds. There's, an explosion of different issuers. A lot of them have interesting strategies, but the transparency is often a bit lacking. So I think that's kind of like a threshold issue for us. Like if we can't get like good transparency into how your strategy works, we have no idea what the sort of like dependency graph looks like. As an example, the DEUSD stablecoin, I think people assumed initially it was just, cash equivalents and then basis trade, but then suddenly they were allocated into a bunch of different stuff, and if you don't have that transparency aspect, you're not going to find out about that until too late. So I think that's a really important threshold issue, but then just trying to like look through each of these strategies, each of these tokenized like hedge funds to see what they're doing and making sure that you're comfortable with each component. So it's quite a bit of legwork, but I think maintaining that discipline is really important, and it doesn't pay off immediately, but over time, this is how you build user trust, and basically just making sure that you're doing everything right and being patient.
Yeah. So obviously, risk has become significantly serious in today's DeFi.
with all these assets and all these and off-chain operations as well, and probably no one has any purview over them. And so now the question is, well, who's responsible for managing risk? We've got here like some, of course, like the risk managers. By the way, it's a confusing terminology, like, you know, because I don't know, do vault managers or asset managers actually manage risk? Is it part of the responsibility? So probably the question is, who's responsible for managing risk on behalf of users or even the LPs or whatever? So maybe, you know, Seb, you can.
Yeah, sure. So there is a strong question to be asked if curators are managing risk and in which way they are responsible if something goes bad. I think it's a fair question, and the industry didn't decide exactly yet. When we are creating a vault, we are creating something with a specific risk appetite. It doesn't mean that we are saying it's risk-free or anything like that. It's just that we are targeting a risk appetite because we are assuming that some people want to have such a risk appetite. It doesn't mean we are comfortable with the risk appetite. Obviously, we don't have the riskiest vault because I want to be able to sleep at night. That's my threshold. But for instance, I always say, and I said it publicly on Twitter many times, for most people, they should only use our prime product, not the high yield one. Now, when we created the high yield one, we didn't have it at the start. Before they were live, most of people in my company were asking me how they can get access to the product before it's live. So that shows you that people are always a bit degenerate, and actually most of the treasury, most of the stakeholders' treasury is in those high-yield products. So it's difficult to have a clear answer. I would say the fact that the curator is investing in their own product is showing that they are comfortable with the risk, but doesn't mean that it's a good risk for you. You need to ask yourself first, what is the risk you are comfortable with?
I think that's a really good point, and I think a lot of users maybe are not honest with themselves of what is their actual risk appetite. They want high yield, but they're not comfortable with, like, you know, occasional charge-offs or decline in value of the strategy. So that's an important thing that, in a sense, users are partly responsible for managing their own risk.
Matt, you also allocate capital. You also have access to lots and lots. You have your own risk assessment tools, and you have, so whose responsibility is it, and what do you think that people like you can do more for the users to understand risk?
Yeah, so I think that, you know, as we all have kind of been talking about, there's even the same, you know, curator might have a variety of vaults with different risk levels. And it's really not something that the industry has really figured out how to actually communicate what these risks are and quantify them. So although it's very easy to look at either the instantaneous yield of a vault or a market, and you know, or historical yields for that matter, it's a little bit more difficult to communicate these risks. And there's several risks, right? There's liquidity risks. You know, are you going to be able to withdraw all your assets at the click of a button whenever you want? There's also, you know, some sort of charge-off risk or insolvency risk in these protocols too. And I think, you know, even if you're investing in, you know, a bond fund or something like that, if you're kind of, you know, more on the high yield side, just in traditional finance, right, there's going to be some insolvencies potentially in there. And that's just the cost of business. It's not necessarily a horrible thing. And I think that something that a lot of us, you know, are working on now is kind of how can we better communicate that to users so they can pick, so they can choose by themselves. As we saw the other day, you know, there was, you know, high utilization in a lot of vaults and a lot of markets. If a user is not comfortable with that, you know, maybe needing to wait 12 hours to withdraw their liquidity, that's something that they absolutely should consider before entering some of these positions. And it's not really something I think most of these same people that were, you know, a little upset about it had thought about prior. So I think, you know, kind of better illustrating all of these risks and, you know, helping users figure out which they're comfortable with is really important, something that we're all trying to work on.
There seems to, right now the debate is, well, what about governance? What about, like, you know, protocols governance, managing risk? There's other thought about well, hiring professional services Like, of course, there's a lot of them, and some DAOs already work with them. So maybe the question to Yaron, how do you see this playing out in DeFi governance, token holders versus teams hiring like professional services?
Yeah, I think eventually, like the vision we had is that at the end of the day, you'll have community or token holders that will kind of have to decide on the level on the risk, while you will have professionals that will have to report, like the risk level. I think it's perfectly fine for certain communities, to decide they want maybe a risk that is twice as much as other, for others to be more conservatives. And yeah, it might not be realistic, to expect token holders to fully understand the risk, but once the risk is reported by professionals, I think it's eventually up to the community to decide, whether today they want higher or lower risk level than yesterday.
Yeah, and when you look about risk and who manages it, there is also a question, so whether it's service provider of a DAO or externalization of risk through curator, there is a last responsibility of the protocol to actually how the data is shown and what are the options for end user on the front end. So for example, in many lending protocol, being a curator is permissionless, so anyone could do it. But ultimately, the responsibility of the protocol itself to list it on their main front end. So protocols still have to do curation of curator in the end, a little bit, or at least like KYC them or make see that they operate correctly. So there is a little segmentation about who will show what the user have access to in the end.
I think DeFi today is just for really the degen, the individual who's willing to take massive, massive risks. And obviously, a lot of users just do not do their due diligence, and probably sometimes because the tools do not exist or maybe very hard to actually find. And sometimes like information is very difficult. So who knew like a certain oracle was controlled by a centralized entity, for example, or like you could not redeem this, redeem that. But I think that's probably the responsibility of entire DeFi. If we want to see DeFi expand, when I get like the millions and probably like hundreds of millions of users using it, you can't tell someone crossing from TradFi that, well, sorry, like someone ran away with your money because of this, or they lost on a centralized exchange. And now kind of bring me to the Stream case, like Stream Finance and Elixir recently. I think that's probably like the consequence of the crash, October crash, lost money and thousands of users. Like I personally deal with this every day. I'm trying to help users with the users of Silo Finance recover their funds. That's our #1 top priority because, and now maybe someone can walk us through what happened exactly, like why Stream and Elixir like both kind of like the,
Maybe I can pop in a little bit. I've looked into this Stream situation recently, but Stream was doing a few things that kind of amplified the risk of their strategy and had it created contagion essentially with other related products. So first of all, they were delegating or investing their user funds fully off-chain in a very non-transparent manner. They've disclosed that they lost 93 million in one of their strategies, but it's still actually not disclosed who was running the strategy. What was the strategy? I've heard some people say that it was like a volatility selling or like some sort of option strategy, which is, it's not the typical, sort of delta neutral strategy that people might be expecting from one of these off-chain assets. The other thing they were doing though is they were minting their own token and then posting it as collateral across various lending markets to essentially draw in like leveraged capital, not people who are intending to invest into XUSD, but just people in various different vaults across the space. And there was a bit of like sort of cross-contamination between XUSD and DEUSD and various other funds that were kind of mutually investing into each other. So all of that means that, when they lose a certain amount of money, the sort of flow of losses spreads very wide, and it also gets levered up. So yeah, there was many different things that were kind of wrong with Stream and created a lot of challenges that people didn't expect to happen.
And until recently, until probably like a few weeks ago, no one talked about this. Why did DeFi fail to spot those like red flags?
So actually, someone talked about it on Twitter and gave some warning 2 weeks before CBB. So it's a good idea when someone gives some thought about a project to just withdraw everything and assess later, as he said. So there were a few people, also Togby and other, like, so just pointing finger at, when you looked at the detail of the strategy, it was a big leverage, crazy health factor across the board, but that was only for the transparent part. What I didn't know is also that they were allocating off-chain, and yeah, to me the story doesn't make any sense. We allocated to an external manager, and he lost 100% of $93 million. I think there is more to be learned about this story than just what we know just now. And yeah, just looking back at, so I actually met those people in real life in April. And there were young people doing crazy degen, and I was like, am I getting old in DeFi? Am I doing very, very conservative grandfather strategies? Is this the new DeFi? And I was like, okay, this is not for me. But yeah, it's crazy how things turn out. But yeah, if there is a third on something, it's better to just withdraw and assess later.
Yeah, I mean, I was just going to say, I think the idea that no one spotted this is also not quite correct. I think that a lot of people, right, would see this and maybe they're asked to allocate, you know, some of their vault to this product or invest in it. Or there's a million things, right? But I think, you know, when you kind of see a lot of these assets come, you know, through your desk, as they say, right, a lot of them are not a good fit. And that doesn't mean you necessarily have to write like a big tweet thread about, you know, how this is a bad asset or something. I think the standard process is just to say like, hey, this asset's not for me, and move on, because there still are a ton of assets that are allocating, you know, user funds more or less off-chain, and they're not particularly assets that, you know, I want to deal with, right? But there's still some out there. I'm not saying there's like more assets like this that are going to have a huge, you know, contagion and you know, cause as much excitement, but just because no one kind of like wrote a blog post on it, I think, you know, I think people did see it. It's just, you know.
It's very hard to say no to high yield, extremely hard. Especially if others are shilling high yield on Twitter, you just feel like you're missing out. So a lot of users do it. So Sebastian, what's your take on the situation? You haven't allocated any money to, you did not allocate any money to
No, we didn't. So we didn't make a due diligence on Stream Finance at all, because I mean, it was just, I mean, obvious. Why USD? I just sent one DM. Are you an unregulated hedge fund with a ton of leverage? Answer was yes. I would say, okay, not for me. But to your point, why isn't there so many warnings? And some people are saying on Twitter and so on, but there is some risk. But there are also some risk on other projects. And we were not, and it's just a probability game. Why did Stream Finance blow up? It could have not blew up at all. And it could have worked for 10 years or 20 years or until infinity. So if you are coding it, then you are having on crypto Twitter, you will have a lot of people fighting for you. There are other bad projects or projects that can blow up. Every time you get money to a random guy on the internet and expecting yield, I mean, you are taking a risk. And there is plenty of projects, some that are quite big. I remember with Money Supply when there was Encore Terra Luna, we were trying to find how to short it. But we didn't say publicly that it's a bad thing, because that would be suicide on crypto Twitter. So the reality is that we cannot speak up because we want to be friends with everyone, because even if Stream Finance was taking a lot of risk, maybe you fake it and then at some point you make it, and they would end up being a regulated stablecoin that was all fine. So you cannot cry against the wolf too early neither. So that's my take.
Looks like they faked it all the way. So recently people started asking questions about like, okay, the Oracle, why it's still $1 like in some lending protocols? Well, and then it started digging into the source, like how do you really read like how do you value a certain asset? And then all of a sudden we discovered that, not all of us, but I mean some people discovered that, well, it's NAV based, so net asset value based, and there was no third party to really verify how much money they held versus what's the backing of the stablecoin. So the question is, Yaron, to you, like what kind of tools, what's the minimum threshold that actually should DeFi enforce at least and somehow on protocols to actually have at least a minimum, transparency?
Yeah, no, I think, NAV-based oracles are not necessarily pure evil. Even for StakeTis and, other assets, they're even the kind of the best practice ones. Specifically with Stream Finance and Elixir, maybe a year from now, after there might be some partial recovery, we will know if in retrospect, if it would have been better to have, like a NAV-based oracle or other. I think, it's mostly concerning and it's mostly challenging when you use it in a permissionless framework such as Morpho, maybe Euler, I don't know, rather than frameworks like Aave, where in Aave, you do have kind of the liberty to change the oracle if you want. While in Morpho, maybe technically it is possible, but already requires some coordination and, like around curators to begin with, which is not very realistic. So yeah, I'm not sure, sometimes it will be better, sometimes it will be worse, especially for low liquidity stable coins. If you use market-based pricing, we saw this incident with Moonwell on some StakeTis that use market-based pricing, and it was priced like 3,000x, higher than the real price. So yeah, like if it is possible, and this is where maybe DAOs can perform better, and you have people who can take decisions at emergency and change it, maybe it's better, but otherwise, it's part of the risk.
Yeah, and I think oracles are just hard in general, even if they're, crypto native assets, like even something like Bitcoin, right, to have an oracle for that. Maybe that's the easiest one, right? But it's still an endeavor to kind of implement that correctly. And for some of these RWA-based tokens, even if they're treasuries, right, you're dealing with stuff that's off-chain. Maybe you're dealing with, a variety of durations. And I think there's a lot of room here for exploration. You could imagine maybe having something like third-party attestations being published on chain. All sorts of things like that I think could really bring the risk of some funny business down a bit. But I think the design space is actually pretty large here.
Well, I have a question. So I think DeFi has evolved from a place where everything has to be decentralized, permissionless, to accepting some level of centralization and some less transparency. I think we've gotten a little bit lazy, and now the recent, it seems that we've accepted too much of compromise in DeFi. What's for example, the current some of the current assets that have massive operations off chain? How do users and protocols how can they navigate risk of such assets?
Yeah, it's a major challenge, and it's something that we sort of struggle with at Spark. So we've had some exposure to Athena, not any longer, but we also work with Maple. We're looking into other sort of like hybrid on-chain, off-chain products and services. I think there's a huge opportunity for like real-time attestations and making them provable. So like ZK proof, TEE, a lot of these technologies can definitely help. But I also think that part of the reason that we have so much of this off-chain assets coming in is because DeFi isn't really feature complete yet. There's people who want to do fixed rate lending, as an example. It's a huge priority for institutions, and they're willing to pay a significant premium to borrow fixed rate versus variable rate. So, in the current condition where fixed rate lending isn't really available in DeFi or on chain, of course, there's this huge incentive to work with Maple or maybe do it yourself and lend through custodians. I think Morpho V2 and kind of new infrastructure is going to solve that. And then similarly with perpetuals, we're seeing like an explosion of sort of increasingly sophisticated protocols. So in the future, you could theoretically see a world where all these delta neutral strategies are happening in a much more secure, transparent environment. And I think that's in the interim, we're probably needing to do more of this sort of verification, but I think we'll move more of the actual activity on chain in a kind of a safer environment.
Remy, would you like to add to that?
Yeah, I think like RWA coming on chain is something that is just starting, and it's going to be huge. Back to the valuation question, I think for tokenized hedge fund, so general purpose vaults, as opposed to lending vaults, the NAV, so the valuation, is usually handled by the asset manager himself, which can be problematic. But also, when you're a hedge fund manager, you look for specialized third-party providers that compute NAV in DeFi. There's not a lot of options, and service providers who are experienced and who are doing it right. So I think it's very, we're just starting, and maybe the space is going to professionalize. So this tokenized fund can have more independent third-party NAV provider that can give a real value, and ultimately that would be better for the users.
Okay. So there's no risk-free yield in DeFi. It's a myth.
T-bills.
Yeah. I think like probably DeFi is under a lot of pressure. If you really want to make like 4 or 5%, a lot of users just want to use DeFi, just go use TradFi, and just you eliminate at least the smart contract risk. And it's a really quite challenging. So everyone in DeFi just wants more and more and more. So now, how do we build really just more transparent and more resilient DeFi? Like, what do we need? Do we need just tools? Do we need to centralize risk management with curators? What do we have? What do we need to do?
Yeah, I think transparency and explaining what, for instance, curators are doing, what is a mental model for each product is quite important. For instance, obviously what we do for our vault is fully on chain. We have some dashboard, but you can always say, well, it's difficult to understand. We didn't publish a lot at the beginning, mainly for regulatory reasons, because when you're publishing anything, you are taking a risk. I don't write regulation, but that's how it works. So now we have published a risk framework so people can understand how we are thinking about risk, what we are analyzing, what we are adding on new collateral. We will publish a bit more thanks to the fact that now there is a more friendly regulation in the US. But I think it's mainly on disclosing, and make it simple for people to understand. For instance, it will be, and also having some counterparties that you can trust. I mean, trust is still quite important. I remember when there was a USDC that was onboarded at MakerDAO, everyone was like, we cannot trust Circle, it's off-chain. Come on, guys, now it's regulated by Genius, it's a big public company, maybe we can start to trust them. And it's the same people that didn't trust Circle 5 years ago are probably the one willing to give money on the internet to stream finance, or YUSD people that are, who knows who they are, and they have no expertise, no regulation, nothing. So for instance, we added a Fasanara MF1 as collateral, and people are saying, oh, it's off-chain, it's complicated, there is no transparency. I mean, yes, that's correct. You have less transparency, it's more difficult to have the prospectus because you need to be accredited because there is a lot of regulation making sure you never get the right information. But it's a regulated entity that is managing 5 billion, that is doing this business for 15 years. How could it be more risky, this one, than random people on a website that you don't know who they are? So it's very simple at the end of the day. There is hints of what you can trust. If BlackRock is launching a product, no one will read the prospectus. No one will ask any question. If you see BlackRock, you will invest. But BlackRock has risky product as well. So you just need to find proxies of knowing when it's safe and when it's not safe. Lindy effect is something. It's not 100%, but it's still something to see. Stackhouse, obviously at the beginning, you could have thought, well, who are those people? We are now here for 2 years on Morpho. You might say, well, maybe we know one thing or two. And we try to be more and more transparent on how we are operating stuff. Same for everyone. But if someone new comes up and you are giving them 1 million and you don't know who they are, I mean, at some point, just, it's common sense at the end of the day.
What would you like to add?
Yeah, I think one thing that maybe people are considering more in light of the balancer hack is, although we're DeFi native, we're not comfortable with these off-chain assets where maybe we have a bit less transparency, we have to trust a counterparty. You still face some pretty large sort of 0 to 1 risks operating on chain, even for protocols that have been around for a while. So you just need to kind of weigh the security risk, the smart contract security risk versus the counterparty risk, and it's not like necessarily always better to be fully on chain. Sometimes it's okay to trust a counterparty if they've proven themselves and they're existing within a rigorous sort of like legal and regulatory framework.
And what kind of tools do you think we need to provide? So actually, let me back off a minute. And we've talked about the responsibility, but we haven't really talked about the responsibility of users themselves. Like it's information, yes, it's difficult to kind of collect and really sometimes understand. But this is an unregulated space. It's extremely convoluted. Information is available everywhere, but then it's still users' responsibility to do it. So why can't DeFi come up with, like, say, for example, like maybe some sort of like organization that could provide insights about this new projects coming up and kind of like flagging these and even like, giving limited access. I think Yaron has done something similar to that.
Yeah, so it might not be popular to say it in this venue, but to some extent AI, it's like a huge buzzword that everyone likes to throw. And yeah, definitely it's not perfect, but one thing that this curator thing doesn't do, it doesn't give you any personalized risk, kind of advices or management. And we say, definitely it's not perfect, but for some users, it's probably better than nothing. And it can help you maybe convey the risk more and maybe understand the risk more. Again, like not sure if it's like a legal solution and, from regulation point of view, etc. But I think at this point, it can definitely outperform many of the kind of existing DeFi users.
So I think first there is no risk-free at all. There is always some risk when there is some yield. And one of the problems that users face is there is no normalization of the way we display yield or APRs in the space. So some projects or some vaults, some hedge funds display projected APR, which doesn't make any sense. Some of them display the instant APR, which doesn't make any sense also. And some of them display 7-day moving, 30 days, 1 year, and since inception. So at least what we could do as an industry is find some kind of normalization around how to show historical yield, net yield. There is usually shares and price per share, so maybe someone could find a way to show all vaults on all products and just show how they compare to each other in a normalized way. So I think some vault aggregator already kind of are trying to do that. So it's a good first step, but I think as an industry it would be great if we could normalize the way, at least the way we show APR. And about the risk model, it's a bit more difficult. So I know there are some risk notation agencies that are coming to DeFi. So I don't like this too much because it reminds some bad memories about the subprime crisis, where everybody would give very good ratings. There can be conflict of interest. And this notation agency can charge the curator, and because they are the one paying them, then conflict of interest. So I don't like too much the notation agency personally, but I think we could normalize APR to begin with.
Okay, now to conclude, just one last thing. I'm going to ask each of you to provide one sentence, your vision of safer DeFi.
I would say it's better product, less concentration risk. Let's just try to do the safe stuff and not go chasing the highest APY, even if everyone is asking you to put the riskier collateral to have a better APY.
I would love to see much more clarity on the risk surface of each product. So as a user, you should be able to see what particular asset drops for XYZ assets that you're exposed to in this product are going to cause you to begin losing money. It's not something that exists today, but I think that'll allow users not just to look at like a letter grade or like a rating, but they can actually express their own risk preferences and what things they're comfortable or not comfortable with.
My sentence, or just 2 words, would be more transparency. I think that when users are depositing into a market, vault, whatever it may be, kind of better understanding what counterparty risks they're taking, as Monet just said, what qualitative risks and volatility risks they're taking. I think that's super important, and I think as the front ends currently are, I think it's a bit difficult for people to get that on first glance. The data is usually there, the information is usually there, but it requires a little bit more digging on their part.
Yeah, so transparency for sure, but one thing that may be also missing, like in the kind of standard security audits, etc., it's maybe also featuring complexity and not only, transparency and risk.
So I think to finish with a positive note that we talked a lot about the risk, about the dark side of DeFi, about people taking loss, but there is still some incredible opportunity for risk-adjusted return in DeFi that you don't find anywhere else. And if you want to have access to those yields, come reach out.
I think we have to go back to the days where when we used to say, verify, do not trust. I think that's the way. I think we've trusted too much. All right, that was it. Thank you so much, everyone. Give it to our panel.
Thank you very much.
Thanks.
Okay, so they're saying that you can go to lunch and then come back at 1. The sessions resume at 1. Cool, thank you.
Check. Yeah. All right. Hey, everybody. All right, we're done with lunch. Please make your way back inside for an afternoon full of amazing content. We'll give people a few seconds. All right, let's kick this off. My name is Mehdi. I'll be your session chair for the next couple of hours. I'm a co-founder of Sigma Prime. We do a whole bunch of cool stuff in the blockchain security world. We're also Ethereum core developers. We have a packed schedule with amazing content, amazing panels, amazing talks. So please start making your way inside. And without further ado, I want to introduce Bartek, founder of L2Beat. L2Beat's doing amazing work, allowing us to keep track and keeping L2s honest. He's going to introduce your panelists for today.
Okay, thank you. Thank you, everybody. Please come in, and we've got an amazing panel tonight. So please welcome Usman, head of protocol security from Plasma. I was told that Usman didn't know what he's getting into, so that's going to be fun. Jan, co-founder of Circuit, one of the newer ZK rollups. Vlad, head of protocol security from Matter Labs, the wizard of ZK Sync, as I know him for many, many years, and one and only Lumi, who's apparently now at Arbitrum.
It's an honor to be on stage with David Guetta, so.
So there is this tradition on my panels that I moderate that, I try to make things spicy, so I do apologize in advance, guys, nothing personal. I know most of you really well. We just want to make it entertaining for you guys, and maybe in a way we're going to learn a thing or two. I'll just start with a super brief intro of myself. I've been for many years building DeFi protocol at MakerDAO, and then I moved on to look at the infrastructure. And a couple of years ago, I founded L2Beat, which is like a community watchdog for L2s. And we're trying to make these L2s honest, essentially. We think that we all should be honest. We should all expose risks to users. And we're at the DeFi Security Conference, so I think you should be interested in risks, especially pertaining to DeFi. So I guess my first question to you guys, and I start with Lumi, why DeFi users should even care about the risks of underlying infrastructure? Why this is important to them. DeFi protocols are complicated as they are, like we've seen recently with Balancer drama. Why should we even care about L1 security versus L2 security? That's sort of, hopefully will set the stage for further discussion.
I think Cloudflare downage is a good example of this, right? So Cloudflare's down, I'm working on a presentation, nothing works, right? The same is true for Web3, but the problem is if your protocol gets hacked, if the underlying layer gets hacked, or you have things like reorg, you might actually just lose all of your money, right? So I think on a very simplistic level, it's you as a user should never have to worry about where your assets are and if you might get rugged at any point in time. So it's a simple answer, but I think overall, this is why we really need to pay attention to security properties of both centralized, decentralized L1s, as well as some of the other considerations for L2s that inherit some verifiability from L1, like security committees.
So if you kind of think about such basic properties of chains as safety, liveness, reorg protection, censorship resistance, that type of stuff, Vlad, what do you think are the most important for DeFi users?
Well, I think everything is important. It's not like you cannot, you're saying that reorg are not important, or liveness is not important, or any other properties of the blockchain. I think that we want to achieve the perfect security for layer 1 users. That's what we do on Ethereum. And you always want to, when you put money on chain, you want to know that your money will be there and will be available for you at any moment of time. That's why we moving from Web 2 security, Web 2 traditional finance to Web 3. To tell a bit more about this, I would say there's events in history when you start using the normal traditional banks, and at some point you just lost your access, right? And some people decide that you should now not be able to withdraw your funds. And that happened in many countries. Argentina is a good example of such incident. But also for me, I am from Ukraine. And then I know that some people had a limit of withdrawals on your credit card, and it was not on control of user. So we should protect this value for financial freedom for everyone that is using blockchain. And if you just disallow one of these properties for the blockchain, then you will lose something important. So with reorgs, you made some actions on chain, and then at some point, the action was declined, which is not good. You can made it right, and then it appears to be declined, right? But then for liveness, you want to access your funds at any moment of time, and also safety is maybe the most important part of all of these properties, because you want to know that your funds will not be stolen without your proper access. So I think everything is important, just a matter of how we achieve it.
So just to set the context for everyone, Lumi essentially right now works for the biggest with respect to TVL and one with the longest history rollup on Ethereum, Arbitrum, right? And Vlad for ZK Sync. So these are two, let's say, leading L2s. And Jan, I mean, you're working at Zircuit, right? Which maybe could be characterized as the upcoming ZK rollup, right? Like a new kid on the space, but still L2. So, like from the point of view as a founder, why have you chosen being an L2 on Ethereum as opposed to launch your chain as an independent L1?
Sure. I think one of the big properties that is overlooked when we talk about L2s is not these core principles of blockchains that we've talked about, like liveness or safety, which are all important and all have a place, but actually diversity and differences in functionality and differences in use cases and differences in target audiences. And I think if you see the last couple of years, we saw other companies start L1s because they want total control. Over things, whether or not they're saying that out loud, I think that's the underlying reason a new L1 occurs these days, because honestly, we have battle-tested tech. Maybe Ethereum is not sort of the be-all answer. I think it is. But even people who like Solana and others realize that there are chains with established user bases that they could build on. And I think the only reason you'd want to go away from that is to have this total control. And I think that's really interesting, and it makes sense from a sort of a management point of view if you're an enterprise, because you have stakeholders that you want to report to, and you have shareholders who want you to do the right thing. And that's really good, but then there's a lot of engineering effort, and I don't think a lot of the technical stuff will necessarily improve or draw users away if you do an L1. But if you do an L2, you get most of that, almost all of that. You can still change your functionality. If you don't want to be EVM, you don't have to be EVM. If you want to do your data somewhere else, you can do your data somewhere else to some degree. But you still get to do a lot of this control. You can still hold a lot of the keys. Whether or not you should is another story, but you certainly can. But you can also on-ramp to the rest of this ecosystem without relying on other weirder bridges. And the L2 will probably have a canonical bridge itself, but also layer 0 will probably just work. And that's really easy, and that's really nice. So you get a lot of that control. And for me, it was a pretty much no-brainer that we would do an L2, not an L1, because we actually don't want to be isolated. We wanted to be connected to everyone else, and we wanted to serve this community in a way that is unique for us. And if we started our own L1, I don't think we would have had that opportunity. So I think it's very critical to stay grounded to the people building and to bring something back to them.
This is a very interesting point. I mean, we'll come back to that, like being connected to the overall community. So, Usman, you're the only L1 representative, so it feels like 3 against 1, or maybe even 4, because I probably am hardly impartial here in this discussion. So, my understanding is that you don't want to be connected to this community, right?
I think a lot of the talk around being an L1 or L2 focuses on, L2s have better access to liquidity. L2s are more aligned with the underlying chain. But I think from the perspective of most like retail DeFi users, there's really very little difference. Like they go to layer 0 front end to bridge their tokens, and they don't really know that, okay, this chain settles to Ethereum, or what settling is, or where the data layer is. There's this ongoing debate whether value accrues to Ethereum from the L2s, or if it does or it doesn't. I think it's easy to say that the L2s give more back to the chain or are closely aligned to it, but from the perspective of most of the users, I think it's very similar when they're on an L1 that has good integrations with the ecosystem and when they're on an L2. And again, most users don't even want to use the canonical bridges, right? Because they don't want to wait. They want their bridge to be done in seconds, not days.
Maybe
Can I
I can
respond to
add to
Yeah,
that
sure.
a little bit of like, the thing that makes blockchain valuable is verifiability or decentralization, right? Otherwise, use AWS, use a bank, none of this matters, right? Like it's really easy to have financial services. The thing that these properties that you mentioned, Bartek, of like liveness, censorship resistance, these all come, finality, all come from the fact that the underlying layer is as maximally decentralized as possible. The second you start putting more throughput on a L1, you're just kind of by definition, because of blockchain trilemma or whatever you want to call it, you're diluting the value of the chain that you're using. And I think this is the reason why like users might not care, but they also can use a bank account, right? So if you want any of the properties that are important to users, you need to maximize towards this decentralization so you get actual finality of transactions and a small validator that can't just reorg away your transaction. For banks, that means you reduce counterparty risk if you have real finality, not this sort of single soft finality on an Alt L1, right? You get censorship resistance, which is an important property of blockchains. And I think that's one of the reasons why like we need to scale blockchain using like actual proofs in order to have L2s built on top. That's how you get the scale into a blockchain while maintaining the #1 property that gives you any value in a blockchain.
Oh yeah, I absolutely agree. I mean, that's the reason that like we are here. We're all building these things, and like it's good that we are thinking about them. But at the same time, from a product perspective, I think users of the end apps are not always fully aware of what's the difference between this app's running on L2, this app's running on an L1.
But I think actually where you were going to go, where I was going to go, which is the end users of those apps might not, but those apps themselves might. They might have different requirements. They might have different needs. They might want something different, whether that's as simple as the virtual machine it's running on or something more advanced or more controlling. But that is a reason why you would want to actually figure out what chain you're on as an app. And there's some really good examples of this. If you want to pay for some of your users to be free because they're paying in your stablecoin, I mean, to me, that's an easier engineering lift if you're doing that on an L2. Like, to me, it seems easier to fork a stack and make that modification than to rebuild a brand new L1. But I could be wrong. I haven't built an L1. I don't know if that's true. But there are all these nice things that you can do where the users may not care. And they may care a little bit about that cost, but L2s are racing to the bottom on the cost for transactions anyway. So I'm not really sure anyone's put off by like sub-cent transactions these days. Probably there is some people, but I think we're getting so low that these other features will start to dominate the narrative over the next 2 or 3 years, because I don't know if there's a demand right now for 130 rollups at L2B tracks. Right? There will be. I think there absolutely will be, but right now there's diversification needs.
Also, from a user experience point of view or a user point of view, the nice thing of blockchain is it has value, right? So like you have this decentralization, trustless access, you have these properties, and the user doesn't really have to be aware of any of this. What this really translates to is cheaper swap fees because there's more liquidity, because those market makers don't have counterparty risk if they're using a decentralized, or less counterparty risk the more decentralized the protocol is. You get higher rewards rates, again, for the same reason that you don't have counterparty risk. From a user experience point of view, like the user doesn't have to notice necessarily, but they get the benefits of having some of the properties that blockchains offer if you design it correctly.
So maybe let's make it like super concrete and focus on specific properties. Who in the audience think that it's important that the underlying infrastructure provides censorship resistance? The vast majority, I would say. So who thinks that L2s have the edge here and they provide a better censorship resistance than L1s, independent L1s? few who thinks that independent L1s with decentralized validator sets provide or potentially provide a better censorship resistance. Okay, so that's a little bit more. I take that the rest are not sure. So let's look at some concrete data from the recent balancer hack. I'm sure that most of you might have heard about it. The balancer hack impacted a few of the chains, some of them being L1 and some of them being L2, and it's kind of interesting to see how they reacted. So the Bera chain, which is L1, they stopped the chain, they reorged, and they hard forked. As a result of the incident, I can only imagine that to do that in a very short time, they have some private signal or Discord channel so that they can actually coordinate. So while you may think they are decentralized, it's just a kind of a small group that can easily coordinate. Polygon, which is an L2, but with a very independent validator set, not posting data to L1, so they have at least half an hour to like detach from Ethereum in a way. Their validators started censoring the attacker right after the incident. Sonic, independent L1, they did an on-chain freeze, and 3 other chains were affected. You might have heard about them: Base, Optimism, and Arbitrum. And even though they have centralized sequences, which is very often cited as like one of the reasons why people say that the L1s are more decentralized, they actually did nothing. They kind of behaved as if they were Ethereum. So I'm kind of like curious, like what your chain would do if there was such an incident. Like, how would, what do you think is a proper like response? Because clearly I think we are all divided in a way, right? On the one hand, we'd like attackers to be stopped. On the other hand, we wouldn't like to be censored just because of what or where we are from, right? We are from different countries, and I'm pretty sure that if validators don't like, my country of origin and whatnot, I certainly wouldn't like to be censored. I certainly would like to preserve my property rights of anything that I actually hold on this blockchain. So the direct question to you, like, what do you think would be Plasma's response to similar accident?
Yeah, I mean, in the wake of the balancer incident, I mean, we also have, so on Plasma we have, a good DeFi ecosystem, and Balancer is one of our partners that we run, and we have, like, internally, we have alerts set up on Balancer and many of our other partners that go to us, and I'm sure Balancer, of course, has their own alerting that goes to them. So we probably would have found out about this rather quickly, like, if it happened on Balancer v3, which it didn't. And so this has been subject to a lot of discussion internally. And obviously, the decision is not up to only me, but, and I don't even mean to avoid your question, but really, I don't know at this point what action we would take in the future. I think what Berachain did and say what Optimism, others did, both, you can look at them and say they were reasonable. And I don't even necessarily think it undermines your own chain's claims to decentralization if you manage to get the validators to coordinate. It might, like, that is an example of social consensus, and doesn't mean that, say, the foundation has the whole validator set in their hands, right? Which, I'm not saying, I don't know much about Berachain specifically or the validator set, but also Sui, which has, at least probably a pretty good decentralized set. In the wake of their last hack, I believe they managed to hard fork and censor their attacker. I don't know. It's a tough question to say, right?
I mean, we know what Arbitrum did. Arbitrum, out of the 3, is actually a stage 1 rollup, meaning for those that don't know the details of this stage classification, we can circumvent potential censoring of Arbitrum by forcing transactions via L1 and assuming that Ethereum doesn't censor, which is realistically impossible, we would get our transaction through. Lomi, do you think this is a proper response? I mean, this is the systems that we should be building?
Honestly, like, it's one of those things that as a user, if you lose money, that's a horrible situation for you, right? Like you relied on a protocol bouncer in this case that you assume that should be safe, right? You're not really auditing yourself, so you have to trust someone in there. It's super hard for the user because that's not a good eventuality for anybody involved, other than the attacker, I guess, is having a nice day that day. But this is really difficult, right? Like you go down this extremely slippery slope if you start reorging transactions. You're not just affecting those people that actually got hacked. Like someone might have just bought a Ferrari on your chain, and if like this happens on L2, now someone's out of Ferrari and the money, or the cash, right? We can't just fork away specific parts of the state. That's kind of one of the properties of an L2. And honestly, I think it's up to the different blockchain builders or DAOs in our case, to decide on a direction, but we are trying to inherit decentralization and verifiability from Ethereum, because that is the majority, like I just said, is the majority of the value of blockchain. That's what makes it powerful. So I feel very bad for the people that got affected, but this is one of the things that you do when, as an L2 that tries to follow the values of the L1 itself.
I guess same question to you guys with this caveat that both zkSync and Circuit right now are stage 0, which in practice means that you may not be able to actually force this transaction. I mean, you may try, maybe there is a facility, but there is an operator can actually censor you. And I know that it did happen in the past in zkSync. Because also there was a security incident, and the operator decided to censor the attacker. So I'm kind of like curious, is there an incentive for you guys to actually put the effort and get to stage 1, which is what at least part of the Ethereum community, including Vitalik, really wants?
Yes, the very short answer is yes. We want to get stage 1. I think it's very important for the community. It's like for users, if they decide to go to the chain and trade on a chain and they see the stage 1 badge, actually I think it's very good that we have layer 2 bit and users can be aware of these properties. They can distinguish different chains. And I think it's just different values that you get from such a chain, right? It can be good or bad values because it really depends on the scale of the incident. If you imagine the incidents that touch the whole ecosystem and, let's say, 90% of funds are affected, you definitely want to roll back from the chain. And on layer 1, we have a social consensus that allow you to do that. On layer 2, you don't. And so I think it's important to have mechanisms that will allow you to react on incidents, regardless of stage 1 or stage 0. For me, it's just a matter of tooling that we have, how we coordinate internally. We should be prepared for any kind of incidents. And with regards to stage 1, I think we're not protecting only users, but we're protecting ourselves as well. Because if you're a stage 0 rollup, you can be targeted to censor someone specifically. You can be a target to get a private key of the operator, to do some malicious activity, whatnot. So this is important for both chains and user, and I think this is, we have incentives to get there.
What do you think about all this, Jan?
Yeah, so I think I'm going to shock some people here. But first, let me start by saying I definitely want to get to stage 1, but it's going to be a bit of a different consideration for us at Zirkit. Zirkit, if you don't know, was purpose-built to stop hacks like the ones that affected Balancer. We have built into our sequencer an integration with various security providers that detect these hacks occurring on other networks in real time. We actually would have been able to detect Balancer if they were on our chain and stop that transaction from hitting our L2. People would not have lost money in the short term on Zirkit. And we were purpose-built because we were tired of people losing this money. Now, that doesn't mean we should censor indefinitely or indiscriminately. I think there is a place for a quarantine, but even a couple of hours could have saved a lot of people some funds in the Balancer incident. And building out that functionality is what we aim to do. So, I don't want to say we'll never release things from quarantine, but we would have stopped this, or at least a big part of it. We know that the security partners we used detected it, so we would have caught it. That transaction wouldn't have hit our chain, and there would have been no complicated reorgs. It would have just been, a bit of a hiccup for that attacker, and everyone else would have been living a pretty good life, including those people who had the money. So, I think that's one of the perks of the L2 is that I can choose to, solicit that value and share that value and say on my chain, You don't have to worry about that, and you won't have to hear platitudes of, oh, I'm sorry you lost money in DeFi, because I think the reality is people don't have the time to audit. There's a whole wall of auditors behind me when this panel is over. There's big business here, which is fine, but it's very complicated, hard business. And if you're an institution trying to come on chain, I don't think an L2 operator saying, oh, sorry, we lost your money is going to be very happy for them. Like they have, a lot of money invested in it. So I think, playing the role of being a good cop, if we can do it effectively, if we can do it in the right circumstances, is very valuable. And L1 should not do that. I 100% think L1 should be 100% censorship resistant. It should be sort of the Wild West. That's what it's designed to do. But on L2, we get all of these, like every time there's a conference like this, there's a hack before it. Some period of time, it's never been a safe 3 years, right? That's sickening. And I think we're going to scare people and not grow the pie unless we take pragmatic actions in the short term. And that doesn't mean, Zircon needs to do this in 30, 40, 50 years. I hope, we've gotten better. But in the interim, let's help the people who we're trying to onboard.
But I think that's a good point, right? So there's a distinction of L2s, right? Every L2 is different. For Arbitrum ecosystem, there's Arbitrum 1. And Arbitrum 1's goal is to scale Ethereum without compromising on its values. Because again, these get hairy, these situations become hairy of that's basically censorship, right? So who's censoring? What government requires you to censor, which then might affect your rights, your civil liberties, as well as your financial freedom. It might affect some countries or group of people's freedom, like the Canadian truckers that got all their money frozen. That's basically instilling that same value. That being said, we have the Arbitrum stack, and there's many different chains configurations that you can deploy. So if you're an enterprise that needs to follow certain legal guidance, you can launch a chain that has different properties, right? So Bartek was referring to Arbitrum 1, and I think it's important to separate that there might be, exactly like you said, there's different chains with different applications. There's different users or operators of chains that need different product market fit requirements.
So let's move to the second, I think, most important feature, which is safety. And my understanding is that one of the reasons why you want to have L2 versus L1 is that it's extremely difficult to actually launch a secure decentralized validator set, right? When you are L2, you're essentially tapping to 300 billion worth of economic security, whereas chains like Plasma, I checked today, you guys, token is bottoming, I'm sorry to say that, and the market cap is $500 million. How can you secure more than 5 billion worth of assets with only $500 million of tokens worth security? Is that a concern, for you guys? Are you guys concerned? Because some of the DeFi protocols have more TVL, like Maker, Aave. I don't know. I'm genuinely curious how you kind of think about it.
Yeah, it's definitely a concern, and like most new L1s or even L2s, we're undergoing a process of progressive decentralization, right? We just launched mainnet a couple months ago, and right now we still run our validators, and we're in the process of going to a point where this is going to be a problem. But for the time being, it's not the economic safety that's doing it. It's more of the operational and software security that is doing it. Very similar to a a single sequencer L2.
So are you saying that there's a closed small validator set right now running Plasma?
Yeah, right now the validator set is exactly that.
What do you guys think about this problem? Because I don't know. I'm genuinely curious.
Yeah, no, I think you have to attach to where the security is. I think years ago there was all these cross-chain bridges, and you could just exploit the weakest one. And you had L1 season there for a little bit. I don't know if it was a formal era that we all agree on, but there were smaller chains, and some of them got 51 attacked, and then you attack the rest of the bridge. That's not right.
Was always my dream, by the way, to get enough Chihuahua tokens to get the majority of validators and go through all the Cosmos chains and steal everything because I've got Chihuahua, but I'm still secretly buying Chihuahua for all you know, right?
Yeah, I think that economic security is hugely important, right? Again, that's what contributes to decentralization. That's what contributes to removing counterparty risk. I think if you're not paying attention to that, you're putting users at risk. The institutions that use this chain should really be aware of this, because for at least the risk, or market makers, at least for what percentage of risk they're willing to take or how their users might be affected, it should be one of the top considerations. And it goes to finality, which I'm sure you'll bring up, but it goes with finality too, the economic security behind it.
I mean, like, some of you, assuming, are aware of governance attacks, right? We had these types of attacks in the wild, if you like, and major DeFi protocols are generally concerned. Like, for example, MakerDAO was always known from having this facility of the emergency shutdown if there was an attempt of a takeover. I think this is hugely important, frankly. But also, we have witnessed takeover of some chains, right? And that's also very interesting, you know, when you think about your assets, how easy it is to do that type of governance takeover by malevolent parties. Assuming that whoever is running the chain is always like benevolent, you know, may end up really bad, I think. But yeah, but that's just my take. So, so you've mentioned that for end users, if they want to tap the liquidity of the overall ecosystem, they can use layer 0, for example, right? You know, and this is the reality actually, and I actually agree. Like, layer 0 is hugely successful protocol. For those that don't know how layer 0 work, this is the essentially interop infrastructure that allows any app to define, let's say, their own security. The way you do it is for every single path between the different blockchain, you define, you know, essentially the security module, if you like. As you can imagine, you know, if you want to be on 50 different blockchains, you know, there's like 50 square paths. So as a result, it's super fragile, right? It's extremely hard to configure. And because of that, most of the protocols like fall back to default, right? So you're essentially secured by default layer 0 security, which is in most cases 1 EOA or 2 out of 2 EOAs, right? That's what you get. This is what you are secured with in reality. Do you think this is a concern? Because like, one of the main reasons why people choose L2 over L1 is that they can actually trustlessly tap into the whole liquidity of Ethereum, right? You know, there is a way to build a trustless bridge. That's what makes you the true L2 and the rollup. There is no such way to tap into this liquidity of L1. You have to use layer 0. So I'm kind of curious about your take here.
I think it's definitely a concern for like integrators like us. You have to take, you know, careful care to understand what these things are, and you can't just sort of YOLO your way into
It's like super complicated, and
yeah,
everybody like literally gives up.
No, yeah, I mean, before I started my role at Plasma, I had no idea what was really involved in doing, you know, working with layer 0, like at all the layers, right? But if it's not uniquely complicated though, right? We have lots of different things that are in the stack of an L1 or an L2 that you have to make sure you configure correctly and, you know, have the right parameters, understand what they are. And I think as an implementer, that's just one of the many difficult things we have to do. And then for the users, they basically have to trust that you did that one correctly along with all the other things that they're assuming that you did correctly. And I mean, they use L2Beat to figure out who's doing well, but there isn't a totally transparent or easy to understand way for normal end users to figure out whether you did this right or whether you did other things right. It's like they go on basically Twitter and like, oh yeah, who seems like they're the coolest L2? All right, yeah, Optimism, Arbitrum, yeah, I heard those a lot. They're probably safe. I think that's like describes the thought process of a lot of users.
Okay, so since we're bashing layer 0, I'm sorry by the way, layer 0, if you're like here, you know, like we love you, but we need to address the elephant in the room here. Layer 0 tokens, omni-chain tokens, Arbitrum is not just Arbitrum chain, it's also a stack, and you can like create your own chain using the Orbit stack. And at one point, Arbitrum was promoting this strange, in my opinion, solution to create an Orbit stack with omni-chain token powered by layer 0 as a gas token. What do you think about this idea, Lumi?
This is like one important thing to understand for bridges in general is one bridge does not equal just a bridge, right? And I was actually really happy about the announcement that you guys are, like for L2Beat, is refocusing on the bridges aspect as well, because like users are not aware of the risk, right? And they should be, and there should be some education. So for example, like if you have a wrapped asset bridge and you go from one to another, you carry indefinite risk. That's the user's risk. The risk is on the user. If it's intense with the LP bridge like across, then the risk is on the LPs, and at least they're financial actors that can calculate risk, understand this, put that into the fee, while the user still staying safe, right? Going from one chain to another, like besides L2s, because you have a single source of truth, just can't be by definition as safe as either of the protocols that it connects to, right? It carries that, like that risk of the weakest link, right? There is like, this is one of those things of like, I might have my opinion on a design of how you should run your chain, right? But the reality is, like, we have the saying of your chain, your rules, right? Different enterprises, like USDC is a good example of that. That's a mint and burn token the same way that the layer 0 OFT standard is. So at that point, you're basically trusting the security of Circle. Right, and at that point, you need to be aware of that. Like, it's not a natively minted asset. If you use USDC as your gas token, like, your counterparty Circle, right? So there is some inherent, like, considerations there that, like, the chain operator at the least should be aware of and inform their users. It's gonna show up in one form or another as fees or something else to the user, but it's definitely something to consider. Like, my personal favorite design is ETH as the gas token, and then you can use paymasters to pay transaction fees in USDC, for example. But that's my personal opinion.
zk-Sync seems to have always been like super like firm on the security and using zk proofs and with elastic chain and whatnot, shared security. You guys seem to be taking the hard route. And I wonder, you know, how, what is like your take on this problem? Because, you know, users seem to prefer cheap and fast bridges, right? They don't understand, you know, the risks, and you guys are building this super sophisticated infrastructure with real-time zk proving to make sure that, you know, all the liquidity in the whole Elastic network is safe. It feels like you're climbing a high mountain, the hardest wall, you know, like the most risky, with the most effort.
Yeah. Okay. So first of all, it's indeed hard. So to build all of this infrastructure, to build zk circuits, to build all of the smart contracts that we have, it's indeed hard. Like, it's a lot of work, but I think it's worth to do it. When you have a lot of bridges and they have different economic guarantees for user, you basically you're paying for this. And when I say you're paying for it, it's a user who, using the liquidity from one chain to another, they need to use different entities across the chains that they're using. And they're not following the core, the part of the blockchain. They're not using the execution environment that they're working on right now. But instead, they need to switch from one environment to another, get liquidity on another chain, which just requires to be paid for. And so I think the cool feature about layer 2s in general is that we inherit security from layer 1. And when one chain inherits security from layer 1 and another chain also inherits security from layer 1, they can trust each other. That's what we're building in zk-Sync. Basically, we have an ecosystem of different chains, and each of them can trust implementation of each other because they're using the same code base. So there's no difference of me trusting on zk-Sync or trusting the abstract chain. So then when you have also fast prover, you build this stack of technologies, and then when you have it all together, you can build a fast bridge. And the cool feature about fast bridge is that money is not moving from one side to another through exchanges, whatnot, but they're moving through the zero knowledge, basically. You're proving the different chain is correct and you can use it for transferring funds. So it's almost the same as transferring funds inside the same chain. It's become cheap, and user will like that it's cheap and fast and not that it's secure. But you get it like just, as a side effect.
I do think there's like a future direction of like, zk-Sync's design is very cool, right? But it exists in a silo. And I like ZK Gateway. I like the interop. I was part of that process, right? But I think like you're still building a silo. And for security, yes, it's better, right? For finality, you're still trusting ZK Gateway in between. And so the risk is shifted somewhere else. There is like an ultimate design for Ethereum itself to consider over a long run, which is enshrining onto L1, like a proof aggregation, data aggregation layer. You'll probably have to have shared bridges. It's going to be years away, right? In the meanwhile, like Arbitrum, like the user shouldn't have to be the risk onto sophisticated financial actors rather than the user itself. And you can use assets across any chain.
I'll just add that, like, I agree with most of these statements, but I think that building out stuff because it's hard is one reason we really want to do it, because everything might not be solved by more ZK proofs everywhere, but a lot of things might be. And I think we're in the dark ages of sort of simplified bridges right now that don't use a lot of the ZK tech or other OIF frameworks or other interop, and there's so many of them now. I think we'll look back in 5 years and think, oh wow, how did anyone bridge like they did back then? But having someone to champion these efforts is really, really important, because everyone else in the ecosystem learns from them and can improve on them. So I think it's worth doing.
Usman, we don't have much time, so I'll ask a strategic question direct. And I know you've been with Plasma for a relatively short time, but this is recorded, so for everyone to know. Do you think there's a chance Plasma will do the Celo move, which is to do L1 for a couple of years and eventually come back to daddy and become an L2?
I mean, I think no.
Oh boy.
Like, I'm not going to put it on record that this will never happen, but I would maybe put my money there.
What about you guys? Is there a chance you'll do the DYDX thingy and detach from Ethereum at one point, because you will feel that your ecosystem is so strong that you don't need Ethereum anymore?
Okay, I think that we get much of Ethereum right now. That's the properties that we get from security, we get liquidity. There's so much benefits to be on Ethereum right now, there's no way we will detach from it. There's a lot of contradiction. If you want to detach from Ethereum right now, it would be a lot of work. And also it doesn't make sense, at least in the current state. I don't oversee that it can happen to any of current layer 2s, that they will have so much of liquidity that all of the layer 1 liquidity will be there, so they can start thinking about building the same as on Ethereum. And at the end of the day, you will need to do the same hard work than Ethereum did in the past. So it just doesn't work, and it's really hard to do it socially.
I think the answer is absolutely yes, right? The only way, if we knew a better way, that would be great. The only way to actually scale a blockchain to tens of thousands, hundreds of thousands, millions of transactions, which real products need, is to do the L2 strategy, right? If you just increase the amount of throughput on an L1 blockchain like DYDX, then basically you're just having to dump a crap load of, it's not a fixed cost, it's a variable cost. And Solana, for example, basically inflates somewhere around $5 to $8 billion a year that is dumped on the community, that they're not really aware of this. At some point, that starts getting unsafe, or it starts getting easier to capture, the economic value goes down, and you can attack the protocol that way, which translates to user risk, right? So I think we'll all converge on, it might look different. It might look like sharding, it might look like L2s, basically the same concept. The idea is somehow you get a shared layer of security and verifiability from underlying construction.
Yeah, I mean, I think everyone's going to stay ETH aligned as much as possible. For Zirkit, probably that's always going to be the case. But going off as an L2 to do your own thing just will add more confusion. I've also heard stories of other L1s, building out new consensus mechanisms, and then the exchanges come and they say, well, what's the tip of your chain? And they can't answer it because they did something really cool and something different. And it just adds technical complexity, and that doesn't grow the ecosystem. So doing that is a really, really, really big risk, in my opinion. And it will not help us get more users, because if people can't talk to each other about one unified language, which I hope is Ethereum, but maybe it's not, who knows, we won't grow as a space. And I think we're all here to grow the space. So I don't want people to be super different. Sorry.
My last question, because we are at the time, and I'll use it to do the shameless promotion. Do you guys love or hate L2 beat? How do you see our role in the space here? And should we look at L1s as well?
Yeah, I'd love if you looked at L1s.
L2 Beat is amazing. The value they contribute to the L2 ecosystem is tangible. They work as coordinators between, they work as the police on the beat. Not really police, but you get the point of like, I really appreciate working with L2Beat on a regular basis, and I think it's really important to have this sort of like independent actors looking in and holding people accountable.
Yeah, can't agree more. It's an amazing project, and I realize that how much you contribute to the ecosystem and to the end user.
I think you need someone taking a look at other things. So, I'm glad it's you guys and glad someone's doing it. I think mostly love is the right answer.
It's kind of amazing how this community actually wants to be policed, right, themselves. That's probably what makes us different from TradFi, that want to do whatever they do, in a very obscure way, right, and opaque. At the end of the day, we all want to be transparent in what we do, and we want to be honest. Thank you so much. That's been a pleasure. That's been lovely.
One question from my side. Bartek, when L1 beats, you don't have enough work yet, so.
Yeah, external police helps me do my job, right? Look, Bartek's roasting us every day. So I need L1 beat.
Yeah, well, think about it. First, we have to fix interop. This is much yeah, that's on our agenda at the moment. Once we fix interop, and then we fix assets, and then we fix RWAs for you guys, and we fix wallets, and we fix some other things, we'll go to you.
Okay, so next week.
Thank you.
Cheers, thanks so much.
All right, thank you to our panelists. Just in case you didn't know, this is the infrastructure session. If you've seen me on panels and at DevCon and DevConnect, you probably know that it's a topic that's quite close to my heart. We did spend a lot of time and effort securing smart contracts, and I genuinely believe that the next iteration should be the infrastructure layer. We have a whole bunch of talks scheduled for this session. I'm pleased to introduce our next speaker, Maciek, who works with L2Beat. He's a software engineer at L2Beat. He's going to tell us a bit more about the risk frameworks that these guys have implemented to, again, keep L2s honest. Please welcome Maciek on stage.
Okay, so hi everyone. My name is Maciek. I work at L2Beat as software developer. And in today's talk, I want to tell you why DeFi security really starts at the chain level. We'll look at what that means in practice, why it matters for users, and how at L2Beat we are trying to make those risks clear and easy to understand. So yeah, DeFi has matured last few years. We've gone from experimenting with small lending pools to protocols that now secure billions of dollars. To put that into perspective, Aave alone is now comparable to mid-sized traditional bank. In terms of asset locked, it would actually rank as 42nd largest bank in the world. That's how big DeFi has become. At the same time, we moved beyond Ethereum. The action is now spread across dozens of L2s. Users interact with these chains every single day, often without realizing how different they really are. Most users don't think about the chains at all. They look at the protocol, they compare yields, and they jump between deployments to chase the best return. From their perspective, Aave is Aave, Uniswap is Uniswap. These are battle-tested contracts running for years in production. Nothing can go wrong, right? But this creates the fundamental problem. Let's take Aave as an example again. It looks the same on Ethereum, on Base, or Arbitrum, Linea, Ink, Scroll. The logo is the same, the interface is the same, even the contracts are the same. But in reality, those are completely different worlds. And that's the starting point of this talk. DeFi security does not begin with the protocol, it begins with the chain. When we say that, it's not just theory. It has real consequences for users. The question is simple. What happens when the chain stops or shuts down completely? We've already seen this tested with DYDX v3 on StarkX. When the team decided to shut it down and move on to building v4, the system still held a lot of user funds. That could have gone badly. If users had no way to exit, their asset might have been trapped there forever. But that didn't happen because StarkX has forced withdrawal mechanism built in. And even after operators stopped running the chain, users could still exit safely directly to Ethereum. You can see it on the chart. After a shutdown announcement, the total value started dropping from around $1 billion down to around $30 million today, but the remaining funds are likely just forgotten. But overall, it worked exactly as intended. That's what real user protection looks like. It goes beyond audits and solid contracts. It's about what happens when the chain stops. And if the chain doesn't give you the guarantees to exit in every situation, your funds are never truly safe. So because all of these problems, we at L2Bit research all these systems. We analyze every Ethereum scaling solution, and we've built unified ways for you to see the difference and to understand in one place how secure and how mature each project really are. But when you first open L2Bit, it can be a bit overwhelming. There are a lot of colors. There is some random thing like looks like a pizza in the table. There are some stages, but it's not random. It just shows how different these projects really are. Each one makes its own trade-offs, and we try to make those differences clear and easy. So in the next part of this talk, I want to walk you through what all of this actually means, starting with the tab split. Then we will talk about this pizza-like thing called risk rosette, and finally, the stages framework. These are the core parts of L2Bit, and once you understand them, the whole site starts to make sense, and you can use it to stay safe while surfing through DeFi. So yeah, we split projects into 3 main categories. There is also the 4th one for project we haven't reviewed yet, but we'll skip them obviously today. This split is the foundation. It shows what kind of security model each project is built on. First, we have rollups. These are projects that have proof system, and they use Ethereum for data availability. All the data you need to reconstruct the state lives on Ethereum, so anyone can access it. That's a big step in the right direction. Then we have Validiums and Optimiums. These are projects that also have proof system, but they don't use Ethereum for data availability. Instead, they rely on external DA layer, like Celestia or EigenDA, but they also use DA Bridge, which is a set of contracts integrated into proof system that verifies that the data actually exists. It connects the external DA layer back to Ethereum security model. It, of course, also introduced more trust assumptions because now you depend on this DA layer and DA Bridge, both working as intended. And then we have others. These are projects that are missing something fundamental. Maybe they use external DA layer, but without DA Bridge. Or they use Ethereum for data availability, but they don't have proofs. Or they have proofs, but they are closed to few limited actors. These are the most trust-heavy setups. In this table, you can, of course, also see what each project is exactly missing. But this split is all just a foundation. This is just a starting point, because to really understand how chain is safe is, we need to look where the actual risks are, and that's where the risk rosette comes in. It shows you the 5 main areas of risks for each project, with each slice representing an assumption you make when using that chain. Green means strong guarantees, yellow partial trust, and red means you are depending on someone. In a moment, we will go through each element one by one with some examples so you can easier understand what this risk looks like in practice. First element is state validation. It answers a simple but crucial question: how is the system state verified? Green slice means there is fully functional proof system deployed, it's permissionless, and delay attacks are bounded. And this is exactly the case for Arbitrum. Yellow slice means proof system is safe overall, but it can be affected by delay attacks. That's when the operator slows down proof submission or challenge resolution to slow down withdrawals. Yellow can also mean that the whitelist is used, but with at least 5 external actors that can use them. And here we have Quinto, and the red slice means requirements aren't met, there is no open source code, or proofs are just basically not deployed, and here we have Blast with no proofs. Another element is data availability. It tells you if all the data needed to reconstruct the chain state is available. Green slice means data is posted to Ethereum, that's a true rollup, anyone can access it, perfect solution. Here we have Base, which uses Ethereum blobs for storing all of its data. Yellow means data is stored on external DA layer, and DA Bridge is used. We've already talked about this setup on Validiums and Optimiums page. And here we have Sophon, which uses Eval for DA together with the Vector Bridge. And red means data is off-chain without the DA Bridge, or it's on what we call basement DA run by a few trusted actors. Ethereum can't verify if the data actually exists. No one knows for sure. And here we have Corn, which relies on a small DAG. This topic is a bit more complex because each DA layer brings its own guarantees and risks. That's why we've built separate data availability risk framework for evaluating them. I also gave a talk about DAs and this risk framework on IFPRAC this year, so if you are interested, please scan the QR code and watch it later. Okay. So next element is exit window. It tells you how much time users have to exit if an upgrade is announced. Green slice means user get at least 30 days. This This is plenty of time to react. And here we have Facet Bluebird, with which contracts are not upgradable. Yellow slides mean between 7 and 30 days. It's okay, but you're under time pressure. Here we have Starknet with 7 days. And red means less than 7 days or even instant upgrades. Here we have Linea with instant upgrades. It might sound minor, but it's crucial because if governance can push a bridge upgrade that changes the bridge logic overnight, users might not have enough time to exit before something bad happens. Also, some systems also have security councils, which can make instant emergency upgrades. That's not necessarily bad. Councils are useful for fixing bugs quickly, but it's also crucial to set them up properly because if they are compromised, they can upgrade everything instantly. Another slice is proposer failure. So what happens if the entity posting routes to Ethereum goes offline? Green slice means anyone can post routes, or in some upchains, the system can freeze and let user withdraw through L1. And this is exactly the case for DYDX V3 that I showed you at the beginning. Yellow means there is some fallback, so governance or security council can step in to rotate proposers or post new routes. Here we have ZK Sync era with governance system that can replace proposers. And red means it's fully centralized, so if the proposer stops, the L1 view freezes, withdrawals can't finalize, and you can't get their money back, basically. And here we have Polygon ZKVM with whitelisted set of proposers. And finally, the last element, sequencer failure. So what happens if the sequencer stops or starts censoring transactions? Green slides mean user can self-sequence blocks or force include transaction through an L1. Here we have Sonium, which supports for inclusion mechanism, but more on that in a minute. Yellow means user can submit transaction to an L1 queue, but they can't force include them. Sequencer can't selectively censor specific users, but it can stop processing the queue entirely, meaning everyone is stuck. Here we have abstract, and red means there is no alternative path, so if the sequencer is down, the whole chain is down. And here we have Katana. And this metric is all about the liveness and censorship resistance, because if you can't force your transaction through, you don't really control your funds. And this is not just theory, it actually happened in practice, because it actually happened on Sonium. Its sequencer started censoring all transactions related to IBO token, which is trademark name for Sony's robotic puppy, and all the transactions related to this token were blocked. But Luca Donno from our research team proved that censorship resistance is real. He manually crafted transaction call data, force included on L1, and after a few minutes, transaction appeared in L2 Explorer, and this is exactly what green slice mean here. Censorship might happen, but at least users have a mechanism to fight it. So to sum up, the risk rosette gives you a simple visual snapshot of where the actual risks are for each chain. State validation shows if you can verify the state. Data availability is the data available. Exit window, how much time you have to react before something bad happens. And sequencer and proposer failure shows if the system can still work or at least let you withdraw if main operators go down or start misbehaving. And now that we know where the actual risks are, the next natural question is how far each project has gone to remove them. And that's where the stages framework comes in. It's a simple three-step ladder that shows the overall maturity and decentralization of each rollup, with each step removing a piece of trust, and you can see it in the rosette getting greener. First, we have stage 0, we call it full training wheels. Project post-DA and routes to Ethereum has a basic proof system, but it's still heavily centralized. Small multi-sigs and operators can upgrade freely. Then we have stage 1, limited training wheels. Now user funds are protected unless 75% of the security council colludes. Exit windows last at least 7 days, and governance can replace proposers. And finally, stage 2, no training wheels. Now proofs are permissionless, exit window lasts at least 30 days, and security council can only act in case of provable bugs like two proof systems disagreeing with each other. And as Vitalik wrote in his blog post, being stage 0 at the beginning is totally fine. You need training wheels to test things and move fast. But over time, you should upgrade towards stage 2, removing trust in people with trust in code. Yet, many projects didn't remove training wheels even after years in production. So we at L2Bit, we try to put pressure on these teams to grow up, to keep evolving, and to deliver on the promise of decentralization, because we've built something amazing in DeFi, open permissionless systems, doing what is impossible in traditional finance, but all of this still relies on the chains beneath it. So we try to make this invisible layer visible, because transparency creates pressure, and pressure creates progress. That's how we move from experiments to real things. So next time when you are bridging, farming, or just deploying more capital on-chain, don't just ask, is this protocol safe? Also ask, is the chain beneath it safe? Because that's where DeFi security truly begins. Thank you.
Awesome. Thanks, Maciek. I think we have time maybe for a couple of questions. Yep. So you raised your hand as soon as he was done. So here you go.
Hi, I'm Tom, representing Facet, one of the only stage 2 rollups. So exit window, right? To get stage 2, you need a 30-day exit window, but why 30 days? I've never seen any justification for that number, and in fact, the data you used, the argument you used favoring the exit window is very much anti-30 days. DYDX, if they had merely a 30-day exit window, users would have lost millions of dollars. They are good because they are immutable. Stage 2 should require immutability. What do you say to that?
That's a very good question. You can come to me after the talk, and we can discuss it. I can also contact you with someone from our research team. I guess they are better to answer that question.
So you were talking about stage 2 as being like the final goal of any chain, really, or any L2, but what if the intended design requires some form of centralization? I know it's a bit taboo here.
I can't hear you well. Can you
What if, for example, an app chain requires, or at least like for a good user experience, it requires centralized sequencer to be able to have higher throughput, or especially for specific applications like exchange, for example, where you want to be able for your transactions to be settled faster. Like in that case, does stage 2 as the final goal for any L2 is really optimal in that regard?
Yeah, like on our website for every app chain, we below the stage badge, we show that this is app chain, because for most of the app chains, the case is a bit different. So we are trying to analyze every bit differently, but we are showing that each one is an app chain. But if we want to talk later, we can go.
All right, maybe time for one more. Nope. Oh, good. Well, thank you, Maciek.
Thanks.
All right, next up is a person I've had the chance to interact with over the past few months. She's doing amazing work at Runtime Verification. She's the brilliant CTO of this company. Please give it up for Paulina.
Thank you, Mekti. Hi, everyone. Is it working? All right. So yeah, thanks for being here. I'm Paulina. I'm the CTO at Runtime Verification, and I'm here to talk about some of our recent experience with doing infrastructure audits beyond smart contracts and share some practical advice that I hope you guys would find useful. So what I mean by crypto infrastructure, essentially the whole execution stack that enables the interaction between the user and the smart contract. If we do look at an example that is here, which is deploying smart contract source code, we'll realize that it does go through a lot of different components, and it would be good to make sure that they are actually implemented correctly. So, for example, the smart contract first goes through compiler. It gets compiled to bytecode that is included in the transaction deployment. It is being sent to the JSON RPC node, and it should be up and running for that to happen. Then it gets included in the mempool, then it gets included in the block. Finally, the instructions from this bytecode actually get processed by the virtual machine, where it is also very important that these instructions are being executed correctly, and the blockchain state gets updated. So I did list some of the examples of the components from this execution stack here, like compilers, nodes, virtual machines, consensus protocol, the whole ZK VM infrastructure, and there are a lot of them, and that is pretty much the point I wanted to make, that all of this is code that is governing whether your interaction with the blockchain is actually safe. I did include this picture because I find it funny. And it is true that smart contract security has been pretty much the spotlight in this industry in the past years. But to be fair, we do get a lot of inbound requests for this, like infrastructure types of audits recently, and I think that is genuinely the trend in the industry. So yeah, I think protocols actually do security seriously these days. So why do I want to talk about it in general? Like, what is the difference between these types of audits and the smart contract audits? And there are a few, well, fundamental factors that are different, and the first one being the code base size. So different from smart contracts, where a few thousand lines of code is pretty much the whole project, these code bases are very different. I ran CLOC a couple of days ago on some of the clients, and here's what I got. Like, RIF, the Rust implementation of Ethereum client, is 97,000 lines of Rust, and that is like the modular, compact, efficient implementation of it. Geth, the Go implementation, is even bigger than that. Lighthouse, the consensus client, is 150,000 lines of Rust code. That is excluding tests. You might think maybe there is a problem with like Ethereum infrastructure that is so big in size, but if you look at FireDancer, which is Solana client, that is even bigger. It's 340,000 lines of C and C++ code. And of course, like with smart contracts, generally the current, the idea of the audit is that someone, like an engineer, looks through every single line of code, but that is infeasible if we are talking about, this magnitude, this code bases. So we kind of have to find some more efficient solutions. I mean, infeasible in the time frames that we usually, operate with realistically when we're talking about audits. So there are some solutions to this. I'll get back to them later. One more thing I want to highlight is that there are also different threat models and areas of concern when we talk about this type of software. So different from smart contracts, we do take care of things like chain split, denial of service, memory exhaustion. It depends, depending on the purpose of the component we are looking at. We also are trying to identify different potential issues. Like in the case of consensus, we are worried about like leader election. We want it to be fair. We want it to like not be gamed. We want consensus and execution layer to be aligned. So all these sort of things that we have to consider. And in addition to that, these components can also be implemented in different languages that have different memory safety. So just a lot of things to be familiar with. So what techniques, like what instruments do we have for actually reviewing? And well, generally all the usual suspects, similar things to smart contracts. So first of all, of course, manual review. This industry is pretty big on that, and like having a human actually look at the code is still, I think highest guarantee that we can get other than formal verification. But it does scale, as we've discussed, to this size of the code base, so we have some other techniques that we can use to scale this. Like static analysis, testing, fuzzing. I'll talk a bit more later. So what do we do with manual review? The thing we do at runtime verification is we found that for us, the best thing to do is to have like a sequence of shorter engagements where we do very focused manual review on high probability code portions. Having this like 6 to 8 weeks does help us avoid like auditor burnout. And then in addition to that, it also gives the chance to the developers to like fix some of the issues we've identified in the previous round, and then we can move on. So how do we figure out what are the high priority code portions we are looking at? Depends on the project, but it can be newer code. If some components of the code are well audited and tested, we can focus on like points of interaction to make sure that they interact well between each other. If we are looking at something that has a reference implementation, like there is a client for an EVM chain, and then there is like an EVM compatible chain, we are looking at if there is some difference between them, then that is something for us to focus on. Like one example being if like an EVM compatible chain has a different gas pricing, like if it reprices some of the opcodes, then it might lead to the denial of service, so we want to look at it like really carefully. And then of course, like really important code, like really important or unsafe. So one example being that Rust generally is considered a memory safe language, but there is a keyword unsafe that helps you like avoid some of the safety. So what we did for one of the project is we went through all the mentions of this unsafe keyword, and we made sure that the assumptions that developers are making about it being safe are actually true, and we documented all of this. And then also another approach to like identifying what is really important is to define a set of properties or invariants that are critical for this particular piece of software. That is why we strongly advocate for doing a design review first. So we spent a few days or a week, depends on the project and the timeline, trying to understand really well what does this project do and whether the design makes sense. and try to identify some properties, put together the specification, because it does help a lot in informing what is the review being focused on. In addition to that, like to scale it somewhat beyond just these key points we are looking at with manual review, we also use tool-assisted review. There are static analysis tools, depending on the language, like Cargo Audit scans dependencies in Rust projects, which is very important, especially considering this like recent influx of supply chain attacks. And we do use AI quite a lot to look at like other parts of the code base. So like anything that we don't do manual review of, and that as well. Just so we get, just in case it can uncover some more issues. And honestly, it does. We are working with Almanax, that is like an AI tool for smart contract and like not smart contract infrastructure security as well. And yeah, it's been working really well for us. It does identify issues. One trick that we've learned is that it works better if you provide specification. So if you try to ask it to not only find vulnerabilities it can think of itself, but also the difference between the specification. And one example of an issue we found this way, that cannot be more specific than that, but essentially it found a bug where the function was making assumptions about something, like some input being validated in the upward function that was calling this one, but it wasn't. And it would be really hard for the AI tool to, well, just infer it in the first run. So yeah, having the specification helped a lot, and that is something that we actually come up with during the design review stage. So yeah, it has been extremely helpful with like both parts of this process. Then what else can we do? So fuzzing is another well-known technique, extremely efficient, really nice way to also scale the security guarantees that you are trying to provide. So there are different flavors of fuzzing. We do all that I am mentioning here, but the first one is panic-focused. So that is like you try to invoke parts of the code base, like you call functions. You try to interact with the nodes through RPC, and then you just feed random, pseudo-random inputs, and you hope that it crashes. So that is what fuzzing is. It helps identify different types of vulnerabilities, like out-of-bound access, resource exhaustion, all types of crashes. The example that I have here is not from our review, and it's not blockchain specific, but I couldn't help, I think it would be illegal for me to not include it. That is from the Cloudflare issue that disabled half of the internet on Tuesday. And the reason for that was that there was a panic in unwrap call in Rust that is like a panicking function, so it just crashed with the bad input. So that is exactly the type of issues that we are trying to prevent with this type of fuzzing. We can go beyond that. We can do property-based fuzzing, where not only we make sure that when we call the function, it doesn't crash, we also assert something about what it actually does. So one example of that that we did in our audits was round-trip conversion between types. And I think, so generally the idea is that we convert some value to one type, then we convert it back, and then we make sure that the result is the same. We can do, we can serialize some value and deserialize, make sure it is the same, and we can also do more high-level stuff that we can come up with if we do design review properly. And then one more type of fuzzing that I really want to mention is differential fuzzing. So differential fuzzing involves running two pieces of software alongside each other and checking that on all inputs they do behave similarly. That has been proven very, extremely efficient in identifying bugs. It does require having a reference implementation. So depends on the situation. We can do, we can set it up differently. So one type of differential fuzzing that we have been doing is running different clients for the same chain alongside each other, making sure that they do not disagree. Because if they do disagree, then some of the nodes are rejecting a transaction, the other considers valid, it can lead to chain split or halt or God knows what. So some example of that is checking that ref is behaving similarly to Geth. The guys from Sigma Prime also published a report about a very nice engagement that did a very similar thing to one of the L1s, so I highly recommend checking that as well. And we did find an issue where essentially some of the node implementation for Solana was rejecting empty transactions and the other wasn't, so that is obviously an issue. We can do that for just different chains that, for example, are EVM compatible, making sure that the parts that are common between two blockchains really do behave similarly. We can check if implementation adheres to specification, if you do have specification, or a formal model such as KVM, which is our EVM implementation in K, that is the formal language. Or you can just, generally, if you have two implementations of the same thing, you can, differentially fuzz it. So we did this for the Rust implementations of WASM interpreter, and it also helped identify some of the bugs. So a couple more notes on fuzzing. Obviously, the setup is very language-specific and component-specific. An important thing to keep in mind is that it has to be meaningful. So some examples are that in order to test asynchronous execution, we really want to have more than one transaction or more than one blocks, depending on what is asynchronous there, because we want to make sure that we exercise the execution path that correspond to that functionality. If we are looking at the virtual machine that executes instructions, then we actually want to feed it valid instruction sequences that would mimic the actual code that is going to execute. And of course, depending on the language you're working with, that is going to be different. So if you work with Rust, to generate these structured inputs, we use arbitrary. That is a crate that has been very helpful. It is different in Go, so there is the whole toolkit attached to every language. Every language, as I mentioned before, has its own potential issues. So we didn't really find a better solution than just spending a lot of time looking at making sure we're really familiar with the code base, with what the protocol does, with the specifics of the languages we are working with. And then another thing to keep in mind is that when I'm talking about design review, understanding the protocol is very important, but that is something where AI has been also extremely helpful for us. We have been using DeepWiki quite extensively, especially in the earlier stages of the engagement, when just trying to put together a good idea of what the project does, what are the components, how they interact with each other. So that being cross-validated with the client team has also been extremely, extremely helpful in speeding up this process. And, well, I wouldn't be myself if I didn't mention formal verification. So that is the process of mathematically proving that the software is correct. As we all know, probably software formal verification is challenging, it is resource-consuming, time-consuming, requires a lot of groundwork. It relies on tools that are inherently either not very scalable or have really challenging UX. But there are still components that can be formally verified if we are strategic about it. So I mostly focus this talk on the off-chain things, but some of the infrastructure does rely on smart contracts. So, for example, bridges or L2s sometimes do use smart contracts that emit events for these events to be received or triggering some off-chain infrastructure as well. So for these contracts, we can formally verify that events are emitted correctly. We can formally verify that if they are paused, then they cannot be called successfully anymore. These are all things that we have proved for some of the L2s. And there are production-grade formal verification tools like our Control, Certora Prover, Helmush that are, that can deal with that. And then one more thing that I think we did at RV at 2019 was the verification of the Deposit 2.0 smart contract that stores $200 billion or something like that right now. So that is important to make sure that it is correct. And while formally verifying it, we actually did uncover some wiper bugs. And compiler bugs generally are really challenging to identify. So that is where formal verification does help identify issues that would be hard to find otherwise. And I think Certora, the guys from Certora also identified some compiler bugs by doing formal verification of smart contracts. If you go deeper, beyond smart contracts, we can do things like formally verify equivalence between different implementations of EVM. That is one of the projects we worked on. We proved the equivalence between KVM, our formal model, and Nethermind's EVM Yule, making sure that the opcodes are implemented and represented similarly. And we did identify some places where that was a bit different. And we can also do that with other EVM implementations like RVM, the Rust one, which is also one of the projects we were doing, which is very important because RVM powers a lot of ZK VMs. So we actually would like to make sure that it works correctly. And then, yeah, of course, we can do things like we can model protocols, we can model consensus protocols and formally verify them. That is something we've done before, and that I personally believe is better done at the earlier stages of the development process. And yeah, finally, we can also select some specific components that are small for us to reason about them efficiently, like data structures, like important operations on data structures, and this sort of things. So I would like to wrap this up with some practical advice based on our experience at RV. So what works for us best is shorter engagements or sequence of shorter engagements, because as I've mentioned, it helps auditors stay focused. It allows some leeway for the protocol developers to actually fix issues between that. and with priority in the shorter audits given to complex, critical, new, important code, unsafe. So something that is very important for a human being to look at. Then we do recommend starting with defining specifications, threat model, invariants, putting together the specification basically, and using that to inform the review. So we do both AI review and manual review against these properties because that does add like an additional dimension to the code review that we are doing, helping identify differences between the intent or specification and the code, not just vulnerabilities that are, present themselves in the code per se. We do recommend, obviously, building a fuzzing harness, and, well, first of all, because it does help identify issues, and then it also helps with the code getting evolved. If you can reuse it, then you can continue running this and see if that doesn't cover any new issues. Although the challenge with that is that it is very stack-specific and target-specific, for which we also should have a very good idea of what the project does. And then for formal verification, we'd recommend applying it selectively. It doesn't fit very well in this 6 to 8 week engagement, depending on what it is the formal verification that we are doing and what it is focused on. But yeah, generally speaking, of course, it does provide the best security guarantees out of all of this tooling. So yeah, cannot not recommend using it. And yeah, finally, we do use AI-assisted review, as I've mentioned, for extra breadth. It does help us look at the parts of the code base that just would be infeasible for us, for human beings, to look at. So it does help identify issues that perhaps we would not have been able to find otherwise within this very short time-boxed type of engagements. But it does work best when you do provide the specification. So yeah, highly recommend doing that. And yeah, that is it for my presentation. Thank you so much. I hope that has been helpful. And please let me know if you have any questions, if we have time for that.
Thank you. Thanks, Polina. We do have time for one, maybe two quick questions. Raise your hand if you have a question for Polina. All right, cool. Well, I'm assuming Polina will be around, so if you want to grab her and ask questions later on, you're welcome to. Thank you. All right, next up is Robert Reith from Accretion. He's going to talk to us about Solana bugs that you might be missing if you're auditing Solana programs. So please welcome Robert on stage. Thank you.
Right. Do I wait for a minute, or can I start? All right. So yeah, welcome to my talk. My name is Robert, and I think this screen is not working. Ah, there we go. All right. Can I get the notes on one of the screens? Just real quick. I have now the talk twice. Okay, but I can start anyways. So today I'm going to talk about Solana, and in particular some bug classes that might be less known or not as common to find in, at least from what I've seen. And yeah, my name is Robert, or Robbery online. I've been in Solana auditing for maybe 3.5 years. And yeah, that's me. Maybe you recognize me by my PFP or something. I'm the founder of Accretion, and we're a Solana-focused auditing company, so we only do Solana audits. So if you're interested in Solana audits, we're also hiring. Yeah, shoot me a message. Yeah, so while I was making the talk, I kind of realized that not all the bugs I wanted to talk about will fit into this, so I kind of decided to focus on one particular category, which is account lifecycle bugs. I think if you've been in Solana auditing, you might know that a lot of bugs come from account validation issues. So Solana has this system where you have storage is all, state is all stored on accounts. So it's always very important to validate those accounts. And most common bugs are like simply account validation bugs. But actually, there's another whole category, I would say, that is account lifecycle bugs, which relates how accounts are created, how they change, and how they move through state when they're active, and how they're, in the end, deleted again. And for this, you should know the most basic background for Solana is every account has an address. By default, an account belongs to the system program. So every account belongs to some program, and only that program is allowed to write data to an account. That includes reducing lamp words, and any program is allowed to increase lamp words. It's like the only exception. So an empty account has an owner of all 0, and all 0 happens to be the address of the system program on Solana, which I show here as like 11111111 because that's base 58 of all zeros. It's a bit confusing, but once you know that 1111 stands for system program. So the Solana account lifecycle is simply an account belongs first to the system program, then you can call the system program to allocate and assign that account to another program, for example, the token program. And then the account belongs to the token program, and now only the token program can change the state in this account, or the data. And now you have to call the token program to put data into this account, and then you have the third version of this account on the slide. And after that, you can delete this account if the program allows to delete an account. In this case, the token program allows you to delete an account, and you can reset it, basically, back to the original state. And that's the whole account lifecycle, and that's kind of all that there is to this lifecycle category, really. But what's interesting is, on top, we have the same lifecycle that I just explained. On the bottom, we have the same lifecycle again, but with a different program. So you can take the same account that you went through this lifecycle. It belonged to the token program before. And in a second cycle, you could assign it to, for example, a launchpad program, and then the launchpad program can use it, and then maybe the launchpad program can delete it again. And now, like, if you think about it, oh, this is like a piece of storage with an address that at one point in time belongs to one program, and at a later point in time belongs to another program. That's a bit of a weird kind of thing that can lead potentially to issues if you think about it. And the normal way to delete an account on Solana, I'll go back here, is that the program which is in charge of that account would zero out all the data and reallocate the account's data to a length of 0. And it will reset or like reduce the lamp words to 0. And then it will change also the owner of the account to all zeros, which is the system program. So that's the main way and the correct way to close an account. But there's also a second way to close accounts, which is simply to reduce all the lamp words to 0. And when the lamp words are 0, then at the end of the transaction, the garbage collector of the runtime will go and see, oh, this is an account that does not have a rent deposit. So we're going to delete this account, which means the garbage collector in this scenario would reset all the other fields all to 0. And that's just something you should keep in your mind. So yeah, now I would like you to just show you 6 different bugs that can arise from this lifecycle idea. The first one is, honestly, it's quite simple. Here we have like an AMM program account, and this AMM program account wants to pay some fees to the creator of a AMM pool. And for this program saves the creator's token account address in the pool's account. So it's just a reference to the token account directly. And in this case, it would be not required to be an ATA. It could be any token account, any kind of token account. So if you think about the lifecycle, the obvious issue here is that it's a token account, and token accounts can be closed. So if the owner of this token account decides to close this token account at this address, then any swap on that AMM, in this AMM pool, which then tries to transfer tokens to this token account, will just fail because the account doesn't exist. And this is a very simple denial of service. Because of this, normally you should never save like a token account address in an account in Solana. And the pattern to remember here is, if you close an account, is there some other instruction maybe that would require that account to be open? That was like a very simple issue. And very similar to that issue is this version. Here we have like a Launchpad program. And in this Launchpad, users commit USDC. And maybe they will later get tokens from that Launchpad. Or maybe they will get a refund. And for like a user experience reason, this Launchpad wants to crank the refund payment or the token payment back to the user. So the user doesn't have to go to the website and claim those tokens. And because of that, they save, obviously, the depositor for each deposit into a launch. And at the end of the launch, the crank will run and look at the depositor and then send tokens to the ATA address of that depositor. And that's a normal, very common pattern, but simply the distinction of the crank being run by the project itself means that the project will have to pay any rent if that account does not exist yet. So if the owner of the token account closes all their token accounts and then this crank is run, they will, the cranker will have to deposit rent to create that account and run this instruction. And then the account will belong to the owner, like who receives the tokens, and they can close this account and they will receive this rent that was paid for them. And on Solana, this rent deposit is actually quite significant, like 30 cents. So if you create like a Sybil network with 1,000 accounts, you can make $300. If you make 10,000, you can make $3,000. And it's a really, very easy way to like get free money. And this has happened in the past. And yeah, the recommendation here is, if you're going to pay rent for people, then maybe when they deposit in the beginning, make them upfront pay you like a rent deposit on top. Yeah, so here I explain it as well. So yeah, the third case, I think, is here it's getting a bit more interesting. Here we have like a very regular token 22 kind of relation. So on the left side, we have a token 22 token account. On the right side, we have a token mint. And on token 22, you can have those extensions. And here we have a closable mint extension. That's the very last item for the mint on the right side. And the closable mint extension says that if a mint account has a supply of 0, which in this case is the case, then we can close this mint and reassign it to the system program. And this can be done by the mint close authority. Obviously, the token account for this mint will also have an amount of 0 because otherwise the supply wouldn't be 0. But nonetheless, in this situation, with both amount and supply being 0, we can close the mint account. And then, once it's closed, we could go ahead and assign, like recreate a new account at this address, go through this lifecycle again, and assign it to a completely random program. For example, an attacker program that we created, which just mimics the token program and creates an account that looks like a mint but isn't a mint. And then maybe we can come up with some kind of bug where some program checks the token account and then just assumes the mint is checked as well, even though it is not a mint that belongs to the token program. So I don't think it's really often exploitable issue, this specific one, but I think we can just agree that it's kind of questionable that there can be a token account on Solana which points to a mint which is not belonging to the token program. That's like a very weird scenario which like just intuitively can lead to issues. And I think this next case here, this is my favorite of them all. And for this, I have an example with an audit contest platform. So we have two types of accounts, again, as always. The first type is an audit contest. An admin can initialize this audit contest and say, okay, this audit runs from today until like next week, and anyone who wants to participate has to deposit $100 if they want to report a bug, so that we don't have spam. And then if someone wants to report a bug, they have to call this program, they will have to deposit $100, and this creates like an account which counts as a bug report, and they can get their money back if they withdraw their report, or maybe if the report gets validated. So far so good. And now the interesting thing is what happens if maybe the contest configuration is closable, because after the contest, they might want to reclaim the rent of that account. Because if that would be the case, then we could do a very interesting attack. The admin would basically start by creating a contest and create a contest with a zero deposit and basically an expiry date that's like immediately in 5 minutes or whatever. And in those 5 minutes, they would create a bunch of bug reports for this contest, let's say 100 bug reports. For each of those bug reports, they have to deposit $0 because that's what is configured here. And next, they just wait for this contest to expire, like 5 minutes later. They could also make it like a couple of seconds if they want. And they close this contest configuration account. And now the crucial part is they can recreate a new contest at the same address. And that's surprisingly quite often the case, that you can close an account and recreate a new account at the same address. But when they recreate this account, they also don't resolve any of the bug reports. And they recreate this account, but now with $100 of deposit. And now you just wait for a couple of bug reports by real bug hunters. Maybe you make an interesting contest with very shitty code. So a lot of hunters will report bugs, and everyone will deposit their $100. But as soon as you have a couple $100 in the contract, you can take those old bug reports that you deposited $0 for, and because they now point to a contest that's valid with $100 of deposit, you can cancel those. You can cancel those bug reports and say, "Oh, I think it's invalid, so I want my money back," and you can reclaim those $100 that you never paid. So this would be a loss of funds, basically. And I call this category like a reopen sames, because you close an account and reopen a new account with a different configuration. And this can happen when you can close an account and there are references to this account from other accounts. Right. For the next case, I call it over-constrained. We have like a public order book and an order book that has to be cranked. And this crank should always work, because otherwise the order book would stop working. So it cranks to like match orders or whatever. And if you call it correctly, it should work, right? And the interesting part here is this order book PDA uses the creator as a seed, which is actually also common to use the account as a seed. But for some reason, they defined in these constraints that this creator has to be a system account. And the system account, as we know, can change the state to not being a system account. So we can reassign it to a different account. And because the developer here was very cautious and they thought, oh, I have to put a strict constraint on every account, they kind of shot themselves in the foot, because this constraint can be easily invalidated by reassigning this account. So that's another case, very simple, and actually happens more often to like experienced devs who try to put a lot of constraints and are very careful. Okay, and this is the last one. In this case, we have like a program that creates some pool, and it wants to assign a mint to that pool. So it wants to save in that pool some mint that belongs to that, like, kind of relates to that pool in some way. And for that, we take the mint account and we check for that mint account that this mint account belongs to the token program. And then we check that this mint account deserializes. And normally, okay, those are interesting checks, correct checks that you can do. But it turns out that it might not be enough to correctly validate this mint. Because what happens if the mint actually has 0 lamports? If we remember what happens with 0 lamport accounts is that the garbage collector at the end of the transaction will look at this account and reset everything to 0. So the program ownership, the data will all get reset to 0 if it has 0 lamports. So if we could maybe create a mint account, or not really create a mint account, it actually only has to be an account that belongs to the mint program. So we could maybe create an account, assign it to the mint program, allocate 82 bytes, which is the exact length that you need for a mint account to deserialize. Then those checks would pass, and this assignment would just complete correctly. So the path here would be have a random account, assign and allocate to the token program. It's all 0 bytes at this point because we never call the token program. And then we call this weird instruction, and this instruction will check, oh yeah, this account belongs to the token program. Okay, 82 bytes, it deserializes, all the values are 0, but we didn't check that. And now at the end of this transaction, the garbage collector will go and see, oh, this account has 0 lamports, we're gonna reset it to 0. So now it belongs to the system program. And now what we have is a dangling pointer. So we have again a case where we have an account which stores this pool.mint, but this mint is not a mint, but actually it's just a random account that belongs to the system program, and we could assign it anywhere. And yeah, I mean, that's it. That's like this category of lifecycle bugs, which is quite an interesting category. You get mostly denial of service, but sometimes you get loss of funds bugs this way. And to spot it is actually quite easy. You just look at how accounts are closed, which accounts are closed, and maybe there exist references to accounts when they are closed. Can we create maybe a dangling pointer? That means like a reference to an account that it doesn't exist anymore. And can we recreate an account at an address that didn't exist, at the same address where this account existed before? Yeah. And to fix it, basically the main tip, don't close accounts, or if you have to close accounts, only delete all the bytes except for one, and that byte can act as a tombstone. Otherwise, is to use a PDA derivation instead of keyed accounts, and use monotonously increasing number in the PDA derivation path, so you can never recreate the same PDA or a recent slot, or use reference counters. So you always count up or down when accounts are created, so no dangling pointers can be created. Yeah, that's it from me. I'm not sure if we have time, probably not, for questions and answers.
I don't think we do, unfortunately, but
Yeah.
thank you so much, Robert. Thank you.
But you can find me outside and ask me directly. Thank you.
All right. And next up is another person I've had the chance to interact with over the past few years. Just an overall legend and wonderful bloke. Please give it up for Andy Beal, co-founder of Forta. Thank you.
We've got a different presentation up here, just a heads up. Maybe the next one? There we go, perfect, okay. All right, well, thank you, DSS, for having me. My name is Andy, and I've tried to give this talk at a couple conferences. DSS was the first that actually accepted it, so I'm excited about that. This is a dynamic that we encounter a lot at Forta, and so I wanted to dive into it a little bit. And I know some of the other presentations have come at this from a different angle. I'm going to come from the security provider angle where we're trying to stop bad actors and threats, and I think in that situation, censorship resistance gets a little bit more nuanced. So I guess just to kind of define a few things up front, because security and censorship resistance are big terms that I think get used a lot. From a security standpoint, today for this talk, I'm talking about preventing malicious activity and transactions from being executed on chain and causing harm. And then on the censorship resistance side, it's going to be ensuring that technically valid transactions can be executed. So that's the framing for this. Okay, reasons I wanted to explore this. First one, like I said, it comes up all the time in our sales and customer support conversations, particularly with our product called Forta Firewall, which is embedded into L2s and screens transactions pre-execution. I'll talk a little bit more about that here in a sec. My observation is that most change in protocols are fairly centralized and don't have a strong ideology. Some do, but the vast majority don't. They are simply listening to their customers. They're trying to find product market fit. They're trying to build a good business and do right by their users. If given the opportunity, and again, this is just our experience, if given the opportunity, most teams would block malicious activity if they could, particularly in advance. I feel like certainly as a security industry, we often avoid having the security versus censorship resistant debate, probably because it's uncomfortable. There's also a vocal minority of people on Twitter that will jump on you if you raise questions around this. But nevertheless, I think it's an interesting conversation to have. And then finally, I think there are very clearly situations where it's reasonable to block a malicious actor or transaction. And I crossed out the word censor there and just used the word block just because when you say censor, it invokes an emotional response in a lot of people. And if you use the word block, or as I'll share on the next slide, there are other terms that I think are easier to talk about this with. So we just stopped using the word censorship completely when we're talking with our customers and potential customers. We use other terms like risk management, risk mitigation, threat prevention. These are all like much less emotional, super boring. Most people don't want to spend any time on this stuff. But when you use that language, it's a lot easier to talk about how you deal with a bad actor or a malicious transaction. The reality is that I think every team has the ability to manage these things, risk management, how they want to. And it's going to depend on a lot of different things. We have chains and protocols that are managed by public companies now, regulated financial institutions. We have some in the US, some in Europe, some in other parts of the world. Different regulatory regimes, different considerations. You also have a lot of these products that are trying to go after different users. Some chains are trying to go after real-world assets. Well, that's a totally different segment with a different list of concerns. Others are going after, degen, DeFi users. Others are going after people that just want to play games. And so I don't think it's a one-size-fits-all. I don't know if anyone saw this, but over the last 2 weeks ago, week ago, Bybit put out an interesting report essentially looking at a big swath of L1s and L2s and wanted to understand what the sort of ability was to freeze transactions, freeze funds. And what they found was 35 out of the 166 that they looked at had some sort of mechanism built in. It was either native or it was something that was added later to, in certain situations, freeze an address, freeze a balance. And you see this come up in, large exploits, and I'll highlight two in a second. The three ways that they do it are there's a public blacklist, which is very transparent to everybody. The second is something that's a little bit more at the config level, which is usually like a private list that's kind of shared amongst validators and maybe the core team. And then you've got third parties that might plug into a sequencer or an RPC in the case of an L2 and might be able to block transactions that way. So I'm going to highlight SWE here, not picking on them at all, but earlier this year they had a large exploit on a DEX called Cetus. 223 million was stolen. SWE Foundation and validators used the native freezing feature to lock a portion of that. I assume the rest of it was moved and bridged off. And then, interestingly, validators subsequently voted to return those funds back to the affected protocol and hopefully back to the end users. And then the attack was eventually attributed to the Lazarus group. Second example, Linea, again, not picking on Linea at all, but I know this was one that got a lot of buzz online after it happened. Last summer, Velocore was exploited for a much smaller amount of money, but nevertheless, Linea made what I assume was a hard decision to halt block production for a period of time and also freeze attacker addresses and prevent stolen funds from being bridged off. They got a lot of backlash, but there were certain folks in the community that were certainly not happy with that decision and using it as an example of sort of centralization and censorship, et cetera. And since then, I think Linea has obviously prioritized decentralizing their sequencer and block production. So I think, last example here, this one's more personal to us. We have a product called FortiFirewall. We plug in directly to L2s at the RPC or the sequencer, and we screen 100% of the flow for malicious activity. And in certain situations, if we find something malicious, it could be an exploit, it could be a scam, we have the ability to tell the chain to block it, but it's ultimately up to them to listen to our recommendation or not. And what I think is interesting is, in our experience, taking firewall to market and working with a lot of layer 2 chains at least, in terms of where censorship resistance ranks in your company's priority or product roadmap, it's usually somewhere in the middle here on the spectrum. It's often not the top priority. It is a priority on the list, but there are a lot of other things that seem to take priority over that. And it's usually, in the case of L2s, it's finding product market fit, it's finding a differentiator, finding a user base, finding liquidity, et cetera. As you guys probably know, most L2s are really struggling to find organic demand. There's only a handful that have any real volume or sort of consistent user base. And so when that's the reality that you're facing, thinking about censorship resistance and things like that just aren't at the top of the list, right? What I think is interesting when you look at the Linea case, the SWE case, all the teams that use FortiFirewall, even going back to 2016 with the DAO hack, there's been a number of other instances between then. I know BNB chain has frozen addresses in the past. There's been a lot of examples. The same thing applies. You want to do right by your users. They are in some sense trusting you, and in this world, they're often trusting you with their finances, and so you want to try and protect that if you can. You're also trying to build a good, trusted brand, and so, I think that's why, honestly, you see a lot of chains do what they do in these situations. They're doing what anybody would do if you saw something happen on the street, right? I assume most people in this room would jump in and want to try and right a wrong if they saw it. This is very much in the same vein. One of the interesting best examples of, I think, where this conflicts, and this is, again, specific to L2s, but we work with chains that will come to us and they do want to do some sort of transaction screening at the sequencer. A lot of it is simple OFAC sanctions address screening. But they don't realize that, and I think the L2Beat gentleman spoke about this earlier, there's another pathway to get a transaction processed in most cases. Most chains have an inbox in the L1, and that pathway exists in case something happens with the sequencer. And that's a feature that is there. If you're using the optimism stack or the arbitrism stack, for example, those decisions were made by those two teams. And in a lot of cases, we find that the rollups, when they choose a stack, they're not fully aware of this kind of backdoor to getting a transaction through. And I'm not saying the backdoor is right or wrong. I think in most cases, it's the intention for it is great, but we're talking to them about screening transactions at the sequencer, and they're not aware that there's another way to get a transaction through. So we end up educating them on that, and then trying to find a balance. Because at the end of the day, they're trying to do the right thing. Maybe they're trying to satisfy some regulatory requirement or some request from a really important user that they have. Okay, so I think all this kind of culminates in like one big question, which is if you do want to stop malicious, non-compliant activity on chain, where's the optimal place to do it? This is probably an overly simplistic version of the tech stack, but we've got layer 1s on the bottom, layer 2s app chains, DeFi protocols, tokenized assets, and then applications, wallets, front ends, etc. at the top. And on the right-hand side here, we've got an example of the mechanisms that are used to screen, block, prevent malicious, non-compliant activity. So at the L1 level, in the past, we've seen hard forks. We have hard-coded public block lists, config file, private block lists. Those were the two methods that were mentioned in that Bybit report I referenced. We have builder-validator screening. And obviously the censorship-resistant conversation there has been alive and well for many years. At the L2 app chain level, we have firewalls. We provide one of those. There's also like sequencer-level blacklists that chain teams have. They run those themselves. It's usually OFAC related. At the protocol level, you also have firewalls that are more baked into the smart contracts. You have circuit breakers, which I'm using just to describe automatic pausing functionality. You have some teams that have contract whitelists. They don't want to let anyone other than a whitelist of smart contracts interact with their protocol, because most attacks and scams are obviously not going through wallets. They're direct contract-to-contract interactions. At the asset level, certain stablecoins have on-chain whitelists, blacklists. The concept of reversible transactions has been around for a while. There's been some white papers about this, but not a lot of adoption there. It's hard to implement, complicated. And then at the application level, there's a lot more sort of traditional mechanisms, KYC. You have transaction simulation screening via API. You've got UI warnings. I'm sure anyone that's used MetaMask or Phantom or anything like that has received some sort of warning like that. So this is sort of what the universe of experimentation has looked like in this area. And back to the question, where's the optimal place to do it? The easy answer is push all the security and protection mechanisms as high up the stack as you can. I think if you want to preserve censorship resistance at the layer 1, even at the layer 2 level, even at the DeFi protocol level, it has to go somewhere, right? These mechanisms need to exist. So where do they go? They need to go up higher up the stack. And I think when you get up there, teams tend to be more centralized. They're usually businesses, venture-backed. They have identifiable teams, and they're probably subject to certain rules. And so it would not be it's not a stretch for them to sort of bear the burden of doing this stuff. But there's a lot of limitations currently if you are limited to only doing security at those layers of the stack. At the protocol level, there's a lack of transaction visibility. Smart contracts can really only see message sender and TX origin. We tried to push an RIP through a year and a half ago about this, but there just wasn't a lot of appetite. So protocols are in some sense kind of blind to incoming transactions. And then another thing is if you actually want to introduce firewalls at the DeFi level, you tend to have to sacrifice some composability, which for a lot of teams that are trying to find product market fit and attract users and liquidity, sacrificing composability is not something you really want to do. At the asset level, again, like 99% of tokens don't have a blacklist mechanism. It's really just the large stable coins, and it's really just limited to OFAC. So that's not a really realistic place to impose this right now. And then at the application wallet level, that's where you've got certainly the most flexibility. But again, like malicious transactions don't go through the wallet. They don't go through front ends. It's direct contract-to-contract interactions. It's also hard to impose good threat screening and warnings on every wallet. So you might have the most sophisticated wallets, the most well-funded wallets do it, but smaller ones might not, or maybe they just can't afford to do it. So I think this is kind of the reality today, which is why I understand why some of the mechanisms that exist at the L1 and L2 layer are there and being used. Wanted to look at a couple examples here, just to kind of get people to put yourself in the shoes of us, or maybe a chain or a protocol that's facing one of these security events. So, simple example, this is something we encounter literally on a daily basis. You have a phishing contract deployment. So a scammer deploys a drainer contract on chain. These are really easy to detect. It's very automated, programmatic. They follow certain patterns. It's the same deployers over and over again. Contract's clearly malicious, but at the time of deployment, it hasn't caused any harm yet, obviously. No victims have interacted with it. So the question is, should the L2 block this deployment? On one hand, chain has a responsibility to create a safe environment for end users. I say that generally. And if it can, it's also in the best position to block a deployment. No one else can do that. On the wallet side, wallets should warn a user if they are interacting with this contract. And I think it's a very reasonable position to say the wallet is the only one that should really intervene in this situation, right? And obviously the user has to sort of do their own research as well and be vigilant with how they're interacting. So if you're the chain, there's always a risk that you block something benign. That's the downside of doing sort of proactive screening and blocking, right? You might get it wrong. And is that a risk that you're willing to take? At the wallet level, I talked about this on the previous slide. It's hard to force all wallets to do this. I think over time, certain standards, expectations will exist. But right now, there's some that do it extremely well. Some don't do it at all. And I think it's entirely reasonable. Again, I say reasonable to sort of fall on either side of this. We work with chains that take the first approach. They want to block the deployment, especially if there is no risk of it being a false positive. If they know it's a malicious contract with malicious intent, they're comfortable blocking that. We also work with chains that aren't comfortable doing that, and they would prefer to push that responsibility up to the wallet and put it on their end user. And I understand that position as well. I think that's also a reasonable thing to believe. Next one, this one's going to be a little bit more difficult, just because the dollar amounts are higher. So let's say a hacker exploits a DeFi protocol on an L2, but it's for $1 billion. And I'll just throw I'll add another kind of data element here. Let's say the chain only has 1.5 billion in total TVL. All right, so 70% is gone. Should the chain blacklist the hacker EOAs and freeze stolen funds? Again, if you're the chain, you obviously want to prevent an extinction event. This is your business. I assume you want it to continue. You also have a lot of users who are trusting you to keep their funds safe. You want to do right by them. If you're the protocol, there's probably some additional things you could have done, but it's obviously hard to account for everything. You can't prevent or mitigate every possible risk. You also have the ability to negotiate with the hacker after the fact and maybe get a lot of those back and pay a small bounty. So maybe the responsibility should rest solely with the protocol. The asset issuer, again, there's not a lot they can do, but to the extent there's a blacklist component in the asset that was stolen, can you freeze those funds and somehow return them to end users? Maybe. So just to kind of look at the downsides here with each alternative, if you're the chain, man, it would be very hard for me to not do anything in this situation. I would imagine it would be very hard for you also to say, our hands are tied, and let someone, particularly if it's Lazarus Group, walk away with 70% of your chain's TVL. I think that's a really hard decision to make. I think the downside, though, is if you do it once, you might be forced to do it again when you don't want to do it. If you're the protocol, again, it's really hard to anticipate and prevent everything, so it's hard to put all the blame on them. But they have certain steps they can take. And then we talked about the asset issuer. That's really not a legitimate place to sort of put the responsibility. So another observation here is I think when a chain has the ability and opportunity to intervene, we've just seen this historically. 9 out of 10 teams, when faced with a security event, are gonna intervene and try and right the wrong. Otherwise, what's the point of having the ability to do it? Which I think raises an interesting question. Long term, despite all my comments here, I'm actually really hopeful that risk management and other security mechanisms and, yep, oh, I see it now, sorry, get pushed up higher in the stack. And I think it's going to happen with more decentralization, and I think something that gets talked a lot about now, obviously, is private transactions, right? If you do those two things and you remove the choice at the L1 and L2 level, I think it makes it a lot easier for these chains to not act in those situations. But if they have the ability to do something, they're going to act like humans, and they're going to try and do the right thing when they see a wrong happen. So thanks again, everyone. Apologies, I went over a few minutes.
Thanks, Andy. Sorry, packed schedule, but thank you so much. Thank you. All right, we got our last talk of the session. Please welcome Ben Berger, research scientist at Off-Chain Labs. He's going to talk to us about economic censorship games in fraud proofs.
Right.
Ben, you're up.
Okay. When you go up, when you check. Okay. Let's see if this works. Okay. Hi, everyone. Buenas tardes. My name is Ben Berger. Thank you so much for coming to this talk. So I'm going to tell you about joint work with Ed Felton, Akaki Mamagaishvili. Both of these are my teammates at Off-Chain Labs, and with Benny Sudakov, who's a professor at ETH Zurich. Okay, so I'm assuming that everyone here has heard and knows about L2s, but still I want to give a very, very oversimplified introduction to what these are, so we all sort of have a similar mental model to think about these in the context of this presentation. So layer 2s, as we all know, this is the main scaling solution for Ethereum today, meant to increase Ethereum's limited throughput problem. And a layer 2, like any blockchain, will receive, process, and order a sequence of transactions, and the computation of each such transaction updates the state of the layer 2. And every once in a while, there will be some party which posts the current state of the L2 onto Ethereum with the goal of convincing Ethereum that this posted state is really the true result of the computation. And the idea is to offload the expensive computation off of Ethereum and use Ethereum just as a means to record and verify that the computation went correctly. So in this picture, these orange rectangles at the bottom, these are like the intermediate states resulting from the computation of these subsequences of transactions. And each of these orange states will be posted onto Ethereum at some rate. In the case of Arbitrum, this happens roughly once every hour. Okay. So of course, what is the challenge of such a system? How does the layer 2 convince Ethereum that the posted state is indeed valid? And so there are two main approaches for doing this today. There's the ZK rollup approach, which I will not talk about, and there's the optimistic approach, which is the main subject of this talk. And so how does the proving mechanism work in an optimistic rollup? Well, each interested party can submit their claim on what is the current state of the layer 2. And in case that there are more than one claimed states, then there is a dispute which is resolved via an interactive protocol, which is run and governed by a set of smart contracts on Ethereum. And this mechanism is usually called a fraud proof, a fault proof, or sometimes a dispute resolution protocol. And the idea is that at a very high level, without getting into the details, the competing parties will submit moves to this protocol, and each such move is an Ethereum transaction which sort of reduces the dispute in question in a recursive manner. And when designed correctly, these systems have the very nice property, it's called sometimes a 1 out of n property, that the honest party that represents the correct claim is guaranteed to win if, and this is a very big if, all her moves indeed get processed and included in the canonical L1 chain. Okay, so as I said, these protocol moves are Ethereum transactions, and because of that, they might be prone to censorship, which in this context is defined as any malicious activity which is intended to delay or exclude the inclusion of a transaction from L1. And in the context of fraud proofs, the censorship of honest moves, what could happen is that the wrong state can get confirmed in the end, which is, of course, a total catastrophe if this happens. And so to mitigate against this possibility, the parties in these protocols get a significant time window to have all the required moves processed on chain. And this time period is called, sometimes it's called the challenge period. In different contexts, it's called the withdrawal window. And the idea is that if a party's timer runs down to 0, then the claim that that party represents gets disqualified from the protocol. And so today, this challenge period is set to about 1 week in the major optimistic rollups. And this is aimed primarily against so-called strong censorship attacks, whereby the potential attacker is assumed to control over 50% of the L1 stake, in which case it has full jurisdiction over which blocks are added to the canonical L1 chain or not. And so this attacker will decide to remove a block that contains the honest party's moves in the fraud-proof system. So this is, of course, a doomsday scenario for Ethereum. But there are other forms of censorship that are possible, much simpler to execute. And it's not clear how the challenge period defends against these types of censorships. So this brings me to the topic of this work, where we consider what we call economic censorship attacks. And in this attack, the attacker, what it will do, so these attacks exploit the fact that the L1 block proposer at any block has full power over the contents of the block. And so the idea is that an attacker will go to this block proposer and try to bribe him to exclude the honest party's transaction from the block. So the scenario that I want you to have in mind is that if the defender or honest party that submits the move offers the proposer a priority tip, total priority tip of P, then an attacker will offer a bribe of B to the block proposer, and the bribe will be successful if B is greater than P. So, of course, if this bribe is successful at some block, then what will happen? Well, the defender's move will not get included in that block, and so its timer ticks down by 1 block, and so the time to get the moves on chain decreases. On the other hand, the attacker paid the bribe, and so its budget for future bribes decreases. On the other hand, if the bribe is not successful, well, the defender is 1 step closer to victory because it got its move in, but the defender also has a budget, and that also decreases. And so the goals in this project were to sort of try to understand the dynamics of these sorts of attacks in the context of fraud-proof systems. In particular, we wanted to understand what bidding strategies or what strategies the players will use, what are the optimal strategies, and ultimately we want to know who is expected to win this sort of contest given the parameters of the system. And in the end, we want to understand what is the meaning of all this for the security of optimistic rollups. Okay, so with this goal in mind, we studied a stylized multi-round game model between an attacker that wants to censor, a defender, which is the honest party, and the L1 block proposers. And this multi-round game is parameterized by these 4 parameters. T, this is the total number of rounds corresponding to the challenge period, the length of the challenge period. N, this is the number of those T rounds that the defender needs to win. I think of this as the amount of transactions the defender might need to put in to include in the fraud-proof protocol. A is the attacker's budget for censoring, and D is the defender's budget for getting all his moves on chain. And in this work, we studied 3 variants of this, which differ in how a round is conducted. And the main question that we try to answer is how large does the attacker's budget, A, need to be relative to the defender's budget as a function of all these parameters, such that it can guarantee victory in the game. Okay, so the first model, and now I want to explain, go more deeply into the results. So the first model that we study, we call the G1 game. This is like the most straightforward model you might think of for this, which models a world with alternating rational block proposers. And so each round corresponds to a block. And what will happen is that the defender will offer a bid B. This is like the tip that I talked before, which is upper bounded by her budget D. The attacker will get to observe this bid and then offer a counter bid B prime, again upper bounded by the budget A. Then the attacker will win the round if and only if B is smaller than B prime. And the winner of the round will get her budget deducted by exactly the amount that they bid. And then a new round begins. And so the defender's goal is to win N of these rounds. This is just a single round, what I explained here. And, well, the attacker wants to win, essentially, the T minus that. Okay. So this brings us to, and what can we show here? We show that in this game, as I presented, the attacker can guarantee victory if and only if this inequality holds. So if T minus N plus 1 divided by N times D is smaller than A. And so what this shows you is that the larger the challenge period T is, the more funds the attacker needs to use in order to guarantee victory, right? If T increases, then A needs to be bigger as well in order to be able to guarantee victory. And so this is consistent with our intuition that the bigger the challenge period is, the more secure the optimistic rollup is. And I want to go over the simple proof of this just so you get an idea. And I'm going to prove the if direction. So let us assume that this inequality holds between the budgets, and I want to show you how the attacker can guarantee victory. Well, consider the following strategy by the attacker. What it will do is it will see at any round, it will see what the defender bid. If the defender bid more than D over N, then it will just let the defender win that round. Otherwise, the attacker will match the defender's bid so that the attacker wins the round. And the observation here is that the defender cannot win the entire game because she doesn't have enough budget to win n rounds. On the other hand, the attacker does have enough budget to do this strategy and win the attacker's required number of rounds, which is t minus n plus 1. Okay. So this is like a very simplistic model, but still to get an idea, what does this mean, for example, in the case of Arbitrum Bold, which is Arbitrum's fraud-proof mechanism. So if you assume that the budget of the attacker is $15 billion, which is, depending on what day you check, is roughly the TVL of Arbitrum 1, and plugging in n equals 60, which is roughly the amount of transactions in one path of bisection that the defender will need to do, and if you plug in t equal 50,000 blocks, which corresponds to 1 week of a challenge period, then what this tells you is that the defender can guarantee victory only if it has at least $18 million. Okay, so that's what this tells us. And of course, $18 million sounds like a lot, which motivated us to sort of refine the model and so we can get better results, essentially. And so this motivated us to study the next variant, which we call the G1 sub K game. Here, K is some constant larger than 1. And this game is very, very similar to the game I showed you before. But now we have two types of rounds. We have the regular rounds, which are exactly like before. And we also have special rounds, which are conducted as follows. Basically, they are conducted in the same way like a regular round, only that in order, if the attacker wants to win the round, it needs to outbid the honest party by a factor of K. So these are rounds where it's much more expensive for the attacker to win the round. And so in addition to the parameters Tn and the budgets D and A from before, we also the game is also parameterized by the configuration of regular and special rounds. So we assume in this simple model that both players know exactly in advance which rounds are special or not, and they can maybe take advantage of this in their bidding strategy. Okay, so now what is the motivation, or where do these special rounds come from, or why do we even think about them? Well, so today it is estimated that about between 2 and 5%, depending on who you ask for the analysis, between 2 and 5% of the Ethereum proposers don't, the way that they build their blocks is not through the more common proposer-builder separation or MEV-boost framework, but instead, to build their blocks, they rely on the default block building software that is provided by the execution client, by essentially all execution clients of Ethereum. So this is they consider only what's called the local block instead of externally built blocks. And the way that this block building algorithm works, essentially, is that the proposer will look at all transactions in its mempool. It will sort them by decreasing order of priority fee per gas, and it will just include the transactions. It will include transactions in the block one by one, as long as there is still room in the block, right? The block has a gas limit. Okay? And so why is this relevant to us? Well, in the case of Bold, a typical Bold transaction in the fraud proof consumes around 500,000 gas. And when Fusaka will deploy in a few weeks, the gas limit in Ethereum will be around 60 million gas. And so what does this mean? Assuming that the Bold transaction, that the honest party is willing to put a priority fee, which is the highest one among all the regular transactions in the mempool, which is, I think it's a reasonable assumption, then if an attacker wants to censor that transaction when the block proposer is of this type, it will need to submit to the public mempool more than 59.5 million gas worth of transactions with a higher priority fee than the Bold transaction. And so this is where this parameter K comes from. This is 59.5 over 0.5 times as much as the defender would pay to get the transaction included. So the bottom line here is that to censor here, the attacker needs to pay 119 times more than the defender would pay to get the transaction in. Okay. So now just a bit more into the analysis of, or what we did here. So to recall, our goal here was to, again, understand how large the attacker's budget needs to be in order to be able to guarantee victory. So to this end, we define as a tool this curly A expression, which is the minimum budget A, such that the attacker can guarantee victory given the other parameters of the game. And our goal here is to calculate curly A, basically telling us how much the attacker needs to bring to the table. And so we prove first the lemma that this curly A is linear as a function of D, and also that its only dependence on the special round and regular round configuration is just on the number of special rounds, but not on their location within the entire sequence of rounds. So what this means is that we can redefine curly A to be just a function of Tn and S, where S here now is the number of special rounds out of those T rounds, which is the minimum number R, such that the attacker can guarantee victory given Tn and S if and only if the ratio between the attacker's and defender's budget is at least R. So this was a lot to digest, but just to give a flavor, what we proved in the first theorem for the simple model is that in the case that there are no special rounds, but that was the previous model, curly A of Tn and 0 is T minus n plus 1 over n. So this is the ratio between the minimal ratio between the budgets such that the attacker can win. Okay, so for a very long time, we tried to find a closed form, like a nice formula for this curly A, but we couldn't. But what we did do is find a recurrence relation that it satisfies. So basically, there are these boundary conditions that allow us to compute it for like edge boundaries, and we also have the recursive step that tells us how to compute curly A of Tn and S given like smaller instances of this function. And so I'm not going to go over all of this, but the observation from this is first of all, because of this recurrence relation, this means that we can compute or calculate this curly A in time which is O of T and S via dynamic programming. And this is feasible to do for the parameters that we find in practice. And also another artifact of the proof is that the optimal bid by the defender is always a fraction of our budget, which only depends on Tn and S. So it doesn't depend, we don't need to assume that the defender knows the attacker's budget or something like that. So if we believe this model and we, again, plug in the relevant parameters for bold, we find that this ratio is 2,718, which, again, if you assume that the attacker's budget is $15 billion, then now the defender only needs $5.5 million in order to be able to sort of mitigate this economic censorship, as opposed to the $18 million from before without special rounds. Okay, so I'm not gonna go over all this for a lack of time. I just want to talk a bit about future work and like what we can take from this. So this was like this work is sort of an initial attempt to incorporate this very realistic possibility of economic censorship on L1 to the fraud-proof context. But this is still, a simple model, and there are many ways to extend it to sort of get more insight for the practical relevance of this. So, for example, as an example, in Bold, or I think in most other optimistic rollup systems, the attacker can effectively increase n by placing a new stake in the protocol. So how do we include that in the model, and how will that change things? I think it's important to understand. Another thing is that the bids and the budgets that we talked about here really only capture the priority fees that are paid to the proposers, but not, for example, the base fee that is burnt, and so the proposer presumably does not have interest in that. So that also should be incorporated in future work. And one last thing is that, I'm finishing 10 seconds, is to consider more refined utility functions or happiness functions. So here, the defender really only cared about winning or about winning. So he didn't care about how much of his budget was sort of spent for this purpose. But in practice, of course, the defender would want to both win the fraud-proof protocol and while losing as less of his budget as possible. So I think that that is also an interesting direction for researchers. So
thank you,
yeah,
Ben. Thank you so much. Sorry, running out of
time. My apologies.
Cool. Hopefully Fossil can help fix some of these issues. Hope everyone learned a bunch of stuff in this infrastructure session. This was the last talk of the session. In this room, in about 2 to 3 minutes, we'll have a series of lightning talks. I think about 8 or 9 lightning talks. Yeah, hope you had fun. I had fun emceeing this. I'll see you guys around. Thank you.
Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love. Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. Tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for Tonight we will fight for the right to stay alive, 'cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life. And we'll always keep on dancing. We are breathing love. We're fighting for love tonight.
Should I start?
Yeah, go ahead.
Hello, everyone. Welcome to the first lightning session in DSS. This is going to be a fast-paced session. Each speaker will have 5 minutes to introduce their topic and ignite your curiosity. We're going to cover a wide range of topics relating to security, privacy, censorship, AI, and stablecoins and all kinds of attack surfaces. It's going to be packed with action. So let's start. And first is Nir Megenheim, CEO of Eureka Labs.
One, two. Hi, everybody. My name is Nir. I'm CEO of Eureka Labs. And in the next 5 minutes, I'm going to talk to you about something very, very cool that I think everybody should be aware of. Either you're a developer of a DeFi protocol, an auditor, or even if you're, God forbid, a white hat attacker trying to attack a protocol. I think it's something that you need to understand that it's going to be in your war chest pretty soon. When you're looking today at the way that flash loans work, the main limitation they have is that you can need to borrow and repay the loan at the same transaction. You cannot do anything across multiple transactions using basically a flash loan. This is done by getting any type of loan from Aave, Balancer, Uniswap. Basically any protocol that has liquidity allows anyone to borrow an infinite amount of capital completely under collateralized. So when you're, for example, auditing a protocol, you need to be aware of anyone having this tool in their war chest trying to do something to your protocol. What we're developing on top of our block builder on Ethereum mainnet, which is going to go live in Q2, is something we're calling intra-block loan, which is an extension of a flash loan that allows anyone to borrow uncollateralized loan for the duration of a whole Ethereum block. So this enables user to basically run any type of strategy, from MEV strategies to any type of attack they want on a block level. You can take a loan at the beginning of a block and anytime later repay it. Basically, this is done because we as a block builder have atomicity over an entire block. So we're able to verify the solvency of the loan. We're able to give anyone any amount of money they want completely uncollateralized to run this. And this is something that I think everyone should be aware of, that pretty soon it's going to be live and it's going to be available to anybody who wants to do anything they want with this. So a few examples of things you need to be aware of when you're auditing or developing a protocol. I'll give 2 examples of things that could be done with this. The first one is any type of oracle manipulation. So think about any oracle that needs to be updated mid-block. An attacker can take in $1 billion loan in any token they want, do something, either change the price of index or any other thing that they want, wait for the oracle manipulation, oracle update to happen in the middle of the block, and then later on do the attack with the capital that they borrowed from the intra-block loan. At the end of the block, they only need to repay this. So you need to be aware that multi-transactions attacks are available right now. That's just one quick example. The second one, which I can't take credit, I remember talking to this with someone and he said he's going to do it, is let's say you know that there's a DAO resolution that is about to be settled in a specific block. And in that block, the DAO smart contract is going to take a snapshot of the token holders to decide their voting power on that resolution. So if you know exactly when that resolution is about to happen, you know exactly what block it could happen. You can, in a way, sandwich it, basically borrowing a large amount of that token at the beginning of a block, staking it, waiting until at some point of the block that snapshot is going to be taken of the holders with you as one of the major holders of that token. And then at the end of the block, you unstake it and you basically repay the loan. You didn't make any money, of course. You paid the fee of the loan, but you gained a substantial amount of voting power in that resolution. There's a lot of different use cases that could be used. We're very focused on MEV. Either we're talking about like front running or sandwiching or yield basis. We talked even examples. People told me they're going to use this for airdrop farming across multiple transactions. There's a lot of cool things that people will be able and will do with this. And I think if we're looking from an auditor perspective, it's something that you need to be aware of, that this exists. It's not longer, the attacks are not only happening on a transaction level, they're going to start happening on a block level. And if I can give you a small teaser, it's actually going to be in the future be able to be done on multiple blocks. So we'll be able to give users uncollateralized loan for more than a single block to be able to run complex strategies, complex, I would say even attacks. And it's definitely something that everybody should be aware. So just to finish, how auditors can stay ahead of this. So when you're thinking right now, you're auditing the code, a lot of times you're thinking about a single transaction. What will happen here will be the call stack. How will this basically go back? You need to start thinking on a block level. And in the future, I can tell you even on a multiple block level. You need to think that whoever is going to try to attack this is going to have basically infinite amount of money in any token they wish to do basically anything they want. And you need to be aware and design your protocol and basically audit it according to that. I'll finish it with saying I think that the next wave of DeFi exploit are not going to happen in the smart contract level, but actually going to be on a mempool perspective. And I think we should all be aware of that, and you should all know that this is going to happen. Thank you.
No. Thank you, Nir. And next up is George Lukovicic, software engineer from DDoB.
Just waiting for the slides. Good. So, ERC20 tokens. We're all using them, be that in providing liquidity, voting on governance, or just plain trading. They represent fungible assets. So, essentially, you can hold and transfer amounts of them. But that leads to a few assumptions. We assume that we are solely in control of our balances. We assume that we may transfer amounts that we own at any given moment. But tokens are programs implemented by arbitrary code. As a result, there is nothing to guarantee that these assumptions hold. That falls on us. So, how do we go about it? First, we could try and simulate the actions we're planning on taking with regards to the token before actually performing them. So, say you're going to trade a token. You could first go and find the holder of the token. Here I'm using our own solution, DeFi Security Suite. And then, once you've got the address, you can go to Foundry and try and simulate the transfer from that address to whatever other address and check that the new balances match. And we can see here that they do not. There is a tax on transfer. But even if there was not, even if the simulation came back clean, we're not safe yet. You see, it's rarely the case that you're going to sell the token the moment you buy it. So what if now you're able to sell it, but that's no longer the case in the future? In fact, that's exactly how honeypots work, right? There is some part of the code that may disallow certain addresses, or all addresses but the owner, from interacting with the token. So, how do we check for behaviors that are not currently observable, but may be enabled? Well, we could inspect the code. As a matter of fact, how many of you hold USDT? Well, good. So let's take a look. We can see here that you're only able to transfer USDT if you're not blacklisted. So there goes our second assumption. We can also see here that once you get blacklisted, the owner may wipe your balance. So that's our first assumption. And we do actually see that there is an owner. It's not renounced. So this could realistically happen. Now, there is a whole social context outside of code that may allow us to trust Tether. But the point I'm trying to make is that there is more to tokens than one might think. Now, we were only able to do that because we have access to the source code of USDT, as that was provided to us by Tether. That's not always the case. You see, more often than not, when a token is first deployed, we do not have access to the source code. Coincidentally, that is also when it sees most of its price action. So, what do? Well, we turn to the compilation. You see, we might not have access to the source code, but we do have access to the executable. And that is in the form of EVM bytecode. Now, unless you're running the EVM stack machine in your head right now, this should not tell you a lot. But one of the things we do at DDoB is that we provide a decompiler, which can take this and turn it into this. Now, this we can actually inspect for all kinds of behaviors, from posing to blacklisting to anything. Now, there was a whole section in this talk regarding automating this process. Because honestly, you cannot be doing all this for every token you're planning on interacting with. But alas, we don't have the time. So I will tell you that what my team tries to do is to automate this process. And if anybody is interested, you're more than welcome to come up to me after this talk. Thank you.
Give it up to George. And next up is Prasanna, Protocol Research Lead from Anchorage Digital.
Hi, I'm Prasanna. I lead protocols research at Anchorage. And I'm going to be talking about how we have built a system for visualizing raw transactions into human readable format at Anchorage, and we are open sourcing it. But I want to step back a little bit, and we'll actually present. This talk was actually stated to be presented by my coworker, who is a founding engineer, Victor, and I ended up. We've been working together to come up with this mechanism. We built this as an internal tool inside Anchorage to support multiple chains that Anchorage builds on as an institutional custodian. But what we found was, because these DeFi transactions were so opaque, retail was getting attacked a lot more while we were building all these things for institutions. Quick show of hands, would you sign this transaction? Do you know what these 4 bytes means? Anyone? Does that look familiar? Yeah, that's transfer. But why do we even have to translate that, memorize these 4-byte characters, right? Why couldn't we express, we have these programming languages and these systems? And by the way, this is exactly the snippet that got Bybit hacked for $1.9 million, a billion. And there's also another problem. If you have been following the standards processes, there's a ABI and standards trap. If you might have access to the ABI, but you may actually not know what the intent of the programmer is, because that intent is expressed in code. It's actually, you can write, so this is a snippet for the same contract, not exactly the same location, but permit to contract in ERC 7730, which is a static JSON. Whereas when you look at code, you have these assembler blocks and byte byte munging, all of those sorts of things. So what we realize is we need a real programming language to be able to map these transactions into something human readable. And we've built it in a way that actually supports way beyond Ethereum. And that's visual signing protocol. So here are two, this is a little bit early screenshot of our app, but it expresses the same. So this is something from Uniswap, standard V3 swap transaction. And we're building this as an open source framework that is chain agnostic, that translates raw transactions into these data structures. And on the right, you have Solana transaction. And we built this for Sui. We built this for a few other chains already as a way to validate that this structure works. So why do you trust this, right? Most of folks use some kind of hardware wallet. We sign everything with HSMs. To do this, we partnered with Turnkey. What happens is Turnkey has this amazing stack with StageX that is able to reproducibly build Rust code, and we're able to run it on Turnkey's enclave, and we verify it. And your wallet might have different policies. If you're a retail wallet, you might just sign it directly. If you're an institutional wallet like us, you might have other policies, but you're able to make that decision afterwards. And additionally, since I mentioned about programming languages, we want to meet where the developers are. No more JSONs, no more translations. We want to give you Solidity interfaces, Solidity types that you can translate, and you immediately get a type system so that if your code compiles, you save that SHA-256 hash, you can check against it. We've already opened up our wallet integration app. I'm doing a ETH Global. We're doing an ETH Global bug bounty. If you want to try to use our framework, try to add a couple of dApps and provide feedback, would love to have you hack on this framework. Thank you.
Thank you, Prasanna. Next up is Ruben from Quantstamp, a senior security engineer and a co-author of ERC 6900, a standard for model account abstraction. Take the stage.
All right. Hello, everyone. My name is Ruben, and I'm going to talk about ERC 4337 paymasters today. We've audited most of the heavily used paymasters out there, so our client list includes Alchemy, Pimlico, Trust Wallet, and many more. I want to give a mini overview over ERC 4337, but it's going to be extremely challenging in the time window. So basically, it's an additional abstraction layer on top of the Ethereum transactions. Users no longer submit Ethereum transactions, but so-called user operation structs. They send these to bundlers, which bundle many of these user operations into a single Ethereum transaction, with the target contract being the entry point. And the entry point is this canonical contract, which basically orchestrates the validation phase and the execution phase of each user operation. In the validation phase, essentially the on-chain interaction gets unlocked, the account wants to do, basically on the account side with a signature validation mainly, and optionally in step 3, if a paymaster is used, the paymaster validation is invoked, followed in step 4 by the actual execution phase, where the on-chain interaction happens. An optional post-op call after the execution phase, and at the very end, the bundler gets compensated either by the account or if a paymaster was used by the paymaster in order compensated for putting the action on chain. There's generally 2 types of paymasters. So there's ERC20 token paymasters, which enable user op inclusion in exchange for equivalent ERC20 token gas payment. And there's verifying paymasters, which are usually used in sponsoring settings, where there's just a signature check being performed on-chain after a series of off-chain checks to determine if a user op is eligible to be sponsored. Think of, for example, like a launch campaign where someone wants to sponsor all the gas costs with some DeFi protocol. ERC20 token paymasters, which are the ones I'm going to be mainly talking about, have to ask themselves the question when to charge the user. So it will either be as part of the validation phase in step 3 or as part of the post-op call in step 5, where they transfer out the tokens from the user to the paymaster or to some other entity. Naturally, you would first think to do it in the post-op call, because that's actually when you know how much gas was being consumed. But there's some problems here because the post-op call is after the execution phase of the user operation. And the execution phase is inherently non-deterministic. A lot of restrictions are put in place in 4337 on the validation phase to have deterministic outcome of the validation phase, but that does not apply to the execution phase. In case the post-op transfer would fail, the paymaster would still be required to pay because the validation has already passed. So if a user, for example, would revoke the approval as part of the execution phase, the paymaster would not be compensated for their efforts. The paymaster can roll back the execution phase of the user operation, but still has to pay. So this is a very real gas griefing attack. And what's interesting is that the logic essentially, or the error happens like within the context of 4337 and not so much in the logic of the smart contract code, but requires the context of the standard. So you can also transfer in the validation phase, which is a better approach because then you have guaranteed payment. However, there's in total 5 user op gas limits based on the arrows I showed earlier. And you have to nail the math between the gas limit, ETH, and then the ERC20 token conversion. So all the typical Oracle and decimal issues apply we see in all audits. And also on a side note, I don't have time to go into this much, but please do not revert due to stale Oracle data, but encode it as part of the return validity window. If you have any questions on that, send me a DM. I don't have time to talk about this more. Basically, what you end up doing is you end up overcharging the user in the validation phase based on the gas limit specified. So basically, you specify the maximum amount of gas a user operation can use, and the actual usage might have been significantly lower than that. So you can return the excess change in the post-op call. However, you should be aware that there's a gas penalty of 10% of all the unused gas. That's basically the difference between the actual gas the user operation consumed and the limits that the user specified. And if the paymaster does not account for that limit correctly, then it either ends up undercharging the user or overcharging the user. Either way, there's a financial loss happening there. There's many more I would have liked to talk about, but I'm extremely constrained on time. So here's a list. You can find most of these issues on our public audit website, certificate.quantstamp.com. And also feel free to DM me on X or Telegram for more. Thank you so much.
I think so. I have it. Give a round of applause to Ruben. Next up is Hani Greenwald, founder and CEO of Olympics. Yes.
Hey guys, apologies, my slides are very last minute, and I think they're really just if you want to glaze over. But my talk today is on how AI won't replace the audit industry at all, but what we'll do is it'll clean it up. So what does that mean? AI does not replace auditors. In fact, it actually helps the best auditors. Okay, sorry, down there. Okay, so when we started Olympics in 2022, about 90% of exploited contracts were audited. That's still the case. How does that happen? Well, the top 5, 20, 30% of auditors actually don't get their hands on all the audits. And even when they do, what falls short is that they spend a lot of time on things that teams internally can do. So when we talk about AI kind of exposing the bad auditors, it's hard to see it right now. When we will see it is in this next wave once teams begin integrating AI and tooling correctly, and we'll be able to trim the fat. Okay, so what else? Yeah, I think that's pretty clear. Okay, so the industry problem today is like I said, a lot of auditors are relying on kind of a template, or how do I see a vulnerability that I've seen before, as opposed to having the time to really think about what is this attack surface, what is the intent and intended logic of this protocol, and how can I exploit it? And that's something unique to a human. Now, what ends up happening is they don't even get the time to dig into here because they're time crunched, and they're really spent just looking for patterns, taking existing vulnerability classes, and just trying to find them within the audit, which leads to, again, we're coming back to the same problem. So it's really like chicken and egg of having to go and get a second, third audit for these protocols. So it's really not working right now. Obviously, the numbers speak for themselves with the amount of money exploited, and the only solution moving forward is to integrate not just AI tooling, but really true deterministic tooling, and it can be leveraged by AI, but within the CI/CD pipeline or ahead of the audit, or even, let's say, if there are multiple auditors given to your report, to have one of them focused on tooling results. And I personally, on a biased view, think the best way to approach this problem is to have internally within a team utilizing tooling, and that tooling can be leveraged with AI, or it can just be pure deterministic tooling. What does AI do really well? Like I said, deterministic. So anything like static, if X is true, tell me why. Does that fabulously. What else does it do really well? Exhaustible. So again, I'm not talking about like LLM wrappers. I'm talking about when we're using agentic systems given really quality information. So maybe information from tools. And there are things that LLM wrappers do well, right? Like pattern driven. If we see a logic vulnerability, or not a logic, sorry, a vulnerability that we can see on multiple contracts, and maybe each contract looks a little different, and deterministically we can't solve that, but from a pattern perspective, an AI LLM wrapper would do fabulous at that. But an AI agent would do really well taking results from deterministic systems and actually orchestrating and finding where the vulnerabilities can take place. So there's a lot of things that AI does really well, and also like exhaustive, for example, like if we use AI to find every path we can fuzz, or exhaustive fuzzing, exhaustive exploration of code paths. That's great. That's also not really feasible for a human to do. So we're kind of splitting these two things, which is like, what can a human do really well and what can a machine do really well, as opposed to what can a human or machine do the same. And I think when you begin to split it that way, you begin to realize that the future of security in this space really looks like, okay, we have tooling that does all this exhaustive, annoying work, and maybe agentic systems use this tooling to produce really easily digestible results, but also we have the human using their time productively. And then that comes to like what AI can't touch. So oftentimes I talk to auditors, and we work so closely with so many incredible auditors, and they say they spend way too much time trying to understand like what is the logic of this what is the logic of this protocol, and then how can I break it? And when their time is spent on things that, again, going back, a machine can do much better, can do much more productively, I'll just say it that way. Like mutation testing, for example. Like no one wants to do that exhaustively on their own, but if they can just leverage a machine, great. But when an auditor actually has that time to understand the protocol logic, understand misaligned incentive structures, economic attacks, have that conversation and dialogue also with the team and protocol architecting it, they can do what a machine can never do. So I think that kind of brings us just to the last slide, which I'm sorry if I'm all over the place. I'm not really a slides girl. This is just something that I truly believe, so I can kind of go on a long straight tangent on it. But essentially, the auditor of the future, what it really looks like is it means internal teams audit themselves first with tooling, with exhaustive measures. And again, this isn't just AI tooling, but perhaps it's deterministic tooling where agentic systems help you. Or perhaps it's LLM wrappers in some capacity if you can get to a really good outcome with false positive rate, which is a whole nother problem. But it does not look like an auditor having all the load on their shoulder, which is probably like the biggest shortcoming of today, which is we don't set our best auditors up for success, and we set our worst auditors up to find things, even if they just use tooling, because you don't do it yourself. And then you're not able to actually figure out who is the good auditor and who is, just medium of the pack, which is really bad for the protocol, for every person who is putting money into what you've worked so hard to build. And it's bad for your company because, again, the state of your security is the state of your company. And so you really have to think about who you internally own with tooling the security posture.
Thank you, honey. Show her some love. Next up is Allison, formal verification engineer from Runtime Verification. Take the stage.
Hello, everyone. My name is Alison, and I will be talking about securing your ROS code for your projects on and off chain. So it would be a controversial statement if I said this a couple of years ago, but I can now confidently say that Rust is the new backbone of Web3. So regardless of the protocol, if you use blockchains, if you are a Web3 user, it's very likely that you use the protocol or an entire chain that has its smart contracts or its entire infrastructure written in Rust. So it's no wonder why. Rust is great because of the speed and simplicity of the code, as well as the safety, with a special highlight on the memory safety that you need to have this reliability of systems that will be running all the time for a long time. So no wonder why people are using it, and the proof of it is the TLV that you have for all the blockchains involved. Solana alone counts for $82 billion. It's an easy claim to prove that it's more than 100 billion USD in TLV between these blockchains. And yeah, if you are a user of Web3, you are a part of this. Yeah. One of the challenges that we face, though, is that not all that glitters is gold. So if Rust was perfect, you wouldn't have this map of outages in Solana, or you wouldn't be having so much money being lost in hacks in the previous few years. And that's because we are all human. We developers, we are all human. We make mistakes. No wonder. So my tip for you in this presentation is that understand yourself and you understand your enemy. That's probably Sun Tzu. You can correct me outside. I would say that for you to understand yourself, a great concept to be clear about what you're trying to do with your protocol is to raise the invariance of it. So invariants are things that are supposed to stay the same at all times. It's not supposed to change. If I talk about invariants here right now on Earth, I would say that gravity is an invariant. If I jump, I come back down. If I'm writing a protocol that is going to take Sol and wrap it and give you a token for it, I can say that an invariant for this protocol is that for every Sol that you provided, you will mint a wrapped version of that. So this is an invariant. The threat model part comes at identifying the ways that your protocol can be hurt, mainly through the means of how can I interact with it. So evaluate the entirety of your code, your protocol, your infrastructure, your smart contract, and see how can I interact with it, and what can I achieve with these interactions. The idea is to unite these two approaches to create your tests. So the tests are not just about making sure that what you developed is supposed to work as it intended. You are supposed to look for corner cases when developing your tests. Use invariant and threat modeling for that, and then you can unite these concepts with your preferred methods of testing, which, by the way, should be all of this and more, if possible. Yeah, don't shy away from using multiple techniques, as I said, and mainly do not shy away from using multiple tools as well and multiple strategies. So whenever we see developers out there creating projects, they are very frequently they focus on picking a tool, a single tool for a testing harness, for example, and doing everything into that tool. It's a valid approach, but nothing is stopping you from putting as many tools as you need or want into your protocol, in your project to test it. One very easy thing to do is to use shared tooling for Rust. For example, the cargo tools that's just a line off in your terminal that can provide you with some quick and easy low-hanging fruits, low-hanging issues in your project for you to fix. The idea is that you're going to explore the tools that are available for your ecosystem and mix them with whatever is available for Rust as well to achieve the best test coverage that you can. So do not shy away from any techniques, do not shy away from multiple tools, and do not let your chains rust. Thank you.
Thank you, Allison. Next up in the stage is Nico, engineering team lead from Aztec Labs.
Hi, everyone. I'm Nico. I've been working for 8 years trying to build secure blockchain applications. Currently working at Aztec. For that, worked with Open Zeppelin and a balancer, which turns out was not that secure. I want to discuss security in the context of privacy-preserving applications. Oh. Okay. Thank you. Yeah, okay. I can go without the slides. I think I know it by heart well enough already. So the point that I want for you to take home is that privacy must be a long-term consideration as any sort of privacy-preserving application is being built. You can't just slap CK into a smart contract and call it a day. It needs to be considered from day one and as a long-term consideration. What we refer to as security incidents, most other industries would just call software bugs, but they have much higher severity in our case due to the very nature of blockchain. Once a hack occurs, once a contract is exploited, funds are lost, systems are blocked, and there's no fixing them. The same properties hold for privacy. Once information that we thought would be secure and not revealed gets leaked and is now publicly available, there is no going back on that. We cannot put the genie back into the bottle. Sorry. Additionally, privacy applications have a sort of unique feature in that they can also fail retroactively, which is not something smart contracts typically do. Imagine, for example, the Ethereum block hash function. If we were to suspect that there may be an issue with a block hash function leading, say, to block hash collisions, we can just fix it. We can have a hard fork, fix the block hash function, and at that point, we're fine. Even if someone were to then try to perform an attack, the fact that we used it in the past is completely irrelevant. We're now using only the new version, so the issue does not apply. But consider that you instead deposit funds into a privacy pool. You deposit, some time passes, you withdraw, you now have no longer any funds in the privacy pool, and you think, that's good, it's a system I used in the past, this no longer applies to me. If the system, say years later, fails in such a way that depositors are linked to withdrawers, that may still affect you, even though you're no longer part of the system at all. Your information also is immutable, so depending on what it is, how important it was for you to have depositor and withdrawer be unlinked, this may damage you greatly. We often say that privacy is a spectrum, which is typically a shorthand for just saying that in some cases it may be okay to reveal some public data, but it also means that the expectations of users when it comes to the privacy of their information depends on the very nature of said information. If I am playing a private game of Battleship, it is totally fine if the nature of the game gets revealed as soon as the game ends. If I privately purchase coffee, that's totally fine, say, if 5 years down the line, everyone learns about that. But things like medical records, private messaging, any kind of financial interaction, there's likely no time frame in which I would be okay with that information, me thinking was private, becoming leaked. Leakage itself is also on a spectrum. Even if the underlying data remains private, you're still exposed to things like metadata leakage, IP addresses, timestamps of transactions, from which timestamps may be inferred. Any queries that are made to public nodes as data is being fetched to, say, build zero-knowledge proofs. All of those continue degrading, essentially, the privacy of the user, at which point might be as severe as revealing the underlying data itself. Essentially, all of these things put together paint a clear picture of privacy being something that needs to be considered from day one. Any loss of privacy is as severe and as final as loss of funds. Users have wildly different expectations of the security of applications depending on the nature of data, so that must also be kept in consideration. And there was a third point that I'm glossing over because of the lack of slides, unfortunately, but it was very good. Again, what I want to leave you with is any privacy-preserving application must have, from the get-go, strong considerations long-term, long after users stop exiting the system, in terms of how private information is kept and how it is stored. Thank you.
Give a round of applause to Nico. Next up is Alejandro, protocol researcher at SEI. Cheer him up.
Yep. Thank you, thank you. Hello. Yeah. Come on, let's keep it light. Yeah, bear with me, just 5 minutes. Almost done. Yeah, so yeah, welcome everyone. I'm going to be talking about censorship resistance at SEI. So some of the people here has been talking before about censorship for security, well, for the purposes of their product. In the case of SEI, we're doing an L1, and we want to make sure that our users can have censorship resistance on whatever they want to propose. For that, this is the only more convoluted slide. But you don't need to understand most of it. It's just for whoever is interested in that. The point is, SEI, like many chains, is a multi-concurrent, well, the new version of SEI has multiple concurrent proposers, which is good for censorship resistance. And here's an example of a protocol that has multiple concurrent proposers. We have 4 proposers, and they all propose the block, these values, and then they agree on, in this case, the value 0 and value 2 to be included in the chain. And so that's how you can get censorship resistance, so because you don't depend on one proposer, right? An example of a chain that's not multiple concurrent proposer, and I chose this example in particular, is this one here, where there's still 4 values being proposed by different processes, but there is one leader that is the one that selects which of the values end up in the chain. So that leader can censor you, at least for the amount of time that the leader is the leader, right? Which is, in many cases, enough. And that's what leads to what I call the meta properties dilemma. So some of you might be familiar with the blockchain trilemma. This is what I call the meta properties dilemma. And basically what it says is you cannot get good put or basically useful throughput in your chain or / reasonable pricing, depending on where you put the burden in the user or the system, low latency for your transaction and censorship resistance. And let me justify that. So if you want reasonable pricing as a user for your transaction and low latency, then you just send the transaction to the next proposer, right? But you don't get censorship resistance. That proposer can censor your transaction. If you want reasonable pricing and censorship resistance, then you keep sending the transaction to the next leader. But you don't get low latency, because the first N leaders or whatever might censor the transaction. And if you want a long latency and censorship resistance, then in a multi-concurrent proposer setting, you send the transaction to all the proposers. But then potentially, all the proposers might include the transaction, and your transaction appears N times, and somebody has to pay for that. And it's, and that's why if you pay for that, then the pricing is not reasonable. You pay too many fees, and if the system absorbs that price, which some systems do, then the good put of the system is not very good, right? It decreases by the amount of times the transaction is included. So this is a problem that many chains are facing. And here is an example of some of the chains, Filecoin, so Sui, Aptos, Filecoin, and Hedera, apart from SEI. Filecoin, interestingly, is also multiple concurrent proposer, which is a lesser known fact. And in the case of Filecoin, Sui, and Aptos, what they're doing is they're absorbing the price. So the user never pays for duplications. In the case of Hedera, actually, interestingly, the user pays for it, and that's how Hedera protects from, unreasonable duplications. So basically, DOS resistance. And also, interestingly, even though this issue exists, the way they protect from this in these chains is through trusted RPCs. So actually, the RPC is the one that can censor. Not in the case of Filecoin, though. OK, what's happening? And so, yeah, this is where we stand at the moment. And what we propose at SEI is to shard transactions. So basically, very quickly, what happens at the moment is if a user wants the censorship resistance, then he needs to send the same transaction to all the proposers, and then all the proposers might include it, and so the good put decreases by an equal factor of the number of the replication factor, and the fee is also multiplied by that same factor. What we propose at SEI is to shard with rateless encoding the transaction at the user level, if he wants to, depending on what's the censorship resistance requirement that the user wants, and then instead of sending all the bits to all the proposers, you only send one of the shards to each of the proposers. And so what you get is the same level of censorship resistance, but you only pay for a much smaller margin of the fees. And how much you pay for? Well, here is one of the results, because I'm running out of time. But here's an example of of course, this depends on many parameters. I'm simplifying for 5 minutes. But there's, of course, some metadata that you need to include for some security purposes in each of the shards. And so you get better benefits the greater the transaction size or the batch size that you are sharding at once. And so asymptotically, we reach basically the replication factor of just one transaction size for censorship resistance. So that's all. Thank you.
Thank you, Alejandro. Thank you all for joining us for this first Lightning Talk session. But don't go too far because we'll resume in 10 minutes for a panel about AI and auditing, what is hype, what is reality, and what is its future. See you soon.
Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. Tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love tonight. We're fighting for love. Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. Tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight. We're fighting for Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are breathing love. And tonight we will fight for the rhythm of our life, and we'll always keep on dancing. We are breathing love. We're fighting for love tonight.
Yeah.
We are ready for you to go up.
All right. Okay. Do you want to put this up on the stage so I can read off of it? Okay. Hello, guys. Can you hear me? Awesome. So I am Ando Joseph. We have an exciting panel coming up. It's about AI-powered auditing, and we have some of the smartest people building these tools in the house today. First off, I'll invite Hani. Hani is the founder and CEO of Olympics. Maybe give her a heads up. Yeah, cool. Let's go. Yeah, like here. Yeah, I got it.
That would make
exactly. Yeah. And next up, we have Kriel from Nethermind. He has been building AI-powered auditing tools for a while. Awesome. Let's go. And next up, we have Jack. Jack from Sherlock. You all are familiar with Sherlock. And we have Nico from Expo. Expo is like the #1 hacker on like the leaderboard of some of the Web 2 competitions. So it's awesome to like have Nico here. Okay, and okay, let's get started. Maybe y'all can do like a quick intro on like what is your tool and like what are you trying to solve? Like maybe start with you.
Great. Hi, my name's Connie. The tool suite that we built out is called the Olympics tool suite. It's 5 different tools currently, but essentially the point is to find as many findings in-house via a layered security approach ahead of going to an external audit.
Yeah, go for it.
Hi, my name is Kirill. Our tool, essentially I think that most of the tools are focused on the pre-audit stage, such as ours, and we also try to find as many issues as possible before the audit. And essentially the idea that we really believe in is that if we find, let's say, 70% of the issues before the audit, your auditor will have 3 times more time to actually find something much more serious that they could previously. Thanks.
Hey everyone, I'm Jack. I'm the CEO and co-founder of Sherlock. Sherlock is really focused on lifecycle security when it comes to securing blockchain code. And so we're building an AI auditor to help with pre-auditing, basically saving you money so you don't have to do multiple rounds of audits, as well as checking your code once you're live on chain to see if there are any new vulnerabilities that the AI can find to save you maybe millions of dollars in bug bounties.
All right, so my product is called Expo, and we are basically focused on Web 2, so I have no idea what we're going to talk about in terms of Web 3, but we basically do AI autonomous pen testers. So basically the product can go and find vulnerabilities both from a black box perspective, basically looking at your website without any information, or you can provide it source code and any sort of like development data, and it will take that information to do a much more educated penetration test.
Awesome. So, so we have seen like the AI models getting really good at what they do, right? And there are 2 trends. AI models that use tools and find bugs. And then there are entirely pure reasoning models that just look at your code base and find bugs. Maybe you can share thoughts on like what do you think is going to win? Because recently, I was listening to this podcast from Dave Datel, who leads like security at OpenAI, and their product, AdWalk, relies mostly on the reasoning side of things. And as a traditional security guy, I do reason, but I also use tools, right? So are we looking at a whole different paradigm of finding bugs using AI, or is it a hybrid mix? What are you guys finding while you build these tools? What approaches work for you today in Web 2 and Web 3? Maybe I can start with you, Nico.
Yeah, so we basically use a hybrid approach. So basically, we let the LLM go and attack like a unit of the application. So we try to basically, one of the big problems with LLMs is that they're very undeterministic, right? And you're expecting that every test you do has to be deterministic. So we separate like the attack surface into units. In this case, for us, it's like endpoints. And then we send agents that go and perform that attack. Now, the agents basically have all the tools that a pen tester will have. So like you can run like SQL map or any sort of like open source tool that are out there can use that. But it can also generate Python script and came out with their own like sample tests to do it. So we give them the freedom to do the 2 things. Tools that, obviously we have to build some tools to specifically work with LLMs. There's a couple of tools that we have to build in-house. For example, like a headless browser that we use to navigate a website and do performance attacks. But in general, we give them like the 2 things, like go and write your own sample scripts to perform like attacks, or just use some of the tools that are out there, the tools that pen testers will use to perform the attacks.
Okay, awesome. Jack.
Yeah, so right now we use a lot of reasoning, but we do use tools too. So we've built, static analyzers into our kind of reasoning, and I expect that the hybrid approach of using reasoning and using tools is going to be even more and more the approach that teams are taking. I think doing invariant testing, doing fuzzing, doing formal verification are really obvious ways that an AI is going to be working with tools to find bugs in a code base. So I expect that to quickly be something that we see some of the reasoning approaches get more and more into.
Yeah, great. Go for it.
Yeah, I would say like pretty much everybody is using a hybrid approach. But with reasoning, I would say it's just we can get there faster, like to higher level of coverage, because like ultimately I view the LLMs as a processor for the high level tasks that we give. But anyways, we break down the entire workflow to multiple stages. We use LLMs to essentially solve each part of the task separately. And the LLMs, which are smarter, essentially, they just do it faster, more precisely. And in the end, we can get faster to this higher coverage and low positive rate.
Right, awesome.
Okay. I don't think it's a one-size-fits-all, meaning I don't think the right question is what's going to win. And the reason I say this is because when I look at the historical exploits just in the last 365 days or even 60 days alone, I can see that maybe one of them would have prevented with our mutation testing tool. One of them would have been prevented with our static analyzer, one with our agentic orchestration system. And so I believe the correct answer is a layered security approach is the only approach, which inevitably leads to, okay, I agree, hybrid.
Right. Okay.
Hybrid. Okay. Cool. But what do I mean when I say hybrid, and how do we make that really easy to digest? What you see is what you know. When the data set is only historical exploits, when the static analyzer behind there is Slither and it's it can't go deep. It doesn't have the right IR and infrastructure. When you don't have all of the information present, you can't reason aggressively, I think would be the answer. So if you want to reason aggressively and find really deep findings, I think you need more information, and I believe that that information comes from advanced tools that take a long time to build. And I think historically those have been very hard to gain adoption. People don't want to implement them, but if you can make it easy for an AI agent and something exhaustive, something smart, something quick, to take it and reason and find if the vulnerability can be proven, you're looking at a whole different structure of finding vulnerabilities ahead of the audit. You're almost able to overlap at like 60, 70%, which is a paradigm shift completely.
Right. Yeah. So I'll play the devil's advocate. Assume I'm like a frontier lab. I have so much money. I have many GPUs. There are machine learning techniques like self-play, RL, reward. You can do a lot of training with very little data, with synthetic data, given like a specific kind of a bug. You can generate multiple variations of it. You can teach your model with RL what kind of a vulnerability that is and get really good with the self-play RL kind of a paradigm. And that is how they got good at coding, right? Like if you use LLMs for coding today, they got really good really fast because of these kind of advances in machine learning. So I would argue that maybe we really do lack a lot of data like the Web 2 has today, because Web 2 security has been around for a long time, but these advances in like machine learning can maybe make these base models that we use also really useful for like Web 3 security. Do you have any thoughts around that?
Well, I guess if you're saying maybe the base models will be the ones who are best at finding vulnerabilities and not some of these tools that people on stage are building, there's a lot of missing data for those base models, I think. Like Sherlock, for example, we have thousands of vulnerabilities that those base models will never have access to potentially. And so you can still get to a high level of effectiveness with the base models, but you might say if you can build on top of them and add these other vulnerabilities, then you can always maybe be a step ahead or at least be a step ahead early on.
Makes sense, yeah. So it's the niche that you guys are like in that makes you better than like the big labs. Is that a general consensus?
I guess I'll piggyback on Jack, which is he has unique data, right? And that's the claim. And I say I have unique information because my tools can abstract unique findings about the code base, and then from there we can, okay, great. But I think the overarching point is we're living in a space that is different than Web 2. And what does that mean? It means in here, you can't use probabilistic security approaches because we can't afford in this ecosystem to be 1% wrong because the incentive structures.
Right.
When we're 1% wrong, North Korea comes in and takes that 1%.
Right,
And they have 100 million a second.
Right.
Right. In Web 2, there's different incentive structures, and security is the buyer comes and the CISO comes from regulatory posture pushing that down. And I'm sure you'd agree with me, like, yes, of course, data's at stake and there's a lot at stake, but it's not the same as your company going under with an $100 million exploit in the matter of seconds. So a layered approach here, is important. And anyone who has unique data gets us closer and closer to that percentage. And the way you can measure that internally is like how many tools you use and how much effectiveness does each tool have.
Right. Maybe, Nico, do you have thoughts about that? I think there are some comments here made that Web 2 is more like CISO.
I will definitely talk through like our experience with like foundation models versus training models. And this is Web 2, so like might not relate with Web 3. But what we find out is like when we did a lot of experimental training, and we end up figuring out that like the next new model is basically beating anything that you're building. Like, and it goes with like Sonnet, ChatGPT, Anthropics. 6 months ago, Grok was like the best model to find bugs, and it was like we were very surprised about that fact. Now GPT-5 is like the very best, and like there's a big jump there. So we have been one of the things that we have been doing, and is generally recommend across any AI company, is like having like a very strong benchmarks that you can actually go and test against it. And we have seen that progress between like things that we have built ourselves, open source, and like the models as they're coming. And it's really impressive, like what is coming out of like each of the different like new models. So I'm still betting on the foundation models. I do believe still that for certain type of vulnerability classes, and that would be the case of Web3, and models might not be as trained as well as in Web 2 than in Web 3 for sure, is that for different type of like vulnerability classes, I think that like training models, there's an interesting result there, especially around like the kind of like business logic, vulnerabilities that are not very well defined and is more related with like the context of the application and how it's being used. For those, I think that a combination of like foundation models and models that have been trained for specific type of vulnerability classes could be like the solution for some of them.
Okay.
That's what we have seen at least.
Awesome. Also, one of the things you brought up, like logic bugs, right? How hard is it for an LLM or an AI agent to like find those deep logical bugs that is easy for a human auditor here to like find these bugs? Because I feel like that kind of intelligence is different from what an LLM you get from a base model, right?
Can I jump in?
Yeah, go for it.
Yeah, so logical bugs is exactly those types of bugs that LLMs handle much better than humans, because they see the discrepancy between the description, the documentation, and the actual code much easier. So this was the first case that we found out when top-tier auditor has missed an issue that has been found by super immature version of our software like a year and a half ago. This was just simple logical bug.
So with good documentation, LLM could find the difference between what was documented and what's in the code. Okay,
exactly.
Awesome.
I would say like LLMs are good at finding logic bugs. The hard part is like validate them. Like figuring out what is the like separating the needle from the haystack. What is the true positive? What is a false positive? That's where the real challenge happened with like IDORs, business logic, authorization issues. And like if the end result is not a shell but rather like an information leak, you need to, like, the LLM needs to be able to reason enough to understand that this is an information leak. And it's really complicated because, like, an info leak could be different things for different type of companies and even for different type of software. So what we find out is that especially GPT-5, the high reasoning models are getting, like, really, really well at being able to, like, validate business logic and being able to, like, understand kind of like a threat analysis of the application and the functionalities and be able to like decide, okay, this is actually something that the customer might be interested and sometimes something that is not. And we review the bugs that we are finding them with our pen testing team. And sometimes like even for us, it's hard to say like, is it really a vulnerability or not? Like in the end, like if you don't have the documentation, it's kind of like a educated guess. And the LLMs is doing similar things.
Exactly. But you had some blog post out there talking about some of the new bugs, net new bugs that the LLM has found, right? So what was the validation process was like? Because I'm sure everyone here is familiar with LLM spam. Like, this is a bug, this is a bug, that is a bug. And how do you even tell like what is a bug? And I feel like Jack runs like Sherlock, which is an auditing platform which receives a lot of fun LLM bugs. How do you go about dealing with that?
Yeah, so the validation part, I agree, it's extremely difficult. And I think Sherlock is the only one up here that has probably validated hundreds of thousands of bugs through the audit contests and the bug bounty platform that we run. And it's extremely expensive. You need some of the top human experts in the world, and you need to pay them thousands of dollars in order to properly validate these bugs, especially these logic bugs, to figure out if they're real or not, if they are in line with the spec that the team provided or not. And so this is a huge cost to finding logic bugs with AI auditors, is you actually need humans for a very long time to validate those bugs. And it's expensive and takes a long time.
So I fully agree with what you mean. And but at the same time, there is an interesting point is coming when. So currently, for instance, for validation, we encountered it recently that cursor with good context is really good for validation specifically. And this is a kind of funny case when I blindly triaged like all the findings via cursor, submitted them to another competition platform, and I got 7 out of 8 accepted. I didn't look at them at all. But we are really close to the point when AI is saying something like, this is correct because of this and that. Human is looking into that and saying, okay, in some cases yes, in some cases no. And then we do another approach when we look, something is not what we expected, like annotation is not matching to what we see, like the benchmark starts kind of saturating, and we get back, look precisely and see, oh wow, this is we who made mistake, not AI. And then this is the point when we looking into the data back and what we used for our, like, let's say not training, but at least benchmarking, and we notice that there are some new findings that have occurred while we've been predicting. We mark them as false positives and try to get rid of them, and they are correct. And that's insane.
Yeah. What we generally do for validations is, as much as possible, try to take it away from the LLM. So, for example, I don't know again about Web3, but for Web2, like if you find a cross-scripting, SQL injection, etc., you can build something that basically validates that vulnerability. Just to give you an example, like when Expo find a cross-scripting, basically we have a validator that's headless browser that will go and navigate that website, and if it sees something like a pop-up coming up, say like, yeah, fantastic, this is a cross-scripting. And and you constantly are improving those validators, because the better the agents, the LLMs are, the better are cheating those validators that you build in place. But so far we have been like very good at validating most of the vulnerabilities. Now, the business logic, the other type of vulnerabilities are the ones that are complex. But we're so far seeing like really good results for the new like high reasoning models being able to like reason about those validations and getting us like a decent amount of like true positive, false positive rate.
Awesome. Chani, do you have any comments about?
I actually don't. I feel like everyone really covered it well.
Okay, very cool, very cool. Okay, so we covered a lot about the capabilities of LLMs, and I feel we are all bullish on these things getting better and helping us do our jobs. So recently there was a blog post from Anthropic. Their models were used in a nation-state espionage. So it looks like these offensive capabilities of these LLMs are used today, and the attackers have access to these today. So as the builders of defensive tools, right, how are you helping? At what stage of the SDLC process does your tool come in, and like how are you helping the defenders, and what do you think? Are the attackers getting better at this using AI for offensive attacks? Because if you ask ChatGPT to build an exploit, it would just politely decline. But you can ask it in creative ways, right? So I think that is what is going on, but you guys are the experts. So what are your thoughts around that?
Yeah, so I think it's an asymmetry problem. Specifically about our tools, we sit in the SLDC lifecycle. We sit before an audit. We believe internally teams should decentralize security, and again, this is for Web3 ecosystem exclusively, and that they should try and find as much internally, and then you have the benefit of great audit firms that not only have audits, but also run their tool for the teams ahead of competition, so that again adds to the layered approach. But when I talk about asymmetry, what I mean is when a team is building a protocol, their job is to market the protocol, to raise money, to hire people, to do a million things, and security is this much part of it, even though the consequences are fatal, essentially, okay? Now, when you think about the person sitting in North Korea, their only job is to hack this protocol, and again, going back to asymmetry, their reward is so much greater.
Right.
So if they just get one exploit, they can pay for their year, plus their family's year, plus, and everyone loves them. They've done great. For a founder, the consequences are fatal, but not focusing on it, the incentive structures are like, also they have to hire, they have to raise, they have to do so many things that it's hard. So it's going to take a little bit more time for the industry to even out and people to begin to really implement this more aggressive layered approach. But I really have seen a shift in the last 3 years where teams are realizing that, relying on just one thing won't lead them to success, and that's just as important to them as hitting their product metrics, hitting their sales metrics, et cetera.
Yeah.
And as we see that shift in industry, hopefully, over time, we'll be able to align in terms of our technology catching up and it being implemented and so robust that our protection systems will protect us from the person who's just focused on that,
So do you guys think it's about who has access to some of the best models, or is it a skill issue? Go for it.
Okay, so what I was going to say first is that that report from Anthropic is kind of like the tip of the iceberg, right? Because can you imagine a nation state using Anthropic or OpenAI for doing the test? That's not real.
Yeah, I don't even know.
You know if someone is listening to you on Anthropic or OpenAI. So nation states attackers, Chinese nation state attacker attacking your environment from that point of view, to me is could happen, but it's not a real team. The real offensive team will be using their own models, and we know that China and Russia are building good models, as good as what we are seeing in the US.
Yeah.
So there's things are happening, and they're happening fast. That's for sure. This is the very first example of this. But again, to me, it's a weak example because we know there are much worse capabilities or better capabilities, depending how you look at it, on the nation state side.
Right.
Having said that, I think that people like us that are working on AI and offensive or in security in general, we do have a responsibility to be able to provide companies with tools that match what others are building on the dark side of the internet. I think that there's nothing different from what we're doing for a human can do. I think the big difference is speed and scale. And I think companies need to be aware that now attacks are coming at a scale they had never seen before and at a speed that they had never seen before. You used to connect a computer on the internet and 10 minutes later they will have some tool trying to test for default username. Right. Now someone can do a full attack on your environment, completely automated.
Right.
And that scale is something that we have never seen before.
Yeah. Jack.
Yeah, I definitely agree that, to what Hani was saying, there's an attacker's advantage where you can defend 9,999 attacks, but if they get one, all they need is one, and they win. So they have that advantage. I think we as builders and the good guys have a lot of advantages as well, where we can go raise millions of dollars from venture capital and really put a lot of effort behind this and sell it to a bunch of different clients that will pay us money for it. And so that gives a ton of advantages and scale advantages in terms of building an AI that maybe Russia or North Korea doesn't have the resources to build. And so I think that gives us a lot of advantages as well.
Yeah, great.
Yeah, I would add to this, in longer term, we have advantages. over the hackers, but at the same time, on shorter term, they actually have these capabilities already here, and they can spend some time specifically focused on these like potential this particular exploit or that. They can scale them already. They can automate a lot of stuff. So essentially, now is the most kind of dangerous time for the project that have been already shipped or that are shipping still in the same manner, in the same processes related to security. So in longer term, we as builders, we have a lot of means to prevent future attacks. So we manage our risks, and we can use some specific mechanisms in code, in operations, in financial incentives, and so on, to make this extremely hard and extremely expensive for hackers to, like, using whatever tools to exploit them. But at the same time, right now, probably we, in a way, we are losing because of, like, for instance, the balancer hack. I really, like, 5 years, the code was never touched. It was audited 11 times, and all the, essentially, we read that it was out of scope here and there, but, like, come on, it was audited multiple times. Developers are top-tier developers. It feels like it's just out of our capabilities to have, like, code that has no vulnerabilities at all, and now hackers got access to such great technologies to find those smaller issues. So in the end, like, I believe that this particular exploit was related to AI, and we'll see multiple like huge exploits in near future. But in longer term, the industry itself feels like more of a kind of anti-fragile, and will survive and will develop.
Got it.
I was going to say, and just to bring a little bit of controversy here, is that I think that attackers need to be right more than once. And I think that if we do the right things, that should be like the scenario. Because, like, they have to be right one time when they get into your network. But then they have to be right, every action they perform, they have to be right. Because otherwise they will get detected.
Right.
So, like, once they able to, like, find that bug that compromise you, that's a one time in, like, 99 that defenders are trying to defend. But then once they're in, there should be layers of defense that will be able to, like, have them, like, needed to be right in many, many different ways in order not to be detected.
Right,
And that's, sometimes that's what we have to aim for.
Yeah, so the recent attack Krill was talking about, it was code that was live for 5 years, and then we all thought it was solid, and then we turned out to be not true. It's similar to, like, how in Linux kernel the code lived for like 10 years, and then like someone found a bug today, right? So, Jack, you wanted to share something?
Yeah, I think there might be a slight difference there between Web 2 and Web 3, where Web 2 you have more ability to put filters in place, hopefully, multiple filters, where in Web 3, it's one transaction, you know? One transaction, and you are 20 billion gone. So it's a little, slightly different, I would say.
Yeah, and you have that luxury of, like, the CISO in place, and the CISO is your buyer, and the CISO has a full stack of tools that can assist your tool and sit in the middle. Whereas for us, buying posture is kind of determined by what that protocol feels like doing, and how important security feels to that protocol, or how much perceived, like, status quo or what they need to do, they're doing.
Right.
And it's really hard to inform because there aren't regulated standards. So you're essentially, like, living off of, okay, here's becoming the new best practice, and once enough people jump on that ship, then great, more do. But even, like, when I started in 2022, the big wave was on-chain monitoring, and no one was doing on-chain monitoring. Now pretty much everyone does it, and it's like, if you don't do it, something's wrong with you. And now the new wave is, like, tooling ahead of audit, whether it's agentic, whether it's LLM wrapper, et cetera. And now we're trying to figure out, like, what's the best practice, and then eventually, I'm knocking on wood, but everyone will be doing it.
Yeah, it's like Web3 is speed running the Web2 playbook. We will get there. And we will hopefully have layers of defenses. Another thought about all the audits we get, and we still find bugs, right? So formal verification comes up. when we discuss these things. And with LLMs, I have seen hybrid approaches where like you generate lean spec of programs, something like CVL or like lean. What are your thoughts about combining formal verification and LLMs to get a higher assurance for the code you are auditing? Maybe if anyone has done anything like that or has thoughts about it, feel free to share.
Yeah, I think it's 100% on the roadmap. I'd be surprised if we're not seeing it in the next 6 to 9 months in terms of AI auditing tools integrating with formal verification. I think the two big problems with formal verification, one of them is that on really complex code bases, it takes too long, like mathematically, it takes too long to run, and so it's not feasible. The other problem is it requires a ton of either developer or auditor effort to come up with all the rules, all the invariants, and create all of that. And AI can really help with that second one. So I think formal verification and invariant testing and fuzzing kind of get super powered with AI.
Yeah.
I would add that with formal verification, there is kind of unique opportunity to, if LLMs are very precise in programming, so very accurate. This is essentially what we are getting every new release. So at some point, you probably will have available the model that can write so much code that covers so many invariants that is impossible for any human to do. At the same time, in formal verification, the level of, let's say, cognitive resources or intelligence that is needed to run it and, at least in some attempt, get fully covered, fully correct program is much higher than just in programming or just in testing, fast testing, even fast testing. So I would a bit doubt about 6 to 9 months, but let's see.
We'll see. We'll see.
Yeah, I'll just tack on to that. I think, forget AI, machines in general are good at exhaustive tasks. Tasks that a human maybe could do, but would be, take, 3 weeks as opposed to 30 hours or 20 hours, even though it's exhaustive, compute intensive, it still is a lot quicker. And the core issues with, and then just coming back to like formal verification is like, one, it asks you to learn a second language.
Right.
2, it assumes you're smart enough to infer the right specs. I don't think everyone's the top 1%, which is like really what it takes to infer the right spec. And I think statistics would agree with me. So if you can find a way, and like, listen, if you can pay for Certora to do that for you, fabulous.
Right.
And Certora knows your code base. Majority of us don't have that kind of budget. So if you can find a way to hit those invariants and infer those specs with something that reasons correctly and infers the right logic, and maybe there's some like intermediate piece where you're putting that in human language or you're verifying its assumptions, and there's like an interactive piece, that's fabulous. That adds another layer to your, like I think that as like a mathematical score to your percentage and confidence in like, I have tested everything, and ultimately with security, it's like, what % have you tested, and that's how you can go and deploy confidently, is like, the more things you knew you did and the more boxes you checked, the lower the chance it is to hack you, essentially, yeah.
Nico, do you have any thoughts around
I don't have any thoughts. Like in Web 2, like you cannot really do formal. At the speed of code, like you cannot really do formal verifications.
Okay. I guess we have 5 more minutes, so I guess I'll have one more question for the panel, and then maybe we can take some questions from the audience. So one last question. As you build these tools, what is your #1 pain point? And what do you think, like maybe is it solved by like a next LLM update, or like what would it take to like solve that? Maybe I can start with you.
Yeah, so again, we take a very different approach than the other teams here. So I'd say the hardest thing is just building these core tools. Like we have our own symbolic execution machine. We spent years building out our own intermediate representation. We don't rely on the Solidity compiler. There's so much there that is just so expensive and such hard fundamental problems to solve. Like we all spend our weekends reading books about compilers. Like that's the truth. It's not easy problems to solve, and like building those core tools that sit under the agentic orchestration is like the hardest part for us.
Okay.
And just building that fast enough and at a speed that it gets in our team's hands, like not our personal teams, but our customers' hands. So that's the biggest thing we struggle with. We don't actually struggle as much with like leveraging AI to make it more digestible and more usable. I think that's a much easier problem to solve.
Got it. Krill?
I would say with the current level of capabilities of LLMs, there's already so many things that we can build, but as you said, it takes so much time because of the cost of the biggest models that already have capabilities to do something, and time. So you run one API call, you put a lot of data, you see how it works, you make your assumptions, next hypothesis, next run, and it costs so much money and it spends so much time each iteration. So like we could achieve much better if even with the same models, just like working on it. The other thing is I already mentioned is that the annotations of the missing annotations, so the things that we think that ground truth for the audit reports that we have or competitions, they still contain some things that were not uncovered. AI is uncovering and we don't understand, we cannot automatically find those things.
Right. Yeah, Jack.
Yeah, I talked to our team about this recently, and I think it comes down to useful context. So one example is AIs are getting better and better at having large context windows,
right.
So you can add a lot of context into them, but it's not a useful context window. Like it's very, very bad at being able to usefully use all of that context, even if you can give it to it. And the other side of useful context is just being able to, like there's a divide between the training and the inference, and it's not quite like a human would remember the flows and have the same type of memory as it goes through a code base and sees these vulnerabilities. So useful context is how I would describe it, and that's just kind of getting the base models better, essentially, you know.
Got it, like,
I think for our case is like our own speed, like we have too much things to build that we don't have enough time. Obviously, if the model gets cheaper, that's good, because like that's going to be that you can offer the service more broadly, and
right.
And the expectation is that compute was going to get, or inference is going to get like lower and lower as we go. We have seen it last year, from this year. It's insane the cost price. So we will see that tendency, and we know that's going to happen. But in our case, it's mainly like there's so many things that we have. It's kind of like a new era or a new kind of like market that is being built, and we need to like build fast enough to be able to serve that market, at least from our point of view.
Awesome. All right, we have 1 more minute. So if anyone in the audience has a question, please raise. Okay, you wanna speak to this? Mike.
Yeah. So the Web3 is, I would say, it's arguably simpler when you compare it with Web 2, because you said you cannot do formal verification on Web 2, but you can do it on Web 3. So because the number of operations are much simpler, the stack is simpler, you can model memory and so on. But when you start building these AI tools, you have systems which you can test in a very separate area. However, because everything is composable in blockchain, do you also think about modeling other systems like Uniswap Balancer and other systems that the code you're auditing right now can interact with in the future?
Yeah, I think if you're trying to audit a code base and you don't have the connection to those integrations, like let's say you integrate with Uniswap or you integrate with Aave, you're going to miss vulnerabilities and you're going to miss really important things. So that's one of the big problems, I would say, is having that big context window is super important, and finding any way to, localize where you're looking for vulnerabilities is really important. But so far, I haven't seen any good approaches to it. You really just want to have everything in context. So if you integrate with Aave, you want to have that Aave code base in context, or at least the chunk that you interact with.
Awesome. All right. That's all the time we have, folks. Thank you so much for joining me here.
Hello.
Tonight we will fight for the right to stay alive. 'Cause you know we live for the music. We are
Hello, everybody. So, in the next panel, we're going to talk about some of the crypto startups and the fact that they lack security leadership. And then we're going to explore the risks of it and the benefits there are to build an official, a formal security program from the beginning before the breach get to you guys. So I'll invite the panelists. Is there an order? Yeah, Ryan. Ryan from Gauntlet. Joe from Mandiant. Chris from Polygon. And Ido from Blockade.
Hello, hello.
Halfway through, we do musical chairs, right? We just swap.
All right, so let's do a quick round of introductions. Do you want to get started, Ryan?
Yeah, sure. So I am Ryan. I'm the head of security at Gauntlet. Go ahead, Joe. I mean, I'm going really short.
That was a
and
very
sweet.
elaborate
So
introduction.
you can go further if you
Okay.
want. But,
Tell us about Gauntlet.
Hi, my name is Joe Dobson, also go by Dobbs, and I do threat intelligence at Mandiant. And what that means is I identify and track bad guys as they move on and off chain, right? So also looking a lot at off-chain infrastructure.
Cool. So I'm Christopher. I look after Polygon security, specifically Polygon products security, and as well the smart contract engineering team.
I'm Ido, one of the co-founders at Blockade. Blockade's a real-time on-chain security platform. We work with some of the biggest exchanges, wallets, protocols, asset managers to protect various different things they build and run on-chain.
And I am Tiago. I'm a technical director at the Crypto ISAC. Basically what I do is I try to find data on and off chain, try to see how that data can help protect and prevent events and stop events, incidents as soon as possible. All right, so let's start with the topic, right? I mean, we know that a lot of the the crypto startups, they claim to have security, they claim to be a security first institution or organization, but is that really the case? So I'd like to start like with provoking the folks here to talk about like what's the real what's the real security scenario for these startups, and what's the reality, and what's the philosophy that they sell around.
Yeah, I can jump in there quick. So I've been in crypto for about 5 years now, and I've gotten to the habit where every time I see a hack, one of the first things I do is I look up who's the head of security at that company. And if I don't find a head of security, the next thing I do is, okay, well, who's the security team at that company? And I'll actually go and reach out to my network and try and figure this out. And it boggles my mind how often there is nobody. Or it's like an engineer who is double duty. Like, here's my engineer who is also the security guy. I'm like, if you're the engineer, you're busy. Like, there's no way you are also doing all of the security stuff. So I've really been probing a lot, and that was kind of like why we wanted to talk about this, is how many companies out there are actually going and building security teams. So go ahead, Job.
I think that part of it is, in my opinion, and you all can tell me if I'm wrong,
I will.
Security is not the default, right? You have to be intentional about security. It's not going to happen on its own. And so if you do not make an intentional, explicit effort to have a security practice, to do things in a secure way, to understand OPSEC and best practices, then you're not going to be secure. You are a target waiting to happen, right? A great example of this is if you fund a new EVM wallet, how long until you get your first phishing token? Does anyone know how long it takes? Less than 8 minutes until you get your first phishing token. Now imagine a new user, new to crypto, brand new wallet, first time they ever use crypto, they fund it. Within 8 minutes, they're already getting tokens sent to them that will drain whatever money they put into that wallet if they interact with them. We have to keep that in mind because the default is crypto is kind of in a bad neighborhood, right? You need to have security, you need to have best practices.
Yeah, no, I completely agree with what you both say over here. No, it's also it's a difficult sell. No, that's a problem really over here. It's like if for anybody that has worked in security, similar to people that have worked in research, for example, it's difficult to tell like let's invest in security. You know, especially if nothing happens, if everything's okay, if you know the end of the year comes and you know my boss or the CEO of the company or the founder is like, hey Christopher, you know, like yeah, I don't think we need this security thing. Like what is the return on investment? What do I get about it? Nothing happens, and that's a very difficult sell because how do you sell the fact that nothing happens is the benefit? No, a lot of people don't get it. They want that, you know, energy, that want that, you know, scrolling, ticking, you know, thing that says like, oh, amazing, good job. But yeah, in security, it's not really like that.
So Christopher, though, talk to me about Polygon's security team because I think Polygon has one of the stronger security teams in the space. I'm actually kind of jealous. Like I look at your team, I'm like, I can't build that at Gauntlet. Talk to me about how did you convince them to build out the team?
I don't know. You should tell me. You were there before me. Yeah.
Is it, so, but still, tell me about the.
No, I think you start seeing the return on investment when you know you actually see the amount of like crap that goes through your network, the amount of bug bounties that you start paying. You know, when you start to see really the consequences, and you see the consequences over time because they start accumulating. Okay, one phishing email, two phishing emails, like who cares? You know, Google will cover it. But once you start getting employees, and you know you start getting public attraction and everything else, that's when things start to accumulate, no, and compound the amount of phishing emails, the amount of bug bounties that you're paying, the amount of bugs that just the engineering team is, you know, having to fix that basically slows down. So then they start realizing like, hey, if my software development life cycle is starting to slow down because of the amount of bugs we need to fix from, you know, what is already out there, then, you know, you kind of say like, okay, maybe, you know, if we had a security team that could take care of this, that could make sure that, you know, my engineers are focusing on what they need to do, you know, which is not ideally triaging bugs and stuff like that, then it's when you start to see that return of investment. No? And the same for phishing emails and stuff like that. You don't want your IT team to be looking and triaging phishing emails, realizing, hey, is this legit? Is this not legit? You know, you want a dedicated team to do that so that IT can continue helping the business move forward.
I think, though, one way that security can provide a return on investment, right, it's still going to be a cost center, right? Even in Web 2, security is a cost center. We have to accept that. But we're in an industry that runs a lot on hype. And I think that security has not taken advantage of that. We're a victim of the hype instead of being, you know, instead of being a victor of it. In that, if we had better sharing, if folks would come out and say, "Hey, we were targeted by XYZ, and here's how we stopped it," and demonstrate thought leadership in security, that would build some hype. That would build some return on investment because that's what leadership wants. They want that attention market share, and that would help, I think.
I want to ask one thing. You mentioned, you know, security is like a cost center, right? It's been a cost center in Web 2. It's been a cost center in Web 3. You know, I think one thing that's really interesting about our industry specifically is that we're all building, at least today, we're all building ultimately financial infrastructure, like all of us, right? And at least as a user, when you think about like why use one piece of financial infrastructure versus another piece of financial infrastructure, I don't know what your answer would be, but mine is generally, it's like, I don't know, it's a thing I kind of trust, right? It's like, this thing holds my money, like, it was there yesterday, it's going to be there today. Like, that's why I go and use that thing, right? I think, like, we're in Argentina, right? We were just speaking about, like, the Cuevos, right? Like, before, right? I'm sorry for the mispronunciation. But it's like, you know, and maybe, like, maybe someone from Argentina will come and pick me up for saying this, but, like, you know, you see the local economy, right, very much, you know, not trusting other things that we would kind of in the States or in Canada, and trusting, you know, things that are more, you know, on the riskier side, or things that we would otherwise not necessarily trust in the United States. And so I'm curious, like, your thoughts as like just my point here is, you know, we're building financial infrastructure. Trust is a differentiator, right? Security builds trust. Why is it a cost center?
Yeah, so, and just kind of like kind of riffing off of that a little bit, why do we trust our money with protocols that clearly don't have security? Like, they have this advertising, like, oh, we're security first, security. And then like literally, if they don't have a security team, like why are we giving them all this money to hold on to and just like taking that massive risk when we're, like to your point, like we're complaining about other institutions not being trustworthy with our money, but like there should be a way we can check this. Like if I am going to go and put my money in DeFi into some product or some vault, I should be able to ask them, hey, tell me about your security, and it should be there should be some standard that's honest that says, yeah, no, this is what we really do. It's not just a bunch of BS on the webpage, right?
Beyond a PDF, probably, like beyond an audit that goes and says, okay, we're good, right? You should have a team. Like you should. I think that's actually a really good, like the thing you mentioned in the beginning, right? Like that check that you go and do. It's like, who is the team, right? People should probably go and check that before they put their money in different vaults and for different curators for things like that, right?
I think people basically assume that. No, if you look at the Web 2 area, actually all these companies, when you do B2B, you have these standards. You have these frameworks in order to do security. If you don't do these, people are not going to buy from you. And by people, I mean businesses are not going to work with you. They're not going to make transactions and so on. But on the B2C in the Web 2. You as a consumer, you're just assuming your bank does security. It's like basic, But in crypto, I personally believe that a lot of people think that protocols do security, that they're taking care of their infrastructure, they're taking care of their employees, of their laptops. But the truth is that probably 80% of all the protocols, if not more, don't have at all a security team, as we were talking about it. But people just think it's implicit and it's there.
So what do you say to like these wonder teams? And sorry, these things are just coming to my head here. But like these wonder teams of like, their excuse is, I've got 10 employees and we've got $200 million in TVL. We're just too small to have a security team. Like, how do you make the case for that? Or what do you say to those people? Because I've struggled when I've had to try and tell them, no, I think you really need to hire someone fast if you have that much in TVL. But
I think it's not about them, it's about the customer. And that's who they have to think about, right? Why do they need security? So that they can provide that value, they can protect the value for the consumer, for their customers. And I think a solution is, if they don't want to hire a full-time security person, they can start out with something like a vCISO, a virtual CISO, right? They can start out with someone that offers security as a service. They can get some level of advice and input, because I think that it's often that they don't have awareness of just how bad it is.
So one thing, a lot of the time people will just outsource for like consultancy firms like audits. That's obviously great. I mean, I was a consultant for more than 10 years, and every time I went into like some of the big techs to review source code, I wanted to, deliver my best and really find bugs and really get them fixed. But especially for the new companies who rely only on third-party providers, what's the benefit of that and what's the limitation of that when it comes to actually getting and growing an internal team?
right, so first of all, for auditing, I mean, at Gauntlet, we definitely outsource auditing to the expertise. Like, it's hard to build an audit team inside a company because auditing is so incredibly specialized, at least for a smaller place. I know some places do actually build internally. So you have like your Solidity coders, but having a full-time auditor is tough, so we would outsource that, right? And that is probably one of the areas where I'm really happy to outsource. Like, it works well, right? Other things in security, I prefer not to outsource, but I'll let you guys talk about that stuff first before we talk about what's not good to outsource.
No, I think on the previous thing you guys mentioned around, I'm a team with 2 million in TVL, right? I think like we as security practitioners like need to understand that security is an afterthought, right? It is something that you bring on after you see some level of like success in your business in the first place, right? If you have nothing to secure, you shouldn't spend on security, obviously, right? Now, $2 million is probably something that you should spend on. Like it's a meaningful amount of money where you should probably be spending on security if you have that, right? And so, and I 100% agree with your like vCISO analogy, where it's like you don't need to hire, you don't need to build these teams. You probably would be better off if the amount of money you would want to spend on a CISO for bringing on, right, for $2 million, better spent on a vCISO that fractionalizes and does a lot of these different things, like for sure.
I think that there's you mentioned like doing that for smart contract audits, and I totally agree with you. That's great. But when it comes to like building products or even like an L1, L2, if you don't really have like an expert in-house or even like fully dedicated to understanding the development roadmaps, the team cultures, their inner pains. What are the most critical components? What's missing there? Is it just, security testing? Is it complex design? If you don't really understand the inners of those development teams and integrate very closely with them, you won't be able to help, right? So Chris, I'd love to hear your experience in that sense.
Yeah, I think, probably difficult to sell, but I think the most important thing you should do, doesn't matter if you're small, you're big, you're one person, you're 10 people, you're $1 million, you're $5, is just understand what is your risk profile. Like literally understand, okay, what is the worst thing that can happen and how could that happen? Just answer those two questions. What is the worst thing that can happen to me, and how could this happen? And once you understand that question, then you start making a plan and figuring out, okay, should I be spending in people to hire security folks? Should I just be doing an audit? Like the worst thing that can happen is a smart contract hack. Okay, then just do an audit. A couple of them, hopefully, then you're okay. But if the worst thing that can happen is an employee being compromised, a laptop being compromised, my AWS system being compromised, no, you need to understand what is that risk profile so that you can actually allocate resources appropriately to that. And then measure it. No, hey, if this happens, am I going to lose $10 million? Then maybe hiring for 200 a year or 300 a year, a security guy, it's worth the money, You just need to do those economics.
In Web 2, one recommendation we have is that enterprises need to have a threat profile, right? They need to understand what are the threats facing them, what attackers would come after them, what kind of tools would they use, the TTPs, tool tactics and procedures, what does that look like? And we encourage them to make that a constant reevaluation, right? You don't just make it once and it's good for 5 years. You actually need to sit down and reevaluate as technology changes, as the world changes, as there's new types of threats out there. You need to reevaluate what does your threat profile look like so that you can protect your organization. It's one of the sad things about Web 3 to me is in Web 3, a compromise can be catastrophic for an organization, but security is not taken near as seriously as it should be. In Web 2, compromise is traditionally not as catastrophic for an organization, but a lot of them take security much more seriously.
I think this is a really interesting point on just like how liquid vulnerabilities or exploits or like security issues in crypto are compared to like Web 2. And I'm sure you've like heard of this kind of analogy, but like, it's crazy. You find a vulnerability, like even a 0 day in like in Web 2, and if you want to go and actually weaponize that to make $1 million, pretty darn difficult to do. Like you have to start like building malware around that. You have to go deploy it in some kind of operation. You gotta find data that's worth money to sell, or like wrap a ransomware around it. And then and now you can start kind of going and doing these things. That's a ton of work beyond just finding the vulnerability. In crypto, it's insane. Like you find a vulnerability, you make $1 million. Like it's basically that simple.
You know what I find just amazing though? Sorry, this is this weird thing in crypto that I don't feel like happened as much in Web 2, and maybe it does have a bit more, where like a protocol gets hacked in crypto, loses a bunch of money, and I feel like a month later, they're back at it and it's fine. Like everybody there's such a short memory in crypto that like, oh, they fixed their problem. Let's just give them more money and give them another, go ahead, take another spin of the wheel. That to me is, like, it's like they just don't care about reputation as much as I wish they would. Like, I know web companies that would have just completely died after a major hack, right? Except for hotels, because I think every couple months I get a thing saying my private data is gone from whatever Marriott, or, sorry, I probably shouldn't say company names. Leave that out. Company X, or, yeah, anyway, sorry, I did, yeah.
You get free credit monitoring for life, okay?
I have
just don't worry about it.
so much free credit monitoring.
So we're talking about like the financial side of things, Crypto startups, they're typically born as sometimes with like $200 million already locked in. But what are the other specific aspects that makes these problems very, very special and critical for crypto companies? One of the things that comes to my mind is whenever it's done, whenever a transaction is signed and sent into the network, it's not reversible, right? So that's one thing. What else do you guys see that's special to crypto?
Yeah, I think if you compare between Web 2 and Web 3 type of companies, in the Web 2, mostly the worst thing that can happen is like some PII data getting leaked, company reputation being affected, those type of things, database being leaked with a lot of confidential, sensitive, financial data, stuff like that. It is definitely catastrophic for a company, but in the end, the users are somehow protected. However, in crypto, you are losing not only your money, your VC's money, but you're also losing your users' money in most cases, because all these protocols are open to the public. Anybody can put money into it, anybody can put tokens into it, and a lot of these people obviously do it with very good intent, and you obviously have no idea about what the risk and guarantees are over here, and you're directly affecting the user, and that is the part that hurts me the most when protocols get hacked and everything else, is that it's mom and dad and your grandma and the lady that cleans your house that because they cannot access a JP Morgan account or they cannot access buying stocks, they do it through crypto because that's the only access they had, and you just lost that $1,000, $100 that they've saved that whole year. And that's the unique thing that is also horrible when there's a hack.
To Chris's point, I think the long and the short of it is the only real difference is the crown jewels change for the organization, right? I think you said this well. Like, it's in Web 2, it's databases, it's data. Like, that's mainly it, right? Obviously, the reputational risk of that is probably shared across these two things, but the crown jewels are the data. And in crypto, the crown jewels is money. And so that's so now just okay, what's the difference between having money that can be lost versus having data that can be lost? Those are the real differences. But ultimately, that's the main change.
I think though it's going to get worse as we. I don't like to say that.
This is not a fun panel. So sorry.
We're full of happy people, right?
So Bitcoin will get even lower. That's what you're saying?
Well, I'm saying think about it as things like DePIN take off. Right? As we get more real-world assets tied to crypto, that means that the implications of a crypto compromise get more significant, right? Unless there is, secure design thought out in the beginning of an expectation when we get compromised, how do we protect these assets? But if you are storing things on chain or have an integration on chain that has a direct correlation with real world physical assets and infrastructure, what happens when that gets compromised and it's on an immutable blockchain, right? That's a whole different level of implication that we as a community really need to think about and seriously consider.
Yeah, I mean, there's a bit of a happy note, because it has been a little bit of a down note.
Sorry.
A lot of the compromise that we've seen, I mean, if they just had, so I don't want to simplify, but in a lot of cases I look at it and think, if they just had someone there in security, it's a lot of really bad mess ups that lead to a lot of lost money, whereas it probably could have been avoided almost entirely. I'm not convinced when people come up here and say, oh, you can't avoid being hacked. If you're going to get hacked, assume you're going to get, yeah, we assume we're going to get hacked because it's kind of part of the game, we have to be prepared we get hacked. But, I mean, there's plenty of protocols that never get hacked, right? And maybe it's because they have a great security team, maybe not, I don't know. In some cases, I know it's because they have a good security team. In other cases, they're just lucky. But take an example, the Bybit hack. That was avoidable. Come on, guy. There was things that they could have done to avoid that one on several layers. Just about every single one. Bouncer, they could have avoided on several layers. You look, in retrospect, it's of course easy for me to say that, but someone with a lot of security expertise probably would have spotted that stuff before, right?
But we're also expecting companies to go up against nation states. And that's what we have to keep in mind, right? It is asymmetric, right? And so I think that we need to push folks to do more, but I don't think we should shame folks for being compromised unless there's clear missteps that are they didn't do industry best practices. They didn't care about XYZ. We should push them to do better, but we also need to acknowledge it is an environment where there's some very strong adversaries.
I disagree. So I don't think you should shame individuals, but I think you should shame companies. Because while the individual can make a mistake, if you're looking for a job, it looks like a great interview, and you get pwned by North Korea, yeah, that sucks. But there are so many things about that story that could have been like, did you have EDR on your machine? Like, did your security guy set you up for failure? Did he give you training? So yeah, the individual maybe we don't blame, but the ecosystem and the companies, they should be held accountable. Like they should.
I do
be
believe
like,
there should be accountability.
Yeah. Okay.
Yes.
Thank you. I'm glad we agree
I'm not against
'cause-
accountability, right? I just one reason why I say all this is because in Web 2, there's not near as much sharing of compromises as there should be.
Oh, yeah, no,
and part of that is because if someone shares that they were hacked, right, what benefit is there for them? And that's one thing you really have to consider. In Web 3, there is an incentive to share that there was a compromise. First off, it's hard to hide it because blockchains are transparent, right? At least for the most part. And so there's some incentive to share it because they want to protect their reputation. But also, if there's a massive heist where billions of dollars are stolen and that money gets dumped out through OTC vendors near North Korea, that's going to cause a dip in the market. And as well as it's going to make people unhappy and it's going to make them feel like they don't trust the system. And so there's an incentive to share to protect the whole ecosystem. And that's why, again, I advocate that if we make security cool, right?
It is cool. What are you talking about?
And we make it so that, when people share how they stopped a hack, right? Or they were hacked, but here are all the details, the indicators, et cetera, then that can cause a rising tide lifts all ships, right? Raise the floor of security.
Yeah. So one thing is like we kind of like, I'd love to see more celebrations of the things we prevented rather than the, like the postmortems are great and the fusion of funds, all wonderful stuff. But I don't think we celebrate enough the stuff that doesn't go wrong.
I agree.
Yeah, here in this talk, basically, and in the whole day, you see all the biggest hacks, discussion about how they happen, and that's very useful for lessons learned and everything else, but I think you're absolutely right. We should actually also talk about, like, how did we prevent this hack? Unfortunately, because in the world of automation and now in the world of AI, we may not even know that we prevented a hack. We just put some tools over there, we put some strategies on those tools, we follow our operations, our standard operating procedures and stuff like that, and potentially we blocked a lot of hacks that we never noticed that we actually blocked.
So there's a lot of technology being built on top of that. Some of the guys are around here probably, bitfinding.com. They recently, a couple of week ago, maybe, they rescued like $1 million from the balancer attack. And really what they did, and I think that's, I think what they do is really, really cool because they keep scanning monitoring the chain whenever they see, some contract that's being deployed that they detect that, there's some patterns, some heuristics there that implies that it's likely an exploit. They start fuzzing it and they try to call the smart contract before the attacker does so. And that's how they actually took the funds. And that's a very different way to do it. But speaking about technology and monitoring, on-chain monitoring to prevent attacks, Ido, I'd love to hear from you. What's your perspective on that?
So, I think it's like an evolving landscape, right? It's there's always like these new tactics, procedures, right? And so you have to stay really, really up to date on kind of the latest and greatest threats that are happening across the ecosystem. I also think that it's incredibly difficult to go in, and I think it's easier to do this on like one chain for one ecosystem for one kind of thing, and it becomes incredibly hard to go and do this across a lot of different chains for a lot of different ecosystems for a lot of different types of companies. And I think we're really lucky to have incredible partners that push us in the right direction, right? So we work with some of the largest protocols, we work with some of the largest chains, work with some of the largest wallets and asset managers, and at the end of the day, they go and tell us what to build, and that's what we ultimately end up doing. And so I think that I really like your guys' idea about like, the panel next year should be, let's talk about the $1 billion that wasn't stolen this year in crypto, right? Because there are good teams and there are, we have great partners that do a lot of work to ultimately prevent a lot of these different things, right? We've seen things like, after the Bybit hack, right? We have like a newer product that basically, verifies transactions before you sign them across various different MPC wallets or multi-sigs. And we've seen tons and tons of teams adopting these things, right? And basically telling us, hey, we need this, we want this, and then going and using them. As well as, other kinds of solutions as well. And so I think ultimately, like, I agree with you that we need to definitely highlight what the industry does well in order for that to percolate to other teams that probably do it poorly.
I just feel like it won't get as many likes on X. Like
That's a different problem for a different panel. That's the algorithm.
So people talk about open source being, not secure. It's open source, it's out there, an attacker can see it, but at the same time, people can just, be auditing. So there's like this kind of contrast between it being more secure or less secure. How do you guys see it, and specifically when it comes to crypto projects?
I think in the long run, security by obscurity never works.
Yeah, no, I agree. I like the idea that if you build a secure product, like most of the cryptography algorithms from years ago were always like open. Like you could read the entire algorithm, you could understand exactly how it works, and you still couldn't break the codes, right? Because like triple DES, like everybody in the cryptography kind of area, they understood triple DES, you looked at the whole thing, couldn't break it. It should be the same thing with our DeFi protocols. The code should be open to everybody to read, and there should be a lot of eyes on it, which isn't in a lot of cases. That's what happens, right? But then, I don't know, I guess there is some argument for having closed source because if there is a vulnerability, you wouldn't want to be out there. I don't know if anyone wants to make a case for that, but I would prefer things being open.
I think there are areas where that definitely will benefit from being closed sourced or like private. I think I still want to have things that being open source and really public, but then make public the inputs, make public the outputs. Maybe don't make public how the inputs work into outputs, and just keep that little enclave, if you want to call it in some way, private. But there's still, if we start building closed source, then we haven't made anything better in the world. Like we're just going back to Web 2.
It's ultimately like the Apple and Google debate, right? It's like, Apple is security by obscurity. Google is like fully open sourced Android, right? What's more secure, right? What's the perception of what's more secure? As someone who spent time, 6 years like researching vulnerabilities for mobile devices, like it's freaking hard to find a vulnerability in like fully patched Android. It's also hard to find in iOS for what it's worth. But nothing's really closed source. Like if you have the binary, like you can do a lot. And so I think like even on chain, right? Like if people start deploying closed source contracts or stuff like that, it's not really closed source. Like you just like have a harder time reading the source.
Yeah, good point.
Guys, but let's face it, incidents can happen, right? So Joe, what's been your experience in like responding to an incident specifically in the realm of crypto? Like what you see that it's different when responding to an incident in crypto. Things happen extremely fast. At oftentimes you don't have enough information. What's different, and how do you guys have approached it?
I think one of the biggest points is that speed is much more important in crypto. It's still important in a Web 2 compromise, but in Web 3, speed is so much more important because of that immutability of funds, of transactions on chain, right? And so there has to be awareness, there has to be monitoring, and folks need instant response plans, right? So many organizations don't have them. They think that they can just call up someone on, incident happens, they email someone, they call up someone, say, hey, I need someone to come do instant response. And what if there's not availability? And that happens, right? If there's no SLA, no service level agreement, there's no guarantee that someone is going to be there to answer the phone when you need help. I would say that's one of the biggest differences is time matters much more.
That is one thing I encourage protocols to have, is to have some sort of retainer with an organization to help you with instant response. Because exactly to Joe's point, if you were to message Mandiant and set it to an emergency, say, hey, we need you now, and they're like, yeah, we're backed up. We'll call you in a week and we'll send over the SLAs to sign, and then it's like, well, that's way too late. It's hard to justify. Like when I go to my CTO and say, hey, I need to spend this money on just in case we get hacked, because he's like, well, we're not going to get hacked, right? I'm like, well, I don't think so, but if we do, we want to be able to call someone super fast and have them tracing funds and have them responding. And there are some good companies out there that do that. You could DM either of us, and we could put you in touch with companies that are there to help that sort of thing.
I would say they're not that different, to be honest, Web 2 versus Web 3 incident response. And the problem is that we think that we need to execute incident response once the smart contract is hacked or, or manipulated or something like that. But in the end, having a security team, having somebody that thinks like a security guy, pessimistic and so on, is going to help you, because there are always indicators of compromise, always. Somebody is starting, we see it in the Polygon blockchain, for example. We see people deploying, contracts, and they've been funded by Tornado Cash, and then that's starting to be an indicator of compromise. You start seeing people that are sending you messages asking you, hey, why does this function behave this way? Why does this function behave the other way? There's always, and that's what security teams do. They're monitoring these things, and they're actually the ones that can tell you, like, actually this guy asking this question may be malintentioned. He may not be asking it because it's integrating. He's actually asking it because something like that. And you see that across a lot of the hacks. You end up, when you start looking at the breadcrumbs of a hack, you start seeing, oh, this guy actually went to the forum and he started asking about this like a month ago. And then you see that this same address was actually deploying contracts on a test net. And obviously you cannot see, what the smart contract was doing, but you can decompile the bytecode and stuff like that. So there's always little breadcrumbs, like, nobody's perfect. And in the end, this is all done by humans so far. All the hacks. So, you are always going to be able to start initiating your incident response process, hopefully before the hack is happening, or at least keep that in mind. So when the hack happens, you already know, like, yeah, I saw this coming.
There's something they do in Web 2 security that we did a long time ago that is, I don't think it's totally made it into Web 3 yet, which is the hunting aspect. So when you have a dedicated security team, when they have nothing else to do, because, well, first of all, they're almost always busy, but when there is free time, you can start hunting for activity. So you're not waiting for alerts to come in. You're actually making hypotheses like, maybe contracts funded by Tornado Cash are more likely to be malicious, so let's go and find all this stuff, right? Let's go and look for all those emails, all those phishing emails that my employees are reporting. Let's actually go through a bunch of them and see, like, how many of them are likely North Korean, how much are likely e-crime, how much are likely, something else, and who clicked on it. Like, if you don't have someone dedicated to security, that's just not going to happen. Like, no one is there to look at that stuff. Sorry,
and you can hire for that. Sorry.
I was going to say, to build off what both of you are saying, everyone is aware of the defender's dilemma, right? You have to protect everything. If the attacker finds one thing, then it's all over. Well, there's also the attacker's dilemma, and this is what a lot of folks don't think about. If the attacker sets off one alarm and there's someone watching, then the gig is up, right? But there has to be someone monitoring and watching in order to see that alarm go off.
And put in the traps, put in the alarms, like, in Web 2 we do a lot of these things, honeypots and those type of things. So a lot of hacks can be preventable. You can actually get indicators. I was going to say, talking about the threat hunting or red teaming and things like that, you don't even need a security team for that. No, you can ask your own auditing company. Normally, I think that most of you, if you ever hired an auditing company, and I see a lot of auditing companies over here, you probably get like, hey, here's a bunch of contracts. Do your work. I don't know what it is, just do it. But in the end, you can actually tell them, like, please focus on these areas. No, maybe not for the first audit, but the second, the third, the fourth. You're actually going to tell them, like, I actually want you to focus on these functions because these are the ones that are most, this is the critical path and this is what I want to cover. And then the third audit, you're going to go and like, I want you to start through this with these type of assumptions. No, think this way. Please plan, your threat models in these areas. And that's going to help you build a much better, threat landscape as well as, plans if some of these things happen.
Right. So what is your last message and probably the most important message that you'd like to leave to the founders out there?
So mine's really easy. If you do not have a security person and you take care of other people's money, go hire a security person. Like, you are holding on to other people's funds. You should just go out there. There's tons. And if anybody tries to say it's hard to hire security people, I'm in like this Web3 chat, several of them, full of security people looking for jobs, right? I don't know where the disconnect is, but there are a lot of people out there in the security, especially in Web3, who would love to be offered a job. They just don't know who to talk to or how to apply, or I don't know what the disconnect is. But anyways, go ahead, Joe.
The thing that I hope folks take away is awareness and education. I think that we need a lot more awareness and education around security for startups, for founders, and that will lead to a much safer ecosystem.
I think I'll say security is not difficult nor expensive, and I think that's a misconception. With security in Web3 is not different from security in Web2. Like, please go and ask. I think people are just afraid of asking. Ask for help. Like, you can even get it for free. You can get audits for free. You can get a security review of like your website for free. There's a lot of people that are really willing to help. And at least, in this panel, I think nobody here would say like, no, I'm not going to help you. I'm sure I can find somebody that's going to help you with your problem in the budget that you have and in the time that you need it. So don't be afraid of asking.
Yeah, maybe I agree with everything you guys said. You guys, I think super insightful. Maybe that security, I think in this industry, is not a cost center. It can be a differentiator. And when leadership looks at kind of security practitioners like to bring you on and doing these things, they should probably think about, okay, great, maybe if I have head of security, I'll get more assets deployed in my protocol. Maybe if I leverage this kind of solution or that kind of solution to go and kind of bolster security, I will actually be safer and I will actually increase TVL, or I will actually kind of generate more revenue. I think it's especially true for financial infrastructure and especially true for the infrastructure that's being built across the industry.
The real cost center is getting compromised.
That's company ending.
All right, thanks everybody.
Thank you.
Thank you everybody for joining us today here in Buenos Aires and back at home. DSS will resume tomorrow.
Tonight we